Okay, let's unpack this. When we talk about professional life, um, few roles are as universally critical and, let's be honest, often misunderstood as the project manager.
Mm-hmm.
We've all seen those job descriptions, right? Listing responsibilities. But what does it really truly take to supervise a complex project effectively? Especially in an environment where, goals can be fluid, organizational barriers are surprisingly high, and resources, well, they always seem scarce.
That's the constant battle, isn't it?
Exactly. And we've received a really fascinating, quite rigorous stack of source material today. It dives deep, and what I like is that it focuses less on the methodology charts and more on the kind of organizational friction points,
Hmm.
the things that really make or break success.
Yeah, the human element, the structural element.
Our mission here is to get that insider view. We want to go beyond just the basic definitions of time and cost. We want to understand the modern reality,
Yeah.
leading without much formal authority, navigating corporate politics, and, most critically, appreciating this massive paradigm shift that seems to be underway.
It's huge.
It's no longer enough just to deliver a product or a service or a piece of hardware. The central, unavoidable focus for any modern project has got to be the measurable creation of sustainable business value.
That phrase, business value, is key. And what's fascinating here, as you said, is how the source material really forces us to redefine what a project actually is. It's not just like a list of tasks you tick off.
Right.
It is fundamentally a disciplined series of activities, specifically designed to achieve a specific objective. And that series of activities is characterized by 5 pretty strict constraints.
Okay, let's nail those down right now because they really set the foundation for, well, all the challenges seem to follow, don't they?
Absolutely. So
Yeah.
first, the project must have that specific objective we just mentioned, that creation of business value. That's number one.
Got it.
Second, it absolutely must have defined start and end dates. It's temporary by nature. It can't just go on forever.
Finite.
Third, it has to operate within defined funding limits, if applicable. Now, funding, interestingly, is often the most, shall we say, malleable of these constraints in practice.
Yeah, I bet.
Fourth, it must consume organizational resources. That means both human resources, people, and non-human resources, like equipment or facilities.
Makes sense.
And fifth, and this is really where the complexity starts to explode, it must be multifunctional. The activities are intentionally designed to cut across multiple existing functional lines within the organization. Engineering, marketing, finance, they all have to play together.
Okay, that fifth point is huge, isn't it? Because the second you move outside a single department silo, you leave that sort of safety of the vertical command structure, and you land right in the messy world of cross-organizational dependency. Everything gets complicated.
Precisely. And the immediate implication of that 5-part definition is the emphasis it puts on rigor. Projects can't just be, personal whims or somebody's pet side endeavor.
Mhm.
They absolutely must be selected through a formal initiation process. Why? Because they represent the best opportunity the organization has to deliver that measurable business value, especially given all the constraints on organizational time and resources. You can't do everything.
So selection itself is a strategic act. So if that's the nature of the project, temporary, resource-consuming, cross-functional, aimed at value, how do we impose some kind of order on that potential chaos?
Well, that's where project management comes in.
The definition itself, project management, is essentially the systematic application of knowledge, skills, tools, and techniques needed to meet those project requirements we just talked about.
Exactly. It's the how.
And the global standard for this, the framework our source material consistently refers back to, is the Project Management Institute's PMBO guide.
Right, the PMBOK. And it's probably worth taking just a second to clarify that term for anyone listening who might be new to it.
Good idea.
PMBOK stands for the Project Management Body of Knowledge. Think of it as a globally recognized standard, a sort of encyclopedia that organizes all the work of managing a project into 5 essential process groups.
Okay.
Now, the source material is really quick to point out, and this is important, that while these 5 groups establish the baseline methodology, the specific activities within them have to be customized.
So it's not a rigid one-size-fits-all template.
Not at all. It has to be tailored based on the unique requirements of the customer, the specific industry you're in, and the nature of the project itself. No 2 projects, even if they're using the same PMBOK framework, are ever exactly alike.
Okay, let's break down those 5 phases, those process groups. But maybe rather than just listing them, let's try to discuss the core difficulty or maybe the key decision that happens in each one. Because they really span the project's entire life cycle, don't they?
That's absolutely the right way to look at it. They're not just sequential steps, they overlap and interact. So we start with project initiation. Now, this isn't just, a kickoff meeting with donuts. This is the crucial high-level stage where we first recognize the potential benefits of doing the project at all, the why.
The business case, essentially.
Precisely. We select the best project opportunity, especially critical when an organization might have, say, 5 really good ideas, but only have the resources, the budget, the people for maybe 2 of them.
Right, prioritization.
And then, crucially, we prepare the necessary documents that formally sanction the project. Think of it like getting the official green light. The sanctioning documentation, often called a project charter, is what gives the project manager their initial, often quite limited authority to actually start moving forward.
Okay, so initiation sets the stage and grants permission. What comes next?
Following initiation, we hit project planning. Now, I think most people probably associate project management with Gantt charts and schedules, which happens here.
Yeah, that's the common image.
But planning is really fundamentally about defining requirements in detail and trying to anticipate problems, isn't it?
Sounds like the heavy lifting part.
It is absolutely the most intensive stage, hands down. This is where you define the exact work required, the scope. You nail down the quality and quantity requirements. All the detailed scheduling happens here.
Okay.
But the truly critical task in modern planning, the one that often gets underestimated, I think, is the rigorous evaluation of risks.
Looking for what could go wrong.
Exactly. If risk evaluation isn't done properly and thoroughly at this stage, the project is almost certainly being set up for failure later in execution. The plan has to serve as a roadmap, yes, but it also needs to function as a kind of early warning system for all the potential organizational and technical hurdles ahead.
So a good plan isn't just optimistic, it's realistic about challenges.
It has to be. Then, once we have that detailed roadmap, hopefully with those warnings built in, we transition into the implementation phase. Project execution.
Getting
it done. And here, the PM is maybe less like a drill sergeant barking orders and more like an orchestra conductor trying to get everyone to play together harmoniously.
I like that analogy.
Execution involves the actual heavy lifting, directing, and managing the work as it happens. But the PM's diplomatic role becomes absolutely central here. This stage requires negotiating for team members, something we'll definitely dive into more later because it's a huge pain point.
Oh, yeah.
As well as working with the team members, coaching them, mentoring them, trying to ensure continuous process improvement along the way. The PM isn't just directing tasks, they're often clearing bureaucratic obstacles so the team can actually do the work.
So facilitation and problem solving are key during execution.
Huge. And running concurrently with all that effort, almost in parallel, is the 4th phase. Project monitoring and control. Think of this as the project's organizational rearview mirror and its steering wheel combined.
Keeping things on track.
Exactly. It's the constant checking mechanism.
Right.
This process group involves tracking the actual progress, what's really happening, which must then be formally compared against the predicted planned outcome from the planning phase.
Measuring the gap.
Measuring the gap. Any variances, any deviations from the plan in terms of time, cost, or scope, they have to be analyzed for their impact. How bad is this deviation really? And then necessary adjustments must be made. This is where the PM truly earns their salary, by ensuring that the inevitable small deviations don't snowball into catastrophic train wrecks.
Right, course correction. And finally, after all that, we have project closure. Now, this seems straightforward on the surface, but I have a feeling it's probably more complex than just declaring the product finished and having a party.
Oh, much more complex. Proper closure is often rushed or skipped, unfortunately. It requires verifying that all the technical work has been fully accomplished and meets the requirements, yes. But it also necessitates navigating multiple administrative hurdles.
Like what?
Well, this includes things like formal contractual closure with vendors or clients, financial closure of the charge numbers, and that's a key term.
Charge numbers.
Yeah, those are the specific accounting codes used to track every single dollar, every hour spent on the project. You have to close those out properly. And then there's the administrative closure, archiving all the documentation, capturing lessons learned for future projects.
The lessons learned seem crucial but often forgotten.
Critically important, yet frequently overlooked in the rush to the next fire. Skipping any of these closure steps means the project can kind of haunt the organization for years, especially when it comes to things like financial audits or trying to estimate similar projects in the future accurately.
Okay, so those 5 groups: initiation, planning, execution, monitoring and control, and closure form the ecosystem. When you combine them and, crucially, execute them effectively, the definition of successful project management becomes quite rigorous, doesn't it?
It really does. Success isn't just we finished. It means achieving a continuous stream of project objectives within those specified constraints of time and cost, performing at the desired performance or technology level while utilizing the assigned resources effectively.
That's a lot already.
And maybe most importantly, having the final results fully accepted by the customer and all the other relevant stakeholders. Acceptance is key.
Acceptance, right. So what are the payoffs? If an organization actually manages to implement this structure correctly, what benefits do the sources say they typically see?
The benefits, when done right, are often underrated, I think. When the organization standardizes its approach using these kinds of processes, the sources show clear gains. For instance, you get a much clearer identification of functional responsibilities.
How does that help specifically?
Well, it's vital because it minimizes disruption when you inevitably have personnel turnover. If Jane from marketing leaves mid-project, the documented project responsibility ensures her work doesn't just stop or fall through the cracks. Someone knows what needs to be picked up.
Ah, continuity. Okay.
You also gain significantly improved estimating capability for future projects. Why? Because you've actually tracked historical performance data accurately on past projects, time, cost, resources used.
Learning from history.
Exactly. And on the proactive side, as we touched on with planning, these methodologies are really designed to serve as early warning systems.
Spotting trouble early.
Absolutely. You gain the ability to identify problems much earlier in the project lifecycle, which allows for timely and usually less costly corrective action. Or, critically, you gain the knowledge to know when objectives simply cannot be met within the current constraints.
Or maybe when they'll be exceeded.
Or, conversely, yes, when they might be exceeded, allowing you to maybe reallocate resources. It lets management make informed gonna-go decisions or pivot decisions before sinking even more resources into what might be a losing proposition or an unnecessary gold-plating exercise.
Okay, those benefits sound compelling, but you can't really reap those benefits without facing some pretty inherent obstacles, can you? If project management is fundamentally a tool for achieving change within an organization, it often seems like it's fighting against the built-in DNA, the established structure of that same organization. What are the sort of built-in hurdles that the sources consistently warn project managers about?
Oh, the obstacles are relentless, and they come from all directions. They include just the inherent complexity of the project itself. Some things are just hard. You have customers who bring special requirements, or worse, continuously changing requirements. Scope creep is a killer.
Always a battle.
You face organizational restructuring that might happen mid-project, completely moving the goalposts on you. There are always unavoidable project risks, technical risks, market risks, resource risks. You have rapid changes in technology that can suddenly render your carefully crafted plan obsolete overnight.
Yeah, tech moves fast.
And then there's just the sheer difficulty of accurate forward planning and pricing, especially in an uncertain, volatile business environment. It's like trying to navigate a ship through a storm while the destination keeps shifting. It's a structure, project management is, designed to maintain stability while simultaneously forcing radical change. It's inherently contradictory in some ways. And this inherent tension brings us to a really crucial conceptual understanding of how resources, especially people, must be utilized across the company for projects to succeed. Project management methodologies, like PMBOK, are explicitly designed to maximize the efficient use of those scarce resources. How? By requiring work to flow horizontally across departments.
Horizontal flow.
In addition to the traditional vertical top-down flow of the hierarchy.
That structural split is absolutely key, isn't it? I sometimes like to think of the vertical structure, the standard org chart, the hierarchy, as the spine of the company. It's necessary for stability for daily operations.
Good analogy.
But the horizontal flow required for projects, that's more like the nervous system. It's the rapid communication, the coordination needed for change and complex initiatives.
That's a perfect metaphor. The vertical bureaucratic flow, that's the traditional chain of command, the sustained operational responsibility that remains the sole responsibility of the line managers, or functional managers as they're often called.
Right, the department heads.
Exactly. That structure is what controls the day-to-day functions, the hiring, the firing, the promotions, the core career progression of basically every employee in the company. It's stable.
Okay.
However, The horizontal flow, that critical communication, the coordination, the integration between those various line organizations, that is explicitly the responsibility of the project managers.
So PMs bridge the gaps.
They bridge the gaps. And this approach, importantly, ensures that the project gets done without completely dismantling the existing vertical hierarchy, which you need for ongoing operations. It simply forces, or tries to force, cross-organizational collaboration.
Yeah, it tries to force. It feels like the operative phrase there. Because forcing collaboration is often easier said than done, isn't it? Especially when you hit what the source material vividly calls organizational gaps.
The gaps?
You've got the management gaps, differences in rank, prestige, maybe reporting lines, and then you have the functional gaps, those hard boundaries between departments like engineering, marketing, finance. When you combine those, well, you get this powerful analogy the sources use. The company being composed of small operational islands.
The operational islands analogy is so effective because it just perfectly captures the political reality inside many organizations. These departments, these functional areas, they often maybe not refuse outright, but certainly resist communicating efficiently cross-functionally.
Why? What's the resistance about?
It's usually rooted in fear or maybe internal competition.
Wow.
Departments worry that by sharing information too freely or giving up their best resources or even just admitting they need help, they might inadvertently strengthen their internal opponents.
Opponents meaning other departments.
Yeah, another functional area that they might be competing with for things like executive favor or next year's budget allocation or simply organizational prestige and influence. It's an internal competitive landscape that the poor project manager is forced to navigate constantly.
Wow. So the PM isn't just managing tasks and timelines. They're effectively acting as a chief diplomat and a kind of bridge builder between these warring or at least competing islands.
That's a huge part of the job. Their core mission, beyond the technical stuff, is to overcome these gaps, to somehow cajole or persuade these naturally resistant islands to communicate, share, and steer towards the common defined goals and objectives of the project.
And that takes some pretty specialized skills, doesn't it? The sources explicitly note that the PM often needs a different set of interpersonal skills for each different island they have to deal with.
Absolutely. Think about it. The kind of negotiation required to secure cooperation, say, from the R&D team, who might prioritize technical perfection and innovation above all else, is going to be wildly different from the skills you need to negotiate a really tight, maybe seemingly impossible timeline with the manufacturing department, whose main focus is usually throughput, cost reduction, and predictability.
Different cultures, different priorities.
Totally different cultures, exactly. The PM has to adapt their communication style, their arguments, even their body language, to align with the internal culture and the core priorities of each functional group they need something from.
And this whole challenge leads us back to a crucial, almost structural, weakness, often inherent in the PM's role. The lack of real authority.
Right.
If we look at the classical functions of management, the textbook stuff, planning, organizing, staffing, controlling, and directing.
FAL functions, yeah.
Right. The traditional definition of project management, as the sources point out, for the longest time conspicuously excluded one of those major functions.
That's the absolute key distinction, the one that often hobbles the PM's authority right from day one. The traditional definition of project management, planning, organizing, directing, controlling company resources for short-term objective omits the staffing function.
It omits staffing completely.
Completely in terms of direct control. The PM can plan the work breakdown structure, they can organize the tasks, they can direct the day-to-day activities, and they can monitor and control the results against the plan, all for that relatively short-term project objective. But they do not staff the project in the sense of hiring or assigning people directly. Staffing is considered strictly a line responsibility.
Okay, hold on. So the PM can figure out they need, say, Jane from engineering and Tom from marketing for their project.
Yep, they identify the need.
But they can't actually compel Jane's or Tom's manager to assign them to the project or dictate how much of their time they get.
Precisely. That's the crux of it. The project manager can request Jane and Tom. They can make a strong case for why they're needed. But the final decision on whether those specific resources are committed, who gets assigned, and for how long, rests entirely with the functional line managers who actually control those employees' careers, assignments, and ultimately their paychecks.
Wow. That severely limits the PM's control over the actual personnel doing the work, doesn't it? And frankly, it seems like it puts their project's ultimate fate partly in someone else's hands.
It absolutely does. It means the PM must operate constantly through negotiation, persuasion, influence, maybe even calling in favors, rather than by issuing direct mandates. They can't just order resources, they have to win them over.
That sounds exhausting. And just a quick note on that phrase we used, relatively short-term project. The source material wisely reminds us that the definition of short-term is completely dependent on the industry, right?
Oh, totally. What might be considered a standard 6-month to maybe 2-year project in, say, engineering or construction? Well, that could be just a 2-week sprint in the insurance industry, maybe designed to update a single claims process.
Right.
Or, at the other extreme, you could have a project for developing complex nuclear components that might span an entire decade. So it's really the complexity, the need for cross-functional integration, and the specific objective, not necessarily the mere calendar length, that drives the necessity for applying formal product management methodology.
Okay, let's shift gears slightly and talk about success. How do we know if a project actually was successful? For decades, the measure seemed pretty simple, didn't it? It was often visualized as that iron triangle, achieving the project objectives within the 3 big constraints of time, cost, and performance, or scope.
The triple constraint. Yeah, that was the mantra for, 30 or 40 years, maybe more. And while that absolutely remains the foundation, you can't ignore time, cost, and scope. It's become increasingly clear that it's just insufficient for the modern corporate environment.
It's too narrow.
Way too narrow. The sources immediately introduce the potential, and often critical, 4th constraint, particularly important when you're dealing with external projects or clients. Good customer relations.
Keeping the customer happy.
Exactly. And the research points out a stark and sometimes painful reality. You can deliver a product or service perfectly on time, exactly on budget, and meeting every single technical specification, and still manage to alienate the customer so badly through poor communication, arrogance, or inflexibility
That they never hire you again.
Precisely. So in that scenario, the project was technically a success according to the old triple constraint, but commercially, strategically, it was a complete failure. That relationship is a constraint too.
That makes perfect sense. And the modern definition, as outlined in the materials, expands the success criteria far beyond just those 3 or 4 elements. It moves into areas like organizational stability and even sort of behavioral criteria, doesn't it?
It really does. The modern standard still demands completion, of course, within the allocated time and the budgeted cost, at the proper performance or specification level, and with full acceptance by the customer or end user. That's the baseline. But then come the really challenging, more nuanced elements.
Okay, what are those?
Yes, the crucial, more organizationally focused criteria that really define true success today are things like, first, success must be achieved with minimum, or at the very least mutually agreed upon, scope changes.
So acknowledging scope creep happens, but managing it formally.
Exactly. The sources are very pragmatic about this. Scope changes are often inevitable. New requirements emerge, markets shift, technology changes, but those changes must be rigorously managed, evaluated for impact, and formally approved jointly by the PM, the sponsor, and maybe the customer to prevent the project from just becoming this uncontrolled, endless drain on resources.
Controlled change, not chaos. Okay. What else?
Second, and this is a big one that often causes friction, the project must be completed without disturbing the main sustained workflow of the parent organization.
Don't break the company while doing the project.
Pretty much. Project managers, especially good ones, often develop a kind of entrepreneurial mindset, right? They want to treat their project as this special, separate entity, maybe exempt from normal company procedures to move faster.
Yeah, I can see that temptation.
But they must manage their project within the existing corporate guidelines, policies, and procedures unless explicitly waived to prevent the project work from completely hijacking the core business operations or causing chaos elsewhere.
Organizational harmony, sort of.
And third, linked to that, success must be achieved without violating or fundamentally changing the core corporate culture.
Wow. Culture as a constraint.
Absolutely. Think about it. If the parent organization deeply values, say, transparency, employee safety, or open and honest communication, the project manager cannot just decide to violate those core values, even if doing so might shave a month off the schedule or save $1 million in costs. Success is intrinsically tied to maintaining the integrity of the company's character. Sacrificing core values for short-term project gain is ultimately a failure.
That is a profound shift in thinking. It really implies that project management is now seen as an act of, corporate citizenship, not just pure execution. The stability and the culture of the entire organization are now success constraints themselves.
Exactly. And this broader realization that success involves more than just time, cost, and scope drives us directly to the really important concept of competing constraints.
Okay, competing constraints. How does that differ from the triple constraint?
Well, the old triple constraint model sort of implies you're only managing trade-offs between those three things: time, cost, scope. Maybe you sacrifice schedule to improve quality or cut scope to meet the budget.
Right, the triangle trade-off.
But today, we realize that there are actually numerous secondary factors, things like project risk, customer relations, as we mentioned, the company's image, its corporate reputation, maybe even regulatory compliance pressures that can potentially at any moment become more important, more critical than the original primary constraints of time, cost, and performance scope.
Whoa, so the pressure points can actually shift dynamically during the project. We move from a relatively stable triangle to a much more dynamic, complex system of competing factors pulling in different directions.
Precisely. And this shift means the PM has to be constantly, strategically aware, looking beyond just their project's immediate metrics. Imagine, for example, a major corporate crisis erupts unexpectedly. Maybe a public safety recall involving another product line or a serious data breach hits the news.
Okay.
Overnight, the company's reputation might become the absolutely dominant constraint for all activities, including your project. Or maybe a new senior management team comes in with a mandate to prioritize rapid market entry above all else. Suddenly, time might completely override cost considerations for your project.
So the initial baseline plan, while important, isn't sacred.
It's useful as a starting point, absolutely, but the modern PM has to manage a much more fluid situation where these secondary factors can suddenly surge in importance, demanding that sacrifices be made on the original primary constraints like cost or schedule. It requires real strategic agility.
To illustrate just how powerful and complex this can be, we have that excellent example from the source material concerning the massive Disney theme park projects. Think Disneyland, Disney World. They weren't just juggling 3 constraints. The sources say they were actively managing 6.
That's right, 6 hard constraints. They explicitly define them as time, cost, scope, and then safety, aesthetic value, and quality.
Safety, aesthetic value, and quality. Okay, those make sense for Disney.
But here's the genius and also the horror for the project managers involved. 3 of those 6 were immediately declared upfront as locked-in constraints.
Locked in, meaning what?
Meaning safety, aesthetic value, and quality were completely non-negotiable. They could not be altered, compromised, or traded off, regardless of how difficult the project became or how much the costs were escalating.
Wow. So if a design choice was deemed even slightly unsafe, or if it just looked ugly by Disney standards or didn't meet their quality bar,
it absolutely had to change, period, regardless of the impact on the schedule or the budget. This meant that all the flexibility, all the potential sacrifices, all the necessary trade-offs that inevitably happen in a huge project like that had to be made exclusively on the remaining 3 flexible constraints.
Yeah.
Time, cost, and scope.
That dramatically increases the pressure on those 3, doesn't it?
Yeah.
The source material notes quite logically that when you increase the number of constraints you're juggling, especially fixed ones, up to 5 or 6, well, it becomes incredibly difficult, maybe even mathematically impossible, to perfectly satisfy all of them simultaneously.
It absolutely necessitates extremely rigorous and often painful prioritization. And importantly, that prioritization itself often has to change over the course of the project lifecycle.
How so?
Well, think about it. In the early initiation and planning phases, getting the scope crystal clear is probably paramount. What exactly are we building? But as you move into execution and that hard end date starts looming closer,
The pressure shifts.
the weight shifts, exactly. Time and cost naturally become the most critical constraints day to day. You might even be forced to make tough decisions to reduce the initial scope, descoping certain features just to meet that critical deadline or stay within the final budget. It's a continuous strategic calibration act.
This whole discussion of competing constraints, locked-in priorities, and the need for constant organizational diplomacy really leads us directly to the reality check for the project manager role itself. The sources really highlight a common misconception, don't they?
They do.
It seems many aspiring PMs, maybe folks moving into the role for the first time, believe they'll be granted vast authority. Like they picture themselves assembling and hiring their own dedicated dream team, having a direct line to the executive suite, calling the shots.
Yeah, the mini CEO fantasy, it's understandable, but the cold reality for most project managers in most organizations is that they operate with very little formal authority. The role is often starkly defined in the literature as leadership without authority.
Leadership without authority.
hmm
That sounds challenging. So where does the true formal power usually reside then?
It typically resides elsewhere. Often with the project sponsor, that's usually an executive who champions the project financially and politically, the one who ultimately owns the business case. And perhaps even more significantly day to day, power rests with functional management, the line managers who control the resources.
And the specific lack of authority in key areas is what creates so much of the friction and frustration, right? As we touched on earlier with staffing.
Exactly. As we established, the PM typically has no direct say in staffing decisions. That's a line function. And critically, this means they usually cannot fire a poorly performing worker who might be dragging down the entire project. That power rests with the employee's functional manager.
Wow.
They also often have no input whatsoever into the wage or salary programs or bonus structures for the very employees they depend on to deliver the project. They can't reward good performance directly.
That lack of control must become incredibly acute when you factor in the modern organizational reality, which the sources mention, of multi-project employees.
Oh, absolutely. The PM is constantly struggling, competing really, to get timely work-focused effort from individuals who are simultaneously working on 2, 3, or sometimes even 4 other projects, often for different project managers or their own line manager. Who gets priority?
Yeah, how do you ensure your project gets the attention it needs? Let's zero in on that resource issue more broadly. We've established that a typical company has, what, 6 primary types of resources it needs to manage?
That's the standard list, yes. Money, the budget, employees, people, equipment, facilities, materials, and information technology. Those are the core assets.
Okay. The PM is held accountable for delivering the project outcome using these resources. But as we're saying, they don't actually control most of these elements directly.
That is the absolute core conflict, the fundamental tension of the role. The PM does not directly control most of those 6 resources. The one exception might be, to some extent, the project budget they manage the money allocated. But virtually every other resource, the people, the specialized equipment, the lab space, the raw materials, even access to critical data is controlled by the line managers.
So the PM can't demand them.
No. Therefore, the PM must constantly negotiate for these resources. It's not a command and control situation, it's a perpetual negotiation model. That negotiation requirement dictates the entire nature of the PM's relationships within the organization.
The source material also brings up an interesting historical shift in sort of the PM's credibility or inherent authority. It mentions that decades ago, PMs were often engineers or technical experts with what's termed a command of technology.
Right, they were the technical gurus.
And that deep technical expertise apparently earned them a significant amount of respect, and line managers are often more willing to defer to their judgment and lend them resources.
Absolutely. That technical command acted as a powerful form of implicit informal authority. Line managers felt comfortable letting their employees take technical direction from the PM because they knew the PM deeply understood the what and the how.
Okay, but that's changed.
That has largely changed, yes.
Yeah.
Today, project management is recognized as its own distinct profession. PMs are often expert managers, skilled in process, planning, and people, but they might only possess a good understanding of technology, not necessarily deep, hands-on command of the specific engineering or software development involved.
They're specialists in management, not necessarily the underlying tech.
Exactly. And this shift, while professionalizing the PM role, has also somewhat eroded that inherent technical authority. It has necessitated, according to the sources, a concept of shared accountability.
Shared accountability.
Between who?
Accountability for the ultimate success or failure of the project is now seen as being distributed. It's shared between the project manager and all the affected line managers who provide the resources. It's not solely on the PM's shoulders anymore, at least not formally. Okay, that shared model sounds more realistic, maybe fairer.
Yeah.
It probably requires line managers to become much more literate in project management principles themselves, doesn't it?
It absolutely does. They need to understand the process. But even this shared accountability model doesn't fully solve the most damaging, practical element of the PM line manager interface, the loyalty problem.
Ah, the loyalty problem. Explain that.
The loyalty problem is perhaps the greatest day-to-day practical challenge for many PMs. Think about a typical functional employee, an engineer, a marketer, a designer, they report vertically up the org chart to their line manager. That line manager handles their career path, their annual performance review, their raises, their promotions, essentially their purse strings, as the sources put it.
Right, the person who really controls their future.
Exactly. But that same employee also reports horizontally, often to one or maybe even multiple project managers, for their daily task assignments on various projects.
Okay, split allegiance.
Split allegiance. And the sources are absolutely blunt and clear on this point. When push comes to shove, the employee will always favor the manager who controls their purse strings. Their loyalty, ultimately, lies with their line manager.
So if the line manager tells an employee, hey, forget that urgent project task for a bit, I need you to finish my critical operational report first, what happens?
The employee drops the project task and does the line manager's report almost every single time. How does the PM, operating with minimal formal leverage, practically overcome this fundamental loyalty gap? It's tough.
It sounds almost impossible without some mechanism.
This is where negotiation has to become formalized through organizational process, not just relying on the PM's personality or charm. Successful PMs and successful organizations have to ensure that project performance feedback is formally documented by the PM.
Okay, write it down.
And crucially, that the line manager is required by company policy to incorporate that documented project feedback into the employee's formal annual review.
Connecting the horizontal performance to the vertical reward system.
Exactly. If the employee knows that their line manager must consider the PM's documented negative feedback about missed deadlines or poor quality work when deciding on their raise or promotion, that creates the necessary leverage. It's about creating a formal paper trail that directly impacts the career path, thereby forcing a degree of horizontal accountability. It links the two flows.
That makes sense, institutionalizing the feedback loop. It's also fascinating how, despite this lack of formal authority, the PM is often seen, externally at least, as the organizational hero, right? The person who gets things done, the one who pulls it all together. The sources even mention the halo effect around successful PMs.
They get the glory sometimes.
Yet the sources argue, quite compellingly, that the PM is often really just the agent or the facilitator through whom resource efficiency is accomplished. And perhaps more of the credit should actually be shared with the line managers who provided, managed, and supervised the necessary resources doing the work.
And this tension over shared ownership, over who really deserves the credit, leads directly to that classic, often destructive conflict, the who contributes to profits argument.
The profit fight.
Yeah. Project managers sometimes feel they control all the project profits because they manage the allocated budget and the schedule to deliver the revenue-generating thing. But the line managers argue, quite rightly, that they are the ones staffing the project with the right skilled personnel, supplying the critical equipment, and supervising the actual work performance day to day.
So who's right?
The reality, and what executive-level management has to foster culturally, is that both are right. Both the vertical line organization, providing skilled resources and stability, and the horizontal project organization, integrating those resources for a specific goal, contribute equally and simultaneously to the company's overall profitability. One simply cannot succeed without the other in a project-driven environment. So, given all this, the constant political navigation required, the inherent loyalty conflicts, the need to hop between those operational islands, it's really no wonder that the modern project manager requires a far broader, more diverse skill set than maybe they did 30 years ago.
It's not just about Gantt charts anymore.
Definitely not. PMI, the Project Management Institute, has actually formalized this expanded requirement into what they call the talent triangle. It represents the 3 high-level essential skill sets required for today's truly successful practitioners.
Okay, the talent triangle. What are the 3 sides?
The 3 sides are, number 1, technical project management. These are the traditional hard skills, knowing how to do scheduling, risk analysis, budgeting, scope management, that sort of thing.
The mechanics of PM. Got it.
Number 2 is leadership. These are the crucial people skills, motivating teams, resolving conflicts, influencing stakeholders, communicating effectively. Essentially, the leadership without authority skills we've been talking about.
The soft skills, which are actually the hard skills.
Exactly. And number 3, the side that's really grown in emphasis recently, is strategic and business management. This involves understanding the organizational context, things like finance, marketing, operations, strategy, market knowledge, seeing the bigger picture.
Okay, that third element, strategic and business management, really feels like the game changer here. For years, it felt like the PM was primarily focused on the technical delivery, on executing the plan. Strategic decisions were maybe handled higher up, by the project sponsor or executive management. What's driving this shift towards PMs needing business acumen?
It's driven by that demand for business value we started with. Project managers are now increasingly expected to be strategic thinkers themselves. They're often seen as managing a distinct part of the business, not just executing a short-term activity detached from the bottom line.
So they need to think like business owners almost.
To some extent, yes. They must make not only project-related decisions like, do we need to expedite this phase of the schedule, but also business-related decisions. For example, does this proposed scope change actually increase our long-term market competitiveness, or is it just gold plating? Or how does this project align with the company's overall strategic objectives this year?
It's a much higher level of thinking.
It is. And this is precisely why modern project management methodologies, the really effective ones, are now embedded with core business processes. Things like financial forecasting, benefits realization tracking, strategic alignment checks, rather than being limited to just pure scheduling and task management tools. The business context is integrated.
And this strategic focus really solidifies that key concept we mentioned right at the start. The phrase business value is rapidly becoming arguably the single most important phrase in the entire project manager's vocabulary.
It has to be the ultimate metric, the North Star. The outcome of the project is no longer simply measured by the successful completion of a deliverable, whether that's a functional piece of software, a completed building, or even an interim research report. The only metric that truly matters in the end is the creation of sustainable business value.
And sustainable implies lasting impact, right? Not just a one-off.
Exactly. A lasting positive impact on the organization's bottom line, its market share, its operational efficiency, its competitive advantage, or maybe even its social responsibility goals. That demonstrable, sustained value is now the defining measure of true project success.
Now, achieving this kind of value is especially complex, the sources point out, in the specific arena of technology-based projects. They single these out as being perhaps the most difficult type of project for managers to handle, especially for those who might be newer to the role. Why are tech projects inherently so much harder to manage than, say, building a bridge or organizing an event?
Well, they tend to be characterized by several major difficulties hitting all at once. You often have extremely high technical complexity coupled with inherent risk and enormous uncertainty about the final solution, especially in R&D or cutting-edge software.
The path isn't clear from the start.
Often not at all. They frequently require significant innovation, experimentation, and iterative approaches like Agile or Scrum, precisely because the solution, or even the detailed requirements, might be poorly defined or evolve rapidly as you learn more. And yet, despite this uncertainty, they usually operate under extremely tight, often market-driven or end-date-driven schedules, combined with highly rigorous performance and quality requirements.
High uncertainty, tight deadlines, tough requirements, that sounds like a recipe for stress. So, trying to manage, say, a cutting-edge software development project using the old, rigid, top-down, waterfall-style controls just isn't going to work, is it?
It almost certainly won't, no. These kinds of projects demand newer management techniques, approaches that shift the focus away from simply measuring functional efficiency, like how quickly did the coding department complete its assigned tasks, and instead prioritize ensuring process integration effectiveness.
Integration effectiveness, meaning how well the pieces fit together.
Exactly. How smoothly did the handoffs occur between requirements gathering, design, coding, testing, and deployment? This drives the use of methods like concurrent engineering, where different phases might happen in parallel rather than strictly sequentially, or stage gate methods.
Stage gate, what's that?
Stage gate involves having formal review points, or gates, at the end of distinct project phases. At each gate, management makes a formal go-no-go decision based on progress, risk assessment, and business alignment before committing significant further resources to the next, usually more expensive, stage. It's a way to mitigate massive financial risk in highly uncertain projects.
Okay, that makes sense. Control checkpoints. Ultimately then, boiling it down, the PM's core technical responsibility often comes down to mastering that one central process group we mentioned earlier, integration management. Is that fair?
Absolutely. Integration management is the heart of it. The PM's primary job is to coordinate and integrate all the disparate activities across all the functional lines and all the other process groups in order to develop the plan, execute the plan, and manage changes to the plan effectively. They are the essential converter.
Converter.
Yeah, taking all the inputs, the money, people, materials, information, and converting them through the project process into the desired outputs, the products, the services, and ultimately the profits and the business value we've been talking about.
And to perform that complex integration role successfully, the most vital tool in their toolkit isn't necessarily deep technical skill, is it? It comes back to those people skills.
It overwhelmingly comes back to interpersonal skill. There's a fantastic, very telling anecdote included in the source material. It's about an executive at a major computer manufacturer who was looking to hire new project managers. Someone asked him if the candidates needed to have a deep command of computer technology to be considered.
Okay, a reasonable question. And what was the executive's core insight? What did he say?
His answer was surprisingly blunt, apparently. He said, and I'm paraphrasing slightly here, "You give me an individual who has good communicative skills and strong interpersonal skills, and I'll give that individual a job. I can teach people the necessary technology, but I absolutely cannot teach somebody how to work effectively with other people."
Wow. That just crystallizes the modern PM role, doesn't it? Communication and leadership competence valued even above deep technical mastery, perhaps. The job is inherently political, it's diplomatic, precisely because the PM has such high responsibility for the final outcome, but such limited formal authority over the inputs. It forces constant negotiation with the team, with functional managers, with senior management, with the customer, everyone.
And because the PM must manage every single one of those interfaces effectively to succeed, they inevitably develop this incredibly comprehensive, holistic understanding of the total operation of the company. They see how money flows, how resources get allocated, where the real political pressure points are, how decisions actually get made.
I get a bird's eye view of the whole system.
A unique bird's eye view. And for this very reason, project management roles are frequently used quite intentionally by savvy organizations as a key training route. It's seen as a proving stage, designed specifically to identify and prepare future general managers for top executive positions. They are essentially practicing CEO-level integration and negotiation skills, but at the project level first. #tag outro.
Well, this has been an incredibly deep and I think really clarifying look into the realities of project supervision and management today. We've clearly established that the fundamental mission of modern project management has shifted. It's moved decisively away from just mere output delivery towards the much more challenging goal of creating measurable, sustainable business value.
Value is the keyword.
We navigated the complex organizational reality, visualizing those operational islands, and understood how the PM has to act as a diplomat, a negotiator, a bridge builder, really, to overcome that deep-seated functional competition and those management gaps.
The political dimension is huge.
Yeah, and we saw how the very definition of project success has dramatically evolved. It's shifted well past the traditional triple constraint into this dynamic, multifaceted system of competing constraints. These can include crucial factors like reputation or safety or aesthetic value, sometimes even declaring certain constraints completely non-negotiable, as we saw in that really powerful Disney example.
Those locked-in constraints really change the game.
Absolutely. And we definitely got that necessary, maybe slightly sobering reality check on the PM role itself. The project manager typically operates as a leader with immense responsibility for the outcome, but often surprisingly limited formal authority. They're forced to constantly negotiate for every single resource, often with the very line manager who controls their team members' long-term career trajectory.
The authority gap is real.
Which led us to find that success, therefore, seems to hinge less on sheer technical dominance these days and much more on strategic business acumen, genuine leadership qualities, and those highly sophisticated interpersonal skills needed to influence, persuade, and integrate without direct command.
People skills are paramount.
So if we connect all this back to the bigger picture, the sources provide, I think, a really powerful underlying lesson here about the importance of flexibility and adaptation in leadership. They make it quite clear that the core prioritization of constraints, time, cost, scope, reputation, safety, whatever they may be, can legitimately, and actually frequently does, change mid-project, often due to unpredictable external events like a corporate crisis or maybe just a new strategic mandate coming down from senior management.
The ground shifts.
The ground shifts. And this raises, I think, an important, maybe provocative question for you, the listener, to consider as you think about applying this knowledge in your own context.
If the fundamental measure of project success itself can justifiably shift, sometimes quite significantly, after the project has already been sanctioned and launched based on these evolving secondary constraints, well, then how essential is rigid, absolute, unwavering adherence to the original baseline plan versus, perhaps, the critical leadership skill of strategically managing the inevitable trade-offs, communicating effectively, and recalibrating expectations for all stakeholders along the way? That fluidity, that ability to adapt not just the plan, but potentially even the definition of success itself, maybe that is the true mark of effective leadership and project management today. Something to think about. Welcome back to the deep dive. Today, we're getting into something that, well, if you've ever worked on a project, you've definitely felt it. We're talking about the intricate, often messy reality of organizational structure.
Specifically that dual command structure.
Exactly. The kind of setup where projects cut across different departments, which, let's be honest, is almost every modern business.
It is.
Yeah.
And it creates this inevitable tension.
That's the word.
Yeah.
That tension when the project manager's schedule just slams up against the functional manager's resource problems. So we are diving right into the heart of that conundrum. We're looking at the overlap, the shared authority, and, the frequent conflict between the project manager, the PM, and the functional or line manager, the LM.
Right.
And our mission today is really to give you the blueprint for navigating this. We're going to distill some great material that focuses on organizational design, resource negotiation, and the precise communication failures that can turn a great project into a turf war.
It's all about defining who controls what. And I think this is the key. Why that built-in struggle is sometimes an intentional system. It's a feature, not always a bug.
A system of checks and balances.
Precisely. And that speaks directly to what a learner needs, which is structure and clarity. The material we've looked at really explores this idea of shared authority, this multiple boss dynamic. It's not just common. It's the fundamental building block of what we call a matrix organization.
So we're going beyond just the job titles.
Way beyond. We're looking at how power actually flows. Who gets the technical veto? How do you negotiate for resources when it feels like a zero-sum game? And why so often the perception of authority is more powerful than what's written on the org chart. We're going to show you how to master that matrix.
Okay, so what's the plan?
We'll start by defining that split in command. The PM's constraints versus the LM's execution. Then we'll get into the intense, often chaotic ground battle over staffing. And finally, we'll wrap up by looking at the project office itself and the common behavioral landmines that trip up newer managers.
Sounds great. Let's start with that core dilemma. Let's unpack the dual command structure.
Perfect.
So, in a perfect world, this division of labor is supposed to be crystal clear. The project manager, the PM, they define the requirements.
The what?
The what, exactly. What needs to be done, plus all the constraints around it, the budget, the deadline, the performance targets.
But then once that's set.
Once that's set, the baton passes to the functional manager, the LM, the true subject matter expert who takes over the technical side of things.
The how.
Exactly. And the sources we've looked at are really clear on this. They lay out 3 core non-negotiable responsibilities that are squarely on the functional manager's shoulders.
The 3 pillars of their control.
I like that. The 3 pillars. So what's the first one?
The first pillar is defining the technical criteria. This means the line manager is responsible for figuring out how the task will be performed and where it's going to be done within their department. And this is foundational because, in almost every case, the LM has to be the recognized technical expert in that field, whether it's software engineering or manufacturing, with maybe the one exception being really exploratory, cutting-edge R&D stuff.
Right, where maybe the PM is the one with the niche expertise.
Exactly. But usually, the LM's expertise is what provides that essential check and balance. It's what prevents disaster.
So give me a scenario. What does that look like in practice?
Okay, let's say a project manager who's being driven by a super aggressive schedule specifies a technical requirement, maybe using a brand new, unproven software library to save time.
Okay, I can see where this is going.
Right. The line manager, the expert, knows this library is unreliable or maybe impossible to implement with the current team. In that situation, the LM isn't just supposed to passively follow orders.
And that's where their power comes in.
That's the power. If the line manager looks at the PM's requirements and says, this is technically unsound, they have the explicit right, because of their expertise, to formally object and appeal to a higher authority.
So they can go above the PM's head.
They can. They can take it to a director of programs or a general manager. And that power of appeal is absolutely non-negotiable for the system to be stable.
It stops projects from being driven solely by, say, cost pressure into doing something technically absurd.
You got it. The LM is basically the technical conscience of the organization. They protect the integrity of the work, even if it means confronting the PM and slowing things down for a bit. The organization's protected because the LM is judged on technical quality, while the PM is judged on meeting those constraints.
Time, cost, performance. Okay, that makes sense. So that's the first pillar, technical criteria. What's the second?
The second is providing sufficient resources.
The who.
The who. Now, the PM could definitely request specific people, and we'll talk about that whole negotiation later. But the ultimate responsibility for assigning who will do the job within the PM's constraints rests solely with the line manager.
They're the gatekeeper of the talent pool.
That's a perfect way to put it. And that leads right into the third pillar, deliverable ownership.
Okay, what does that mean?
It's crucial. The line manager remains absolutely responsible for the quality and completeness of that functional deliverable, even after the PM has started tracking it. Accountability doesn't just vanish into the matrix.
So if the team the LM assign fails to meet the PM's constraints, time, cost, whatever, it's not just the PM's problem.
Exactly. If that happens, both the PM and the functional manager are blamed.
Ah, so that's the alignment mechanism.
It is. The source material is clear that this isn't about punishment. It's a formal way to align their incentives.
Because if only the PM were blamed, the LM would have no real reason to provide their best people or stick to the schedule.
None at all. By holding the LM accountable for their commitments to the PM, the organization basically formalizes the idea that everyone has to succeed together. We're even seeing companies now explicitly tying line manager promotions to how well they support their project managers.
That dual blame structure really forces collaboration.
It has to. Otherwise, the whole thing falls apart. Project management is, by its very nature, designed for this kind of shared authority. It accepts that no single person should control both the big picture strategy and the nitty-gritty technical details.
The split is systematic.
It is. Broadly, PMs plan, monitor, and control the project, while the functional managers perform the actual work.
And the sources break this down, right? I think it was Table 1.1. It's all about summary versus detail.
Yes, that's a great lens to view it through. Let's take direction, for instance. The PM gives the summary direction, the big goals, the timeline, the what and when.
But the LM gives the detailed direction, the specific procedures, the engineering standards, how to actually do the task.
Exactly. And the same pattern holds for recognition and control. The PM might give an informal, hey, great job on that milestone, but the LM provides the formal, detailed rewards.
The things that actually matter for your career, like a raise or a good performance review.
Right. The LM holds the purse strings and controls that career path. And this summary versus detail split, it's consistent across everything: evaluation, measurement, control. It's a system designed to prevent either side from becoming too powerful.
But you mentioned it's vulnerable. Where's the weak point?
The weak point is when that separation of duties is removed. The material highlights a major conflict when the project manager and the line manager are the same person.
Which happens a lot in smaller companies.
A lot. And it immediately creates a conflict of interest that just guts the whole checks and balances system we just talked about.
Your temptation would be huge.
Of course, if you're a line manager and you're juggling 6 requests for your best engineer, and one of those requests is for your own project.
You're going to save your star player for your own team every time.
Every single time. And the result is your project looks brilliant, but it's often at the direct expense of the 5 other projects that needed that same person. So that shared accountability, as messy as it is a crucial defense against that kind of self-serving behavior.
It forces the manager to balance the needs of their department with the needs of the projects.
Precisely.
But that shared structure, it's not always a 50-50 split in power, is it?
Not at all. The balance of power can vary dramatically depending on the type of matrix organization you're in. That's really a strategic choice the company makes.
And that choice dictates who has more influence over the employees on the project.
It really does. At the weakest end of the spectrum, you have what's called a lightweight or weak matrix. This is where the functional manager is king.
The PM is more of a coordinator in that model.
An expediter, yeah. They negotiate for deliverables. They're asking the department for a finished piece of work by a certain date. The employees get their technical direction almost entirely from their LM.
And the key part is the performance review.
The most important part. In a weak matrix, evaluations are made only by the line manager, with little to no formal input from the PM. The PM has almost no leverage over the people doing the work.
Okay, so what's in the middle?
Moving towards the center, you get the heavyweight or strong matrix. This is a deliberate shift of power towards the project. Here, the PM is negotiating for people.
They want specific individuals.
They do. They want specific people on their team, often full-time. So the employees report informally to the PM for project direction, but still formally to the LM for things like salary.
And the big difference here is the evaluation.
That's the critical distinction. In a strong matrix, the LM still does the evaluation, but they must include critical input from the project manager on that employee's performance on the project.
So now the PM has a real lever.
A huge lever. That feedback directly impacts the employee's career, which makes them pay a lot more attention to what the PM needs.
And then at the far end of the spectrum.
At the far end, you get what are sometimes called tiger teams, or a very strong matrix. This is usually for mission-critical, high-priority projects.
The functional connection is basically cut.
Almost entirely. The employees report directly and fully to the PM for the entire project. In that case, the PM becomes the sole authority and does the evaluations themselves. It's a clear spectrum, from the PM as a facilitator to the PM as essentially the temporary CEO of their project.
And you have to know where your organization sits on that line to know how to negotiate.
If you don't, you're flying blind.
Okay, so we've set up the structure. Now let's get into what you called the ground battle.
Staffing.
Right, where the theory of shared authority meets the painful reality of not enough people. To get why this is such a fight, you have to understand the world the line manager lives in.
It's a world of perpetual chaos. The PM often sees the LM as this, predictable pool of labor they can just draw from.
But that's not the reality.
Not even close. The reality, as our sources detail, is that the line manager is in a state of continuous, high-pressure firefighting. It makes making firm commitments incredibly difficult.
What kind of firefighting?
Think about it. They're getting unlimited work requests, often from promises made during some competitive bidding process. They have predetermined deadlines set by somebody else.
And every request is marked high priority.
Every single one. And they have to manage all of that with a limited number of people who are already busy.
Plus all the unexpected stuff.
The constant unscheduled changes, the project that's suddenly behind schedule, unplanned absences, equipment breakdowns, people quitting.
Yeah.
It is a structural treadmill of chaos. The LM is supposed to be a stabilizing force, but they're standing on quicksand.
And that uncertainty, that chaos, forces them into a strategy that a lot of PMs just don't get.
Exactly. Because of all that chaos, the LM cannot, and really should not, commit specific individuals months and months in advance.
So if I, as a PM, ask for your star engineer, Alex, for a task next year...
I can't guarantee Alex will be available. I have no idea what fires I'll need Alex to put out between now and then.
So the commitment from the LM isn't about the person.
No. This is the counterintuitive part for the PM. The LM's commitment has to be to achieving the deliverable, to hitting the time, cost, and performance targets, even if they have to use an average team to do it.
They commit to the outcome, not the specific resource.
And that shifts the burden. If you, the PM, get a resource you think is subpar, you can't just complain about the reputation. You have to track them closely. You need hard data.
Evidence?
You have to have evidence, quantifiable metrics showing they're slipping on schedule or the quality's at risk. Only then can you go back to the line manager and demand someone better. The whole negotiation has to be based on project constraints, not on your personal preference.
Which brings us right to the sharp end of that negotiation. It's almost always about trade-offs.
Always. The source material has a classic scenario for this. Imagine a project with 3 tasks, one after another, all in the same department.
Okay.
The LM comes to the PM with 2 options. Option A. You can have the absolute best available person right now for the first task, but I can't promise they'll be free for the next 2. Or option B. You can have an average employee, but I will guarantee you that this person will stay on your project for all 3 tasks.
Quality versus continuity.
Exactly. And there's no single right answer. It's intentionally ambiguous. A risk-averse PM might take the average person for the guaranteed stability.
Right, to keep that institutional knowledge on the project.
While a PM with really aggressive technical goals might fight for the star and just accept the risk of having to find someone new later.
And the deciding factor is?
Trust. It's entirely about the level of mutual trust between the PM and the LM. If trust is high, they can have an honest conversation about the risks and make a joint decision. If trust is low,
the PM will assume the LM is trying to dump their worst employee on them.
And the LM will assume the PM is setting them up to fail.
Yeah.
It all comes down to that relationship.
And the staffing process, it's not just a two-person conversation, is it? Upper management often gets involved.
They have to, because these assignments have to line up with bigger company policies, rank, salary, promotions. You can't just assign a mid-level person to do a director's job without dealing with the political fallout.
And what about when you're staffing from within? Moving people between projects?
That's where it gets really intense. It becomes a zero-sum negotiation between the project managers themselves.
Because no PM wants to give up their best people.
Never. The sources call it a way of life in these environments. It's a constant competition for talent.
Which is why upper management often sits in on those meetings.
It's highly strategic. First, they're there to set the ground rules and priorities, to decide which project gets top billing. But more importantly, their presence shows that leadership cares about the best overall resource mix for the whole company, not just letting one-star projects suck up all the talent.
It elevates resource allocation from a scheduling task to a strategic issue.
Which is exactly what it is.
Okay, let's not forget the person caught in the middle of all this.
The functional employee.
They're in an incredibly awkward spot. They've got a solid line on the org chart going to their functional manager.
Who handles their salary, their career, any disciplinary stuff.
And then they have this dotted line going to the project manager.
Who gives them their day-to-day tasks and priorities for the project.
It's a recipe for stress and contradiction. They're getting technical direction from one person, but their performance review and their raise depend on someone else entirely.
And it gets even more complicated and feels like, say, advanced R&D. In those cases, it's actually pretty common for the project manager to have more technical knowledge about the project than the line manager.
So the employee is stuck. They're getting technically superior direction from the PM, but they have to make sure they're following the policies set by their less informed but administratively powerful boss.
The tightrope walk. Which is why their role is about so much more than just doing the work. They have very specific duties to bridge that authority gap.
Communication, I'm guessing.
All communication. The employee has to periodically update both the PM and the LM on their status.
Yeah.
They have to raise problems quickly. They have to share information with the rest of the team.
They become the communication hub.
They do. They have to be the diplomat, keeping both of their bosses in sync. If they fail to communicate, the project's integration fails.
Let's talk about the life cycle of that assignment. What happens over time?
The sources show a really clear pattern. Staff gets brought onto a project very quickly. PMs are terrified of losing good people to other projects, so they grab them fast.
But they're slow to let them go.
Much slower. The curve for releasing staff is really gradual. PMs tend to hoard resources.
They want to be absolutely sure that person isn't needed anymore.
Right. And that fear, the fear of having to go back and renegotiate for that person later, causes them to keep people on the payroll longer than necessary.
Which wastes budget and must drive the line managers crazy.
It's a huge source of frustration for LMs who desperately need those people back for other work.
Okay, now for the sensitive part. What happens when someone needs to be removed from a project?
The material outlines very specific project-focused reasons. It's not about being a bad employee in general. It's about things like not accepting project rules or focusing too much on technical perfection and ignoring the budget, or just, simple incompetence for that specific task.
The impact on the project is the key.
It is. And if a PM decides a line employee has to go, they have a few options. They could try an on-the-spot appraisal or reassign them to something less critical, but most often it's removal.
And this is where the politics get really tricky.
This is peak organizational politics. A PM can directly remove someone from their own project office staff. That's a solid line report. But removing a line employee,
The ones who report to the functional manager.
is strictly an indirect process. It can only be done through the line manager. The PM cannot fire or even transfer that person without the LM's approval.
And it has to be handled delicately.
With exquisite delicacy. The sources really stress this. The removal must be framed to look like a transfer. Just a neutral reassignment back to their home department.
Why is that so important?
Because if a project manager gets a reputation for firing people from their projects, their ability to negotiate for any good resources in the future will be destroyed.
Line managers will see them as toxic.
They'll refuse to assign their best people because they'll be afraid they'll just be rejected and demoralized. It's a powerful truth. Your perception, your reputation, dictates your future negotiating power far more than your project's metrics do.
So the PM has to choose diplomacy over satisfaction.
Every time.
Okay, let's shift focus a bit to the project office itself, the structure of the team.
Right. Companies struggle with job descriptions for project roles because every project is unique. But the material gives us a really clear career path framework. It shows how responsibilities scale up.
Let's start at the bottom, the junior roles.
Okay, so you have your junior roles, project administrator, coordinator, technical assistant. Their job is almost entirely internal and supportive. They're coordinating tasks, helping the PM with scheduling, tracking the budget.
The skills are mostly administrative and analytical.
Exactly. Planning, coordinating, analyzing, and just understanding how the organization works. They're the operational backbone.
Then you move up to the mid-level.
The mid-level roles, task manager, project engineer, assistant PM. And this is the big transition. You go from assisting to directing.
So they're establishing requirements, making trade-off decisions.
Conducting those trade-offs, right, is adding this feature worth a 2-week delay. They're directing the technical implementation on the ground. The skills shift to technical expertise and leadership. They're the tactical translators of the PM strategy.
And the next jump is a big one.
The jump to senior PM or program manager is massive. Your focus moves from tactics to strategy and complex negotiation.
Their main job becomes managing the relationship between the client and all the functional managers.
That's it. They're handling bid proposals, overall staffing strategy, and critically, they're now responsible for the project's profit, and even finding new business. Their skills are all about team building, conflict resolution, and leadership. They own the business success.
And at the very top,
The executive roles. Director of Programs, VP of Program Development. At this level, you stop managing single projects and start managing multi-program businesses.
it's all about strategic planning, setting policies, deciding which technologies to invest in.
Exactly. The higher you climb, the less you deal with how the work gets done, and the more you deal with who is doing it and why the project even exists.
So if the senior PM is the conductor, the project office or PO is the rest of the orchestra.
A great analogy. It's the organization built to support the PM. The people in the PO have to be just as dedicated as the PM, and crucially, they need great relationships with both the PM and all the functional managers.
Their core job is information and control.
They're the central hub, the focal point for all information, both internal reporting and what goes to the customer. They control the time, cost, and performance to make sure you're meeting the contract. They make sure everything is documented, authorized, and funded.
But the material says there's one overriding purpose.
Integration. The single most challenging responsibility for the PM and the PO is integrating the work across all the different functional lines, engineering, manufacturing, quality, you name it.
And that's hard because those departments often have conflicting priorities.
Inherently conflicting. Engineering wants perfection. Manufacturing wants speed and low cost. They're naturally at odds.
And this is a really critical point for anyone listening. The sources explicitly say that the lack of proper integration is the most common cause of project failure.
It is. Which means the project office is so much more than an admin team. It's the vital connective tissue that has to actively mediate and resolve those conflicts.
Everyone in the PO has to be dedicated to the project's success, not just their own department's goals.
Absolutely. And staffing that office is a trade-off. You need enough people to ensure compliance and control, but not so many that your administrative costs balloon. It's a balancing act.
What's interesting is the effect it has on careers. The cross-training.
It's a fantastic training ground. People in the PO should be focused on project management, not their old technical specialty, but just by doing the job, they pick up expertise everywhere.
The cost guy learns about procurement. The scheduler learns about quality assurance.
Exactly. The PO acts as this amazing accelerator for creating really well-rounded generalist PMs who are ready for leadership.
Okay, let's talk about something you mentioned earlier, organizational charts.
Ah, yes, organizational diplomacy.
The sources are pretty blunt about this. They say these charts can sometimes be, and I'm quoting here, eyewash for the customer.
It's pure theater sometimes, and highly strategic. Let's say a company's running 6 big programs, and the Midas program is actually their lowest priority internally.
But you can't tell the Midas client that.
Of course not. So on the org chart you give the client, you might put the Midas program right at the top, in boldface. It's visual manipulation, designed to make the client feel like they're the #1 priority, no matter what the reality is.
And the charts also hide the true reporting lines.
They do. A chart might show a solid line from the chief of design to the program manager, implying direct control. But in reality, that person reports to the Director of Engineering, the LM. The chart for the outside world is a diplomatic tool that masks the real, complex dotted line relationships inside.
This also explains dual titles.
It does. If you give someone the title Assistant Project Manager, it allows them to speak directly to the customer and represent the company as a whole.
Whereas a regular functional employee can only speak for their own department.
Right. The title gives them external authority and legitimacy.
And finally, what are Manning charts?
Manning charts are vital, especially for proposals. They don't just list the key people in the project. They show the customer the exact % of time those key people will be dedicated to their program.
It's a commitment.
It's a contractual commitment that you won't starve their project of the talent you promised. It turns resource availability into a quantifiable, proposal-backed promise.
Right. Charts and structure only get you so far. Let's get into the human element.
The behavioral dynamics. A project's success really rests on the team dynamics. You can have all the executive support in the world, but if you staff your team with people in destructive roles, they can derail the whole thing.
And these roles are especially bad in a matrix environment.
Because they destroy the fragile consensus you need for integration.
Okay, let's go through the saboteurs. Who's first?
First, you have the aggressor. This person criticizes everything, tries to deflate everyone's ego, and is just generally confrontational. They're trying to tear down the PM's authority, which is already spread thin in a matrix.
And you've got the dominator.
The dominator tries to take over. They claim to know everything. They manipulate. They challenge leadership directly. In an environment that's supposed to be about shared authority, the dominator tries to make it all about them.
And what about the devil's advocate? That sounds like it could be a good thing.
It could be, but this type is more devil than advocate. They find fault with everything, not to make it better, but just to be negative. They refuse to support any change unless they're threatened. They create massive inertia.
And that's similar to the blocker.
Very similar. The blocker also criticizes and rejects ideas, but they do it by citing unrelated anecdotes and coming up with a million reasons why project management just won't work here. And since we know lack of integration is the #1 cause of failure, the blocker is one of the most dangerous people you can have on a team.
They actively work to keep the silos in place.
Exactly. And then you have the others, briefly. The recognition seeker, who only cares about their own ideas. The topic jumper, who makes sure nothing ever gets decided. And the withdrawer, who is a black hole of information. All of them are fatal to a project that relies on transparent communication.
So if those are the people who sink the ship, who are the ones that keep it afloat?
The supportive roles. The people who make matrix management actually possible. Their behaviors are all about building consensus and solving problems.
You want initiators.
Yes. Their language is all about breaking inertia. Let's try this, or could we pilot this? They get things moving.
You also need the information seekers and givers.
Absolutely essential. They make sure you're not reinventing the wheel. They bring in data, benchmarking studies, past experience. They replace subjective opinion with objective facts.
And in an environment with a lot of ambiguity, you need clarifiers.
So important. They're the ones who say, wait, are we all agreeing that? Or let me say this back in my own words. That simple act prevents huge misunderstandings down the road.
Then you have the people who manage the inevitable conflicts, the harmonizers and consensus takers.
Harmonizers find the common ground. Consensus takers make sure everyone is actually on board before moving forward. They're the emotional intelligence of the team.
And lastly, the gatekeepers.
The gatekeepers ensure the decision-making is fair and complete. They're the ones asking, who haven't we heard from yet? Or, do we have enough information to make this call? These supportive roles create the behavioral framework you need to navigate the complexity.
Okay, to wrap this all up, let's fast-track the learning curve. Let's talk about the classic mistakes.
The self-inflicted wounds. The sources lay out about 20 of them, but we can group them. First are the leadership and ego errors.
Like believing you need to know every single detail to be a good leader?
Which is a huge mistake. Real leadership is knowing who to trust for the detail. Even worse is pretending to know more than you do. The real experts, your functional team, will see right through that and lose all respect for you.
And the cardinal sin, constantly reminding everyone you're the boss.
Especially in a shared authority setup. That just destroys the goodwill you absolutely need to negotiate.
Next up, planning and execution errors.
These are usually driven by ego or ambition. Like trying to impress your bosses with a ridiculously ambitious schedule that you know the line managers can't possibly support.
You're just setting everyone up to fail.
Guaranteed failure. Another classic is gold plating.
Adding extra features that nobody asked for.
Exactly. The PM thinks they're impressing people, but they're just blowing the budget and the schedule, which are the two things they're being judged on. The project might be a technical marvel, but it's a commercial failure.
And then the final, critical group of errors.
Communication and conflict errors. Failing to share accountability for both successes and failures with the line managers.
It makes it feel like it's just the PM's problem.
So the LMs have no skin in the game. Also, being unwilling to ask for help or just ignoring problems, hoping they'll go away. They never do. They just get bigger.
This also includes the external mistakes, right?
Big time. Refusing to tell the client they're wrong, even when their demands are hurting the project. A good PM has to protect the project's integrity, even if it means a tough conversation.
It's all connected to being unwilling to say no or not knowing which battles are worth fighting.
That's the art of it. And the last two critical mistakes are ignoring problems and, maybe most importantly, failing to understand the political landscape. Project management is inherently political. Ignoring that is a guarantee of failure.
It seems like the role requires more diplomacy and political skill than pure technical know-how.
In many cases, much more. So we've really covered a lot of ground today. We started with the formal definitions of that dual command structure, the LM's technical veto, the PM's control over constraints.
Then we went through the chaotic ground battle of staffing and how it all comes down to evidence and trust.
We detailed the project office as that indispensable integration engine and showed how org charts can be a diplomatic tool, a piece of theater for the client.
And we wrapped up with the exact behaviors to look for in a team and the critical errors to avoid.
And if you connect all those threads, you see that successful project management is all about the PM's ability to use informal influence on direction, on priorities over resources they don't formally control.
Because the formal control belongs to the LM, the administrative boss, the career path owner.
The technical authority. You've seen that the real work isn't in the project plan itself. It's in the invisible negotiations, the political maneuvering, and the constant difficult work of integrating specialists from those powerful line organizations.
So it's not just about managing time, cost, and scope. It's about mastering the organizational psychology needed for shared authority.
Exactly. And that brings us to a final thought for you, the learner, to consider. The sources tell us that the lack of proper integration is the single biggest cause of project failure. So if the current system naturally creates all this friction over resources,
how could an organization change the game?
Right. How could you fundamentally redesign compensation or promotion structures to explicitly incentivize both line managers and project managers to view that integration, the sharing of people, the sharing of accountability, the proactive communication? How do you make them see that not as a cost or a political risk, but as the single most important measure of their shared success?
Aligning the incentives.
That alignment, that is the ultimate organizational deep dive.
Welcome back to the deep dive. Today, we are strapping in for a high-velocity look at the operational reality of projects.
Right.
We're moving past all the theoretical planning and getting right into, the grease and grit of execution.
Yeah, the real stuff.
We're tearing through sources that detail not just how managers should lead, but how the most rigorous financial systems track every single hour and every single dollar.
That's exactly right. I mean, if planning is all abstract, execution is very, very concrete.
Mm-hmm.
Our deep dive today is focused entirely on that fundamental tension in project management. How do you lead, direct, and motivate these temporary teams, that's the human factor,
right,
while at the same time implementing and sticking to these incredibly rigid quantitative cost and control systems that are often mandated by the customer.
So our mission for you, the listener, is to walk away with a crystal clear understanding of that balance. We are going to decode the mechanisms that give authority to a project manager who might not even sign the paychecks.
That's a huge one.
And then we'll break down the financial architecture, the management cost and control system, and the, frankly, genius of earned value measurement that verifies if your leadership is actually delivering measurable progress.
It's power, people, and precision accounting all rolled into one. You really have to master all three to survive in the real world of projects. Let's unpack this whole operational framework.
Okay, let's start where the action begins. Directing. The source material defines this function really beautifully. It's the process of implementing and carrying out approved plans through others to achieve or, even exceed objectives.
It's the managerial function that turns the blueprints into actual action. It's where the rubber meets the road.
And this action, it relies on mastering 7 key elements of directing.
You can think of these as the fundamental tools in any project manager's leadership toolkit.
So we start logically with staffing, putting the right qualified person in the right position.
Can't do anything without that.
Then it's followed by training, making sure they actually know their duties and responsibilities.
Then you move into the core daily oversight. That's supervising, which involves all the necessary day-to-day instruction, guidance, and, yeah, sometimes discipline.
And this next one is critical for any project's efficiency: delegating.
Right. Assigning the work, the responsibility, and crucially, the authority needed to really maximize the use of your team's abilities.
Okay, now we hit the more human element, motivating, encouraging performance by appealing to or fulfilling people's needs.
Yeah, the softer skills.
And the element that I find most intriguing, especially in a temporary setting, counseling. This is described as private discussions aimed at improving work, maybe solving personal problems, or even helping someone realize their ambitions.
Which is tough when you might only know them for 6 months.
Exactly.
And then tying it all together is coordinating. Making sure all those separate activities done by all these different people are carried out in relation to their importance. And this is key, with minimum conflict between all the moving parts.
When you look at those 7 elements, it's just so clear they were almost designed for a stable, long-term line organization.
They were.
But the project manager is operating under this unique constraint of short project durations.
That's the friction point.
Yeah.
I mean, a traditional line manager, they have years to build rapport, trust, and history with their team.
Right.
The project manager, they often lack that luxury of time to get to know their subordinates deeply. And to make it worse, those team members often still report functionally to a line manager.
So you instantly have this dual accountability. A team member reports vertically to their permanent boss, but horizontally to you, the temporary project manager.
So the moment things get complicated, whose authority wins out?
That's the question.
Exactly.
Yeah.
And this means the PM has to prioritize rapid credibility and decisive action. Our sources give us an almost, a brutal metric for this.
What is it?
It is better to be 10% wrong than wait for the last 10% of input and cause catastrophic delays.
Wow.
Yeah. The pursuit of perfect information often just kills the project timeline.
And that kind of speed requires maximum clarity. So when you're issuing directives, what guidance do the sources give us?
It's the famous KISS rule. Keep it simple, stupid.
Of course.
Directives have to be written with one simple, clear objective. And look, this isn't about being condescending. It's about reducing the cognitive load and the chance of misinterpretation when everyone's under high pressure.
Right. When a team member has 2 bosses and a deadline breathing down their neck, they need singular focus from you.
And when you issue that clear order, the source material is absolutely adamant about enforcement. Orders must expect immediate compliance, but you should never, ever issue an order if you can't enforce it.
Why not?
Because the entire system just collapses back to that basic human dynamic. Respect is the key factor in obedience.
Oh.
If your subordinates sense that you, the PM, lack the political capital or the organizational authority to back up your own directive, they'll just ignore it.
Your command just becomes an optional suggestion.
It does. And that's why the advice for oral directives is so nuanced, isn't it?
It is. Tell us about that.
Well, oral directives should often be disguised as suggestions or requests. You're trying to get their professional buy-in, not just bark orders at them. And after the order is given, you must ask the receiver to repeat it back to you. This is just an essential check against that short timeline dynamic where a simple assumption can completely destroy progress.
You have to ensure absolute clarity.
On the task, the timeline, and the expected outcome.
Yes. Okay, let's pivot to motivation. This feels like the most difficult element under these kinds of short constraints.
It often is.
Since the project has a finite lifespan, the PM can't really motivate by promising material gains, no long-term raises, no permanent promotions, so what's left?
You have to appeal directly to each person's pride.
Okay.
This shifts the focus entirely from, extrinsic rewards like money to intrinsic satisfaction. The PM has to make the assignment feel necessary, vital, and frankly, resume-worthy.
So tell us about the specific security methods that can enhance that sense of pride and value within a temporary team.
It really boils down to extreme clarity and visibility.
Yeah.
First, you have to let people know why they are where they are. Don't just assume they know. Tell them the unique skill they bring that the project desperately needs.
Acknowledge their value.
Exactly. Second, ensure they feel they belong. placing them in positions where they're properly trained, which sets them up for success.
Oh.
And most critically, let employees know exactly how their little piece of the puzzle fits into the big picture.
So if they know their widget is essential to the overall launch.
Their personal pride is now leveraged for motivation.
Absolutely. That visibility is such a powerful tool. You're giving them something to brag about both internally and externally. What are some of the broader guidelines for the manager's behavior here?
The guidelines really focus on consistency and honesty. You have to adopt a positive attitude even when you're facing delays. A major rule: do not criticize management to your subordinates. That just erodes the very structure they're relying on. And never, ever make promises that you can't keep, especially on personnel matters.
I also like the focus on external motivators, like circulating customer reports.
Yes. When they see the customer is thrilled with phase one, it validates their effort in a really tangible way that money often can't replicate in the short term.
Right.
And it's also crucial to give each person the individual attention they require. Even a quick check-in that acknowledges their specific contribution can go a long way.
Okay, so if we synthesize all of this, what are the most effective motivational ways for a PM working with a temporary team?
Well, challenging assignments are key. It shows that you trust their capabilities, clearly defining performance expectations so success isn't ambiguous, providing proper criticism when it's needed, but always balancing it with credit where credit is due.
Giving honest appraisals.
Giving honest appraisals that they can take back to their functional manager, absolutely. And fundamentally, developing a cohesive team attitude. It must always be framed as us against the objective, rather than me, the PM, against you, the performer.
That tension between needing respect but not having formal hiring or firing power, it seems like a natural transition to the structure of power in a project environment.
It is.
We really need to clarify the fundamental distinction between authority and power.
This is a critical managerial distinction that gets blurred all the time in daily conversation. Authority is the legal or rightful power to command, act, or direct. It's delegated from superiors. It comes with your title and the project charter.
Whereas power, conversely, is granted to you as an individual by your subordinates.
Exactly. It's measured entirely by their respect for you, their perception of your credibility, your expertise, and your ability to be a sound decision maker.
So a project manager's true ability to lead is a combination of that legal authority and the earned power and influence.
That's what leads subordinates, peers, and even associates to willingly accept their judgment, even if that judgment conflicts with what their functional boss might prefer.
In a traditional hierarchy, a line manager's power often flows naturally from their authority. But in a project matrix structure, the PM's authority might be weak.
Meaning they have to rely disproportionately on that earned power, which is built on competence and reputation, just to get things done.
It's like managing an authority web.
It is. The project management structure inherently creates this dynamic and honestly often chaotic web of relationships in delegation. The PM has to manage across functional and organizational lines, basically forging new alliances every single day.
And if you can't build or maintain those alliances,
your project stalls. Simple as that.
This brings us to a potentially controversial question from the sources. How much authority should a project manager actually have?
The amount varies widely, of course, based on project size and the organization's philosophy, but the guiding principle cited in the sources is provocative.
Go on.
A project manager should generally have more authority than their responsibility calls for.
Wait, hold on. You're saying the PM should have more authority than their responsibility calls for. That sounds like a recipe for, I don't know, scope creep, unchecked ego, organizational abuse.
I know. It sounds that way.
How do the sources justify giving a single person that much potential leverage?
It's justified purely by risk. The rationale is that the amount of authority has to scale directly with the level of risk the PM is expected to manage.
Oh, okay.
Greater risk demands greater authority to prevent and mitigate catastrophic events quickly. You have to give them the tools to handle a crisis that are proportional to the cost of that crisis.
So if the project fails, the PM is responsible, therefore they need a maximum latitude to prevent that failure.
That's the logic. It's a very pragmatic approach to liability and consequence.
That makes more sense. We should also acknowledge the influence project managers we've talked about, the ones who only have monitoring authority.
Right. They exist in weaker matrix structures.
Yeah.
Their entire success hinges on personal power because their legal authority is limited to just monitoring and reporting status, not actually commanding action. They are the ultimate negotiators.
And the danger of getting this authority structure wrong, of having undefined authority, is huge. What happens to an organization when those relationships aren't clearly established?
You just see this cascade of dysfunction,
Hmm.
poor communication, the spread of misleading information, antagonism, particularly from the informal organization that just thrives in ambiguity,
Which leads to?
poor working relationships, and, worst of all, surprises for the customer. Nothing kills confidence faster than an unexpected delivery failure because the internal authority was murky.
And that murkiness usually stems from the core conflict structure of the matrix, especially that dual boss problem.
Right.
What are the common problems the PM has to confront?
Well, first and foremost is just poorly documented formal authority. But the biggest source of day-to-day friction is dual accountability personnel, having two bosses who often disagree on priorities or methods. We also see the inevitable shifting of loyalties, from the vertical functional lines to the horizontal project lines, and the overall project structure just naturally encourages individualism over following a standardized process.
So since the PM doesn't have unilateral authority, they have to negotiate constantly with the functional managers who actually own the personnel and the resources.
Constantly.
What's the fundamental division of responsibility in that negotiation?
It's the classic separation. The project manager determines the when and the what of project activities. They own the schedule and the scope definition.
And the functional manager?
The functional manager determines how the support will be given. They own the technical standards, the specific tools that are used, and the personnel training.
Which means the PM has to be proficient in leading professional staff by explaining the rationale behind the effort, not just issuing top-down orders.
Exactly. And the negotiation itself has ground rules. It should always take place at the lowest level of interaction possible to get a fast resolution.
And when conflict arises,
The team has to first define the problem clearly. What's the issue? What's the impact? What are the alternatives? And what are our recommendations? Going to higher level authority is the absolute last resort, only when negotiation completely fails.
so if planning is the critical stage for establishing these rules, how do we document this negotiated authority clearly?
Well, the sources cite the project charter as maybe the single best way to document the PM's authority.
The foundational document.
It is. It delineates their focal position, their control over project funds, and their rights in resolving disputes. It basically turns those negotiated agreements into formal organizational policy.
And when multiple functional units are sharing work, we turn to the responsibility assignment matrix, or RAM.
Also known as a linear responsibility chart, or LRC. Yes.
Right.
The RAM is just indispensable for matrix organizations. It defines the specific authority relationships visually. You use rows for the activities or tasks, pulled directly from your work breakdown structure. The columns identify the positions or titles involved.
And the symbols where they intersect indicate the degree of authority. Who must approve, who needs to be consulted, who just needs to be notified. It defines the whole flow of communication and decision rights for every single piece of work.
And that practical detail you mentioned earlier is so key to maintaining control.
Which one?
If external customers see the chart, you should only use titles, never employee names.
Right. Why is that?
Because if you put names on it, you risk the customer bypassing the PM and communicating directly with your staff, which can derail your priorities instantly. So the RAM isn't just an org chart, it's also a political document.
Okay, so we've established the team dynamics, we've defined the lines of authority. Now we need to know if all that directing is actually producing the required results. This brings us to the formal function of controlling.
Controlling is the management discipline that closes the loop. It's defined as a three-step process: measuring progress toward an objective, evaluating what remains to be done, and then taking the necessary corrective action to achieve your objectives.
Let's break down the mechanics. Step one is measuring.
Measuring is where you determine the degree of progress you're making. You're using both formal monthly reports and informal daily or weekly updates. You're basically quantifying the distance between your baseline plan and your current reality.
And step two is evaluating.
This is the diagnostic step. Here you're determining the cause of and the possible actions for any significant deviations from your plan. You're asking, why are we 10% late, and what are the specific inputs we need to change to fix it?
And finally, step three is correcting.
Correcting means taking active control action. This could be fixing an unfavorable trend by adding more resources or maybe reducing scope. But importantly, it also means capitalizing on a favorable trend.
How so?
Well, maybe you reallocate an excess budget or some time savings to a higher risk area of the project.
To enable this comparison, the PM has to have a really thorough knowledge of standards and cost control policies.
Absolutely. You're comparing your operating results against pre-established standards that were often outlined months or even years before you started execution.
And here we have to link back to our original point about the human factors.
Yes. The PM needs exceptionally strong interpersonal skills during this controlling function. Since they operate under time constraints, delivering corrective action, especially negative feedback, to someone who still functionally reports to another manager is incredibly delicate.
You don't have the long-standing behavioral data or the leverage of a traditional boss.
Right. You have to make sure the correction is seen as being directed at the work and the objective, not at the person. If you fail at that, you lose their respect and collaboration instantly.
So the control system you use needs to be undeniable.
It has to be.
Yeah.
It needs to make the need for correction self-evident.
That need for an undeniable objective control system brings us directly to the Management Cost and Control System, or MCCS.
It does.
The sources are so clear on this. Cost control is far more than just monitoring and recording data. If you're just being a historian of what happened, you've already failed.
True cost control involves analyzing that data to take corrective action before it is too late. And the responsibility for this analysis has to rest with all personnel who incur costs, not just the project office accountant.
Good cost management integrates a lot of moving pieces.
It does. Cost estimating, cost accounting, tracking cash flow, handling direct labor costing, understanding overhead rates, and specialized tactics like incentives and penalties you build into your subcontracts.
The MCCS is conceptualized as a two-cycle process. The foundation is the planning cycle.
Right, the planning and control phase. This is where you object the cost and control phase. This is execution and monitoring, where that planning system actively helps management project the status toward completion by relating cost and schedule performance data.
And this requires standards. There are two categories.
Right. First, you have performance results standards, which are quantitative measurements: quality, quantity, cost, and time to complete. These are your nice, clean, quantifiable targets.
And second, process standards.
These are more qualitative. They focus on the relationships between organizational factors, personnel effectiveness, and so on. They're often harder to measure, but they're critical for sustainable performance.
Standards are vital. They provide unity, a basis for control, and incentive.
But there's a downside we have to acknowledge. Highly specific standards can lead to performance being frozen.
What do you mean by frozen?
It can make employees unwilling or unable to adjust to necessary differences or unexpected changes. It can stifle innovation right when you need it most.
The integrated control that MCCS demands is really the absolute core of modern project management, the triple constraint.
Yes, management has to compare time, cost, and performance together, not independently.
Right. If you're on budget and on time, but your performance is only at 75% of what was required, you've failed.
And if you hit 100% performance on time, but you incurred a 50% cost overrun, you've also failed. The analysis of all three together prevents that management trap of winning the battle but losing the war. They have to be seen as a group.
And the framework for this whole integrated analysis is the work breakdown structure, the WBS.
The WBS provides the tool you need to verify that your project objectives were successfully translated into specific performance standards, and that meaningful budgets were established at the lowest necessary level for comparison. It is the spine that connects your technical requirements to your financial control structure.
Since the WBS defines the baseline, any changes must be managed with absolute discipline.
Baselines are not static, but the sources mandate disciplined change control. Changes have to be deliberate management actions, not arbitrary or, inadvertent slips.
And this discipline is often enforced through really stringent contractual rules, particularly for government work.
Yes, and the examples of prohibited actions they cite are crucial. You cannot make retroactive budget changes for work that's already completed. You can't just re-budget work-in-progress activities arbitrarily. And you can't transfer work or budget independently of each other. This level of discipline ensures that your baseline, and therefore all your metrics, retains its integrity.
And this rigor is paramount because of something called the iceberg syndrome.
This is one of the most sobering truths in project management.
What is it?
Cost reductions are most readily available very, very early in the project lifecycle, during initiation and planning. The cost of making changes increases exponentially as the project moves downstream.
So if you find a requirement flaw during planning, fixing it might cost, say, $10.
Right.
But if you find that same exact flaw during the testing phase, fixing it might cost $100,000.
Precisely. The cost of late changes can easily exceed the original cost of the entire project. The iceberg analogy is so potent, the problems only become fully evident late in the game when they are too big and too late to be solved easily, leading to those astronomically high correction costs.
Which underscores why the owner, the manager, and the contractors, they have the greatest influence on costs and changes during those earliest planning phases.
Your power to influence the final outcome diminishes dramatically every single day after the project starts.
Okay, let's dig deeper into the MCCS operating cycle. Let's start with phase 2, work authorization and release.
Right.
This is the stage where the budget actually gets unlocked and assigned to the functional groups.
This phase is initiated by a formal work description document. You can think of this as an internal contract. It details the narrative, the organization, the time frame for specific WBS elements.
So this document authorizes program management to proceed.
And it formally releases subdivided work to the functional units, authorizing them to spend resources, but only within a defined timeline.
This authorization relies on the creation of work orders.
Yes. A work order number is required for all in-house direct and indirect charging. And it's really important to note the specific metric used here. Work orders specify hours, not dollars.
Hours, not dollars. Why?
They establish the physical targets, the amount of effort that the program office expects the functional department to actually hit.
And the focal point where all this data collection converges, the operational nerve center, is the cost account.
The cost account is, in a way, the conceptual genius of MCCS. It's the intersection point of your work breakdown structure, the WBS, and the organizational breakdown structure, the OBS.
So this is the level where responsibility is formally assigned.
Exactly. It's where, say, Jane's welding team from the OBS meets task 3.1.2, frame assembly, from the WBS.
So the cost account is where we actually compare the actual costs to the work performed for management control purposes.
Precisely. Now, a cost account may be made up of several work packages, which are these detailed short-span jobs. The actual cost doesn't have to be reported down to the work package level.
The costs can be rolled up.
They can be rolled up to higher levels in the WBS. This aggregation of cost data from smaller units into larger control units is what we call cost aggregation.
Okay, moving to phase 3, cost data collection. Here we're accumulating the actual cost, the ACWP, and the budgeted cost for work performed, the BCWP monthly, in these detailed cost accounts.
And while those monthly reports are essential for formal analysis, the sources highlight a really critical early warning tool.
Which is?
Weekly supplemental direct labor reports. Direct labor is often your highest or at least most volatile cost. These weekly reports give you current month subtotals.
So the PM can quickly detect unfavorable trends.
Exactly. In cost or performance before the detailed backward-looking monthly report arrives. It gives you a window to implement contingency plans proactively.
We should probably understand the 4 primary categories of cost data that are accumulated.
Right. We track labor, material, other direct charges, and overhead. The PM maintains reasonable direct control over the first 3.
But overhead is different.
Very different. Overhead costs, things like facilities, utilities, corporate services, are typically calculated yearly or monthly based on broad formulas and then applied retroactively to all the applicable programs.
Which means the PM has very little direct real-time control over that overhead rate.
Almost none.
Okay, let's get into the budget components, which require absolute traceability through a budget log. We can start with the simplest one, the distributed budget.
That is your normal performance time phase budget that's released through the cost accounts and work packages. It's the money you are planning to spend on all the planned, defined activities within your project scope.
Okay. Now let's tackle the crucial distinction, the management reserve, or MANR.
The management reserve is established for your known unknowns or contingencies that result in special out-of-scope work for the performers.
It's basically the budget set aside to address unforeseen risks that actually happen.
That's it. And this is critical. MR has to be based on the project's assessed risk, often ranging from, say, 0 to 15% of the total budget.
And the fundamental rule, MR is explicitly not part of the distributed budget or the cost baseline. Why is that?
Because your budgets are established on the assumption that they will be spent. Management reserve is money you actively try not to spend.
So if you spend MR, it signifies a risk has materialized.
Precisely. Furthermore, How you handle unused MR depends heavily on the contract type. On a firm fixed-price contract, any unused MR typically converts to extra profit for your organization.
But on a cost-reimbursable contract?
The unused MR may be returned directly to the customer, meaning you, the PM, are fiscally incentivized to manage risk as effectively as possible.
What about the other budget components we see?
Well, we have the undistributed budget. This is budget that's associated with contract changes or special tasks where time constraints prevent the detailed planning needed to incorporate the change into the normal performance budget right away.
So it's a temporary holding spot for funds.
Exactly, for defined work that hasn't been broken down at the WBS and cost account level yet.
And finally, the unallocated budget.
The unallocated budget represents a logical grouping of contract tasks that haven't been fully identified and authorized yet. It's work that the contract dictates, but the specifics, and thus the budget detail, are still pending clarification from the customer or internally.
Understanding this budget traceability is just essential for maintaining a transparent, auditable control system.
Yeah, absolutely.
So we have the MCCS structure providing data traceability. But data alone isn't analysis.
Right.
We need a system that fundamentally changes how we interpret that data.
Right.
And this leads us to the most sophisticated control tool, the Earned Value Measurement System, or EVMS.
We needed EVMS because, frankly, early project management was terrible at answering the simple question, what is our true status? Take that example from the sources. A $1.2 million project, 6 months have gone by, you've spent $700,000.
That's 58% of the budget gone.
Yeah, right. But how complete is the work? Often, managers would just report they were 58% complete, simply based on expenditures, which led to disastrous surprises down the line.
Right. Just because you spent 58% of the money doesn't mean you completed 58% of the work. You could have just paid a lot for raw materials or had massive labor overruns early on.
Exactly. The government wanted costs managed, not just reported.
And EVMS solves this.
It does, by relating resource planning directly to schedules and technical performance. It's a systematic process that uses earned value as the primary tool for integrating cost, schedule, technical performance, and risk management into one single holistic view.
The genius is that it introduces a standard performance baseline that quantifies the work completed regardless of how much money you actually spent.
That's the core of it. It uses 3 key input metrics. First, there's plan value, or PV. It used to be called BCWS. This is the approved budget assigned to the work scheduled to be completed by a certain date.
Okay. Second is actual cost, or AC.
Right, formerly ACWP. This is simply the actual amount of money spent on the work completed to date.
And the revolutionary metric.
Earned value, or EV, formerly BCWP. This is the calculated value of the work you've actually completed. So if a $100 task is 50% complete, your EV is $50.
Regardless of whether you spent $40 or $80 on it.
Exactly. And by comparing these 3 numbers, EVMS instantly provides its core benefit. It's an early warning system that is undeniable.
It provides an accurate display of project status and an early identification of trends and problems.
Which is the basis for course correction. It emphasizes prevention over cures. If you find a variance when it's small, you can make a small, easy adjustment.
And those early small course corrections are the lifeline of the project.
They really are. If variances become large, they are incredibly difficult to fix. The cost of correction, that's the iceberg syndrome again, might displease management to the point where they just cancel the whole project.
So EVMS has to be used continuously.
Continuously, to detect and manage these small deviations before they can snowball.
Let's detail the 2 critical variances you can derive from these inputs.
Okay, first we have the cost variance, or CV. This tells you if you are over or under budget for the work you've completed. It's calculated by subtracting actual cost from earned value.
So CV equals EV minus AC.
Right. If the CV is negative, you're over budget. If it's positive, you're under budget. Simple.
And second, the schedule variance, or SV.
This tells you if you are ahead of or behind schedule. It's calculated by subtracting planned value from earned value. So SV equals EV minus PV. If SV is negative, you are behind schedule.
This really is genius. A single number tells you where you stand on 2 fronts.
It does. For example, if you have a positive CV but a negative SV, that means you're under budget but you're behind schedule.
A common scenario where the team is being too cautious with spending.
Or waiting on materials. But if both are negative, you're over budget and behind schedule, which signals a critical crisis.
But the real power of EVMS, it seems, lies in the performance indices. They're predictive, not just descriptive. What are the 2 core indices?
We have the cost performance index. or CPI. It's calculated as earned value divided by actual cost.
CPI equals EV divided by AC.
Right. This is your efficiency metric. It tells you how much dollar value you are earning for every dollar you spend. If your CPI is 1.0, you're earning exactly $1 of work for every dollar you spend.
But if your CPI is, say, 0.8,
that means you are only earning 80 cents worth of work for every dollar you spend. And this index is strongly predictive. If your CPI stays at 0.8, you can predict that every dollar of future planned work will actually cost you $1.25.
which allows the PM to immediately forecast the final expected cost of the entire project rather than just waiting until the end to find out they're broke.
Exactly. And the second index is the Schedule Performance Index, or SPI. It's calculated as earned value divided by planned value.
So SPI is EV divided by PV.
Correct. This shows the work you've accomplished versus the work you would plan to accomplish. If your SPI is 1.0, you are meeting the schedule. If it's 1.2, you're ahead of schedule, completing 120% of the planned work in that time.
So if my SPI is 0.9, I'm only accomplishing 90% of the work I plan to accomplish, which means I need to accelerate if I want to hit that finish line on time.
Precisely. EVMS transforms management from reactive tracking into proactive forecasting. It just cuts through all the ambiguity to answer the 5 most critical questions for any project manager.
Which are?
What is the true status? What are the problems? What can be done to fix them? What is the impact of each problem? And what are the present and future risks? It turns raw cost data into management intelligence.
This deep dive has really highlighted the twin pillars of project success.
Mm-hmm.
We started with the qualitative demands of directing people appealing to pride, mastering those 7 elements, gaining respect.
Mm-hmm.
And we finished by dissecting the stringent quantitative demands of controlling systems like MCCS and the predictive genius of EVMS.
And the takeaway here is that success is entirely about managing that tension. The PM has to balance the intrinsic leadership needed to motivate a temporary team with the relentless, objective discipline required to enforce standards across that integrated triple constraint of time, cost, and performance.
And that tension is most acute when it comes to power. The authority of a project manager is always a negotiation. It exists in that delicate space between the legal authority granted by the project charter and the sheer power earned through credibility and respect from the very subordinates they need to drive execution.
You have to earn your leadership every single day, even when the clock is ticking down.
Absolutely.
The PM has to navigate that complex web of relationships while being fully grounded in the rigorous financial reality that's revealed by the cost account and the predictive metrics of earned value.
So here is a final provocative thought for you to carry forward, building on the severity of that iceberg syndrome. Given that the cost of corrections rises exponentially the later they occur, how might a project manager structure their initial planning phase, specifically using the project charter and the responsibility assignment matrix, to ensure that the fundamental conflict resolution about what and when, which is the PM's mandate, versus how, the functional manager's mandate, happens before the first shovel ever hits the dirt, thereby minimizing those catastrophic downstream surprises?
Finding that sweet spot between functional expertise and project deadlines, that's the secret to avoiding the iceberg altogether. Thank you for joining us for the deep dive.
We'll see you next time. Welcome to the Deep Dive, the place where we cut through the noise to get straight to the critical insights you need. Today, we are undertaking a major operation. Project mastery. We are diving into the complex mechanics of how successful projects are not just measured, but actively controlled, predicted, and corrected.
That's absolutely right. And our sources today give us a really comprehensive look at the duality of modern project success. We're going to start with the quantitative backbone.
Yeah.
The cold, hard metrics of earned value management, EVM. We'll focus on variance analysis and robust forecasting.
But then we make a critical transition.
We do. We move into the human element, the necessary leadership and the non-negotiable ethical frameworks required to successfully deliver on those metric-driven plans.
And for listeners who are already familiar with the basics, PV, EV, AC, we are going to go deeper. We're arming you with the precise terminology, the detailed calculation methods that major government contractors and enterprises actually use, and then the essential ethical foundations that define a truly great project leader.
We're starting with what is essentially the universally recognized financial language of project status reporting.
Right. So before we can even begin to talk about deviation, we need to establish a very clear, unambiguous baseline for measuring effort. Our source material really emphasizes that work has to be categorized into 2 primary forms. Let's start with the most common one, measurable efforts.
Measurable efforts are, well, they're the core work of the project. They are these discrete increments that have clear, tangible results and a definable schedule. Think about achieving a specific feature integration or installing a piece of hardware or maybe completing a specific test protocol.
You can point to it. You can say, that's done.
Exactly. You can point to the end result and you can calculate the progress objectively. There's no guesswork.
Which you can't really do with the other category, level of effort. That's always more ambiguous.
Level of effort, or LOE as it's called, is that ongoing resource consumption-based work that doesn't easily subdivide into those tangible increments. This includes things like overall project support or, certain elements of routine supervision or even project control itself.
So the work of managing the work.
Pretty much. The crucial distinction is that LOE produces no single measurable end product. Its value is derived simply from the passage of time and the sustained presence of a resource. And you have to track variances for both types of effort, but the calculation method for LOE is based purely on scheduled time, whereas measurable effort is based on physical progress.
Okay, so to measure both, we need to define the 3 foundational cost acronyms that form the basis of all earned value calculation. And we should reiterate something you touched on. Although the PMI has introduced some newer, maybe simpler nomenclature, the source material confirms that the majority of heavy industry users,
Especially in large-scale government contracting.
right, they still rely on the established acronyms. So we're going to stick to the older terms for precise detail.
Let's start with the baseline, the planned value. What does the budget say we should have achieved by a certain date?
That would be the BCWS budgeted cost for work scheduled.
BCWS is the total time-phased budget plan, also known as the planned value, or PV. It represents the cumulative budgeted amount for all work. Measurable effort, level of effort, any apportioned effort that's scheduled to be accomplished within a specific reporting window.
So it's the yardstick.
It is the yardstick. Everything else is measured against it. And it's critically determined at the lowest working level, the cost account level, by totaling up the budgets for individual work packages and in-process work.
So BCWS is the planned spend. Now, how do we measure what we actually achieved in terms of value?
That brings us to our second term, BCWP, budgeted cost for work performed. This is the official earned value, or EV. It represents the dollar value of the completed physical work, plus any budgeted level of effort or apportioned effort activity that was completed.
So if a task was budgeted for $1,000 and you complete it,
You've earned $1,000 worth of value. It doesn't matter if you spent $800 or $1,200 to get it done, the value you've earned is $1,000.
which leads directly to the third term, ACWP, actual cost for work performed.
ACWP is the simplest component, really. It represents the actual cost, or AC. It is the amount reported as actually expended in completing the work accomplished within that time period. This includes labor, materials, any indirect costs, whatever was charged to that work package.
What I find fascinating, and our sources really drill down on this, is the instruction regarding the development of the BCWS itself. It's not meant to be some static theoretical number, is it?
Not at all. And this really speaks to the realism that's required in project planning. The contractor must utilize what's called anticipated learning when developing the time-phased BCWS.
Anticipated learning, so you're building in efficiency gains from the start.
Exactly. If historical data suggests the team will become, say, 15% more efficient on a repetitive task after the first 2 months, the budget for months 3 and 4 must already reflect that expected improvement. The BCWS is established to reflect as closely as possible the expected actual cost that will be incurred.
So it's meant to be a realistic, dynamic prediction, not just an arbitrary, flat baseline.
It has to be, because if the baseline is flawed, all subsequent variance analysis is, well, it's meaningless.
Okay. So once we have those 3 points, BCWS, our planned value, BCWP, our earned value, and ACWP, our actual cost, we can finally calculate the variance, which is just any deviation, whether it's schedule, technical, or cost from that established plan. Let's start with the one most people immediately worry about, cost deviation.
That is the cost variance, or CV. This measures cost efficiency. And the formula is simple. CV equals BCWP minus ACWP.
And if the result is negative, you're in a cost overrun condition. You spent more than the work you earned was budgeted for.
Right. And a positive CV is favorable, which means you accomplish that progress more efficiently than you forecasted.
What does that mean physically, like on the ground for the project manager?
Physically, CV is the measurement of the efficiency with which you completed the work. So if you have a severe negative CV, the manager's immediate priority is to examine the burn rate and the resource utilization. Are materials being wasted? Is labor taking too long? Is the labor rate itself too high? You're focused entirely on productivity.
And the second major metric is the schedule variance, or SV.
SV is calculated as BCWP minus BCWS. This compares the value of the work you completed against the value of the work you should have completed by now.
So a negative SV means you are behind schedule. You earn less value than you planned to by this point. Positive means you're ahead.
And physically, SV measures the timeliness of the physical progress compared to the plan. If your SV is negative, the manager has to focus on improving the speed of execution. They need to address bottlenecks, resource allocation, sequence dependencies, anything to catch up.
Let's just revisit that simple numerical example from the source material to make the distinction really sharp.
Yeah.
BCWS was $1,000, BCWP was $800, and ACWP was $700.
Okay, so CV, the cost variance, is $800 minus $700, which is positive $100. That's favorable. You are highly efficient. You only spent $700 to accomplish $800 worth of budgeted work.
Fantastic. But the schedule variance, SV, is 800 minus 1,000, which is negative 200.
Unfavorable. You only accomplish 80% of the work you were supposed to. You are behind schedule, and the management implication here is crystal clear. Stop worrying about cost cuts. You're already efficient. And immediately focus all your effort on expediting the remaining work to catch up on the schedule.
But this is where we have to introduce the biggest challenge to the EVM system, one that our sources stress over and over again, the fundamental limitation of schedule variance.
This is a critical point. It often causes a lot of confusion. SV is measured in dollars or hours. It's a financial metric. It doesn't inherently relate to the real schedule duration in days or weeks. And most importantly, it does not distinguish between critical path work and non-critical path work.
So a project manager could have a massive negative SV because they delayed painting the break room, which has zero impact on the final delivery.
Exactly.
But the critical path activities are moving smoothly, so the EVM system is screaming danger, even though the project is actually fine.
Precisely. The actual scheduling tools, the precedence diagrams, the real critical path network, might show the project is actually ahead of schedule, or at least on track, despite that negative SV. Therefore, SV is primarily a powerful warning light for financial timeliness. It tells you less work was accomplished than planned, but it requires a supplementary analysis of the true critical path to determine the real impact on the final delivery date.
So given that pretty major limitation, why do government contracts and big enterprises still mandate SV reporting? Is it just bureaucratic inertia?
I don't think so. It serves a unique and essential purpose that those precedence diagrams miss: financial accountability and standardized reporting. A customer or senior management needs a single, universal metric that can aggregate performance across wildly different technical work packages. From software development to pouring concrete, and report it in a standardized monetary format.
I see. So it may not tell the PM where to expedite.
Right, but it tells the executive how much less value was earned than what was paid for, which is a key measure of contractual performance, regardless of what's on the critical path.
And this inherent limitation is why we often move away from these raw dollar variances, the CV and SV, and start looking at ratios, the performance indices.
Exactly. We use ratios to determine efficiency and trends without disclosing sensitive actual dollar amounts to customers or other departments. And we have two main ones: the Cost Performance Index, CPI, and the Schedule Performance Index, SPI.
CPI is BCWP divided by ACWP.
And SPI is BCWP divided by BCWS.
The interpretation is simple. 1.0 is perfect performance. But let's make that tangible for the listener. What does a CPI of, say, 0.8 actually mean?
A CPI of 0.8 means that for every single dollar you have spent, you have only earned 80 cents of budgeted value. You are literally losing 20 cents on the dollar. Conversely, an SPI of 0.9 means that you've only accomplished 90% of the work value that you scheduled to achieve by this date. They're powerful early indicators, often used as leading indicators for performance trends.
Right. Which brings us to how these are actually used for control and forecasting.
Yeah, these metrics are not theoretical. They are the active levers of project control. Variances are the critical items that get reported up the chain of command. However, the definition of what makes a variance critical is highly flexible. It's tailored to the project environment.
And the source material is really detailed here. It notes that the permitted variance thresholds, they vary based on the life cycle phase, the project length, the type of estimate used, and critically, the organizational hierarchy. The higher you go, the lower the tolerance. Absolutely. Consider the sample variance criteria the source outlines. At a section manager level, They might only have to submit a formal report if the variance is over $20,000 and it exceeds 25% of the cost account budget.
So they have a high tolerance for small amounts.
Right. But if that variance gets aggregated up to the division level, a variance greater than, say, $1 million might only need to exceed 10% of the cost to become critical. Management expects extremely tight control on high-value spending.
And the risk profile itself influences tolerance. The variance boundaries are not fixed throughout the project's life.
This is so crucial for managing stakeholder expectations. In the early stages of a high-risk program like R&D or early concept design, management permits larger deviations because uncertainty is inherently high. But as you move into the production or qualification phases, the risk is supposed to decrease. And that means the variance boundaries are reduced. You're expected to tighten up performance as the project matures and stabilizes. This emphasis on dynamic control naturally leads to trend analysis. We aren't just looking at this month's numbers, we're looking at the trajectory using CPI and SPI.
Exactly. These indices are the project's early warning system. Managers frequently use moving averages, 3-month, 4-month, or 6-month windows to smooth out the noise and identify underlying trends. If the CPI is fluctuating, but its 3-month moving average is consistently dipping further below 1.0, you have a systemic cost problem that needs correction now, before the cost overrun becomes massive and irreversible.
But using trend analysis requires time, right? Time for the corrective action to actually take effect.
Which is why trend analysis might be restricted to very long-term projects. If a project lasts only 6 months, you won't have 3 months of trend data followed by 2 months to implement and verify a corrective action. In that case, you need rapid, immediate intervention instead.
All of these metrics, they all integrate into one system. The source provides a useful illustration of this. You could have a significant schedule slippage, so performance is far less than scheduled. That's a big SV problem.
Right. But if the actual costs are proportionately underrun, meaning the slippage happened efficiently, the situation is far less severe than if costs were simultaneously overrun.
And you still have to check against the overall contract budget.
Always. An integrated report might show an internal cost overrun against the established performance budget. But if that amount is still covered by the management reserve, that buffer set aside for unforeseen events, the contractual status with the customer remains healthy. The project is struggling internally, but it hasn't broken the contract terms yet.
So when variances are exceeded, the process demands formal accountability. This is where the cost account variance analysis reports come in. These reports force the manager to answer the essential questions.
And these 5 questions are really the management checkpoint. 1, what is the root problem causing the variance? 2, what is the impact on time, cost, and overall performance? 3, what are the impact on other related efforts? 4, what specific corrective action is planned or currently underway? And finally, 5, what are the expected results of that corrective action? The point is to prevent the manager from just stating a number. They have to analyze, correct, and then forecast the result of their correction.
Okay, we've established the formulas, but the main difficulty is always the input accurately calculating the BCWP, the earned value, for work that's still in progress. How do project managers quantify partial progress without just, guessing?
This is where the art really meets the science of EVM, and it often involves standardized shortcuts. The formula is conceptually simple. BCWP equals the percentage complete multiplied by the budget at completion, or BAC. But judging that percentage complete is highly subjective. The source strongly prefers calculating the percent work complete, which requires a schedule loaded with specific resources over the simpler, less accurate percent duration complete.
So to eliminate that subjective judgment for smaller tasks, companies adopt standard BCWP calculation techniques. Let's look at the 50-50 rule.
The 50-50 rule is highly common, especially for projects with lots of small elements, where detailed tracking is just too cumbersome. 50% of the budget for a task is earned when the task is scheduled to start, and the remaining 50% is earned only when it is 100% complete. It minimizes the managerial effort of having to do a continuous percent complete determination.
But doesn't that 50-50 rule inherently invite risk? I mean, especially if a project starts all its tasks but then stalls halfway through them, you'd be claiming 50% earned value but have delivered nothing tangible.
That is the trade-off. It is an administrative simplification. It works best for a large volume of tasks that are relatively short in duration. For tasks that are very short, say less than a month, the 0-100 rule is generally used. 0 value is earned until the activity is 100% complete. This protects against that very risk of claiming half value for partial work.
And then you have the more detailed approaches for those long-duration packages.
Right. If a package lasts 3 months or more, and there are no natural checkpoints, the PM might have to rely on the subjective percent complete method, relying on their judgment or maybe independent audits. More accurately, if the package has identifiable interim control points, they'll use the milestone technique, where value is assigned to those specific checkpoints.
Let's just clarify the difference between the two non-discrete efforts we mentioned earlier. Level of effort, LOE, versus apportioned effort.
LOE, as we discussed, is something like supervision or project control. Value is earned based purely on the time expended over the total scheduled time. So if the supervision job is budgeted for 100 hours over 4 months, 25 hours are earned each month, regardless of what the supervised teams accomplish.
It's just time passing.
It's just time passing. Apportioned effort, however, is different. It is work that is in direct proportional support of another measurable work package.
Can you put us a clear example of apportioned effort?
Sure. If you have a specific production package being tracked, and there is a mandatory regulatory compliance inspection required for that package, the inspection effort might be designated as apportioned. If the production package earns 100% of its value, the inspection package earns 100% of its value concurrently. The source warns very strongly against trying to use this technique for standard supervision. That must remain LOE.
Okay, so once we have the current status, the most vital function of EVM kicks in, forecasting the finish line, or the estimate at completion, EAC.
The EAC is the manager's best estimate of the total cost at project completion. It is a dynamic forecast, usually updated monthly. The calculation itself is, well, it's a declaration of confidence in future performance. The core difficulty is choosing the right formula, because the assumptions inherent in that choice will produce very different final costs.
Let's use the source's example to make this clear. The budget at completion, BAC, is $3,000. The actual cost to date, ACWP, is $1,900, and the earned value, BCWP, is $1,500. So we're already over on cost and behind on schedule.
Right. So if we use Formula 1, EAC equals ACWP divided by BCWP times BAC, this assumes that the cost inefficiency, the current burn rate that we've experienced so far, is systemic and will continue for the remainder of the project. If you believe the root causes of the overrun are structural, unfixable, or maybe just due to poor estimating, this is the right formula. Using the numbers, the EAC result is $3,800. This is the most pessimistic, but often the safest forecast.
Okay, then there's Formula 2, which is a little more optimistic.
A little. Formula 2 assumes that all work not yet begun. The remaining scope will be completed at its planned cost. So it effectively assumes a correction has occurred, or will occur, but it acknowledges the past damage. The formula is a bit more complex, but in essence, it assumes the cumulative cost performance index will only apply to the work already started. The resulting EAC is $3,533. This is often used when a PM thinks they've fixed the core problem, but the benefits won't extend to activities that are already underway and, damaged.
And finally, Formula 3, which places a lot of faith in managerial intervention.
A lot of faith. Formula 3, EAC equals ACWP plus the remaining work at planned cost. This assumes that all remaining work, regardless of its current status, is independent of the inefficiency incurred so far, or that the PM is so confident in their corrective action that all future work will meet the original budget plan. The result is the most optimistic, $3,400. A project manager has to justify this choice to management, proving that a major process change, new resources, or some leadership intervention has completely reset the playing field.
This complexity is beautifully illustrated by the Project Z, Task 3 deep dive in the source material. The initial analysis showed a $20,000 negative cost variance in burdened labor costs, which just screams, stop wasting money.
That's the surface reading, absolutely. But the detailed drill down, the analysis of hours versus dollars, it revealed a deeper truth. The budgeted labor rate was $27.86 per hour, but the actual rate was $32.24 per hour. The problem wasn't efficiency, it was cost mix. They were using higher salaried people than they planned to.
And yet, simultaneously, the team had a positive variance of 409 direct labor hours.
Which is the core insight. The higher cost employees were performing favorably on the learning curve. They were performing the task faster and more effectively than the lower wage employees they were budgeted to replace. So the negative dollar variance was a labor rate problem, not an efficiency problem. The manager's conclusion was that while the work was progressing almost on schedule, the increased cost dictated that direct labor hours still needed to be reduced even further to protect profitability.
A very different action than just firing the efficient, high-salaried team members.
Completely different. And that detailed analysis of cause and effect is the difference between simply reporting a negative number and actually managing a project. And managers can quantify the degree of difficulty in hitting that revised target using something called the To-Complete Performance Index, or TCPI.
TCPI, okay, what does that show us?
The TCPI shows the future cost performance necessary to complete the remaining work within the current financial goals. The formula is basically the work remaining divided by the budget remaining. This tells the manager, based on what we have left to spend, what CPI do we need to achieve from this point forward just to hit the original budget at completion? If that required CPI is 1.2, it means you have to achieve 20% better efficiency than planned for the rest of the project. If it's 1.5 or higher, well, the budget is likely unattainable without a major scope or funding intervention.
Okay, we've thoroughly covered the math. We understand BCWS, BCWP, CV, SV, the EAC formulas, the TCPI. But as that Project Z example showed, these metrics are only as good as the leaders interpreting them and driving the change. So now we transition to the massive cultural shift in project management leadership.
And leadership is defined as a style of behavior designed to integrate the organizational requirements with the personal interests of the team toward achieving the project objective. Historically, the approach to project leadership was split, often depending on the organizational structure.
The first one, identified in the Hodgett survey, was the human relations-oriented approach. This was about influence, empathy, and recognition.
This approach was very popular in matrix organizations, where the PM often lacked direct hierarchical authority. They had what's called the authority gap. The PM had to be a master of making team members feel important, providing credit for success, and knowing people personally to understand their unique needs. It was all about earning loyalty to overcome the lack of formal power.
And you contrast that with the formal authority-oriented approach.
This was the classic command and control style. It relied heavily on organizational power structures, using the implicit threat of high-level intervention, maintaining strict control over expenditures, and making sure team members recognize the PM's official charter to direct the project. This style prioritized structure and compliance above all else.
But the sources stress that modern project success relies on a transformation away from that traditional formal authority model and toward value-based project leadership. What drove this seismic shift?
Several factors all converged. Firstly, project management became a full-time profession. It started being viewed in strategic business terms, not just tactical engineering terms. Secondly, new projects are fundamentally different. They're highly complex, uncertain, often accepting risks they don't fully understand, and they're constantly pressed for speed to market. The statements of work, the SOWs, are frequently ill-defined, based on flawed assumptions and targeting a moving goalpost of value.
So the project environment just became too chaotic and complex for a rigid command and control leader to handle.
Precisely. If a Project Z analysis reveals a labor cost problem, a formal authority PM issues a directive: cut costs. A transformational leader diagnoses the underlying learning curve issue and collaborates with the team to strategically optimize efficiency. The changing values reflect this. We've moved from a culture based on mistrust, job descriptions, and power and authority to one based on trust, competency models, and teamwork.
And the ultimate goal of that cultural shift is moving away from simple compliance and toward real commitment.
And there's a huge difference. Compliance is mandatory adherence to rules, often enforced by the threat of punishment. Commitment is a deep internal buy-in to the goal. It's driven by personal recognition and the belief that the project's success is tied to one's own success. And you absolutely need commitment when the project is volatile and requires team members to constantly go above and beyond their basic job descriptions.
This brings us to transformational project management. When are PMs required to become these change agents?
Transformational leadership is required whenever employees must be removed from their comfort zones. Think of launching a new, complex, corporate-wide IT or accounting system. The PM who managed the development of that system is now required to stay on and drive the full corporate-wide implementation. They are responsible for the cultural adoption, not just the technical go-live date.
So that means the focus shifts heavily to managing the people side of change and resistance.
Heavily. Absolutely. The PM has to become adept at diagnosing where that resistance is coming from. Is it fear of job loss, inertia, or just a simple lack of understanding? They can't just mandate compliance. They have to create a compelling vision, build a guiding coalition of champions, identify and reward early successes, and institutionalize the new methods to prevent backsliding. This is about establishing a new way of working, a new set of values across departmental boundaries, creating those boundaryless systems the sources mention.
Ultimately, the transformational PM is balancing the needs of four distinct groups simultaneously. The PM themselves, who's seeking accomplishment.
The team members, seeking achievement and recognition, the organization, seeking continuous improvement and profitability, and the stakeholders who are seeking usefulness and financial growth. You cannot balance those conflicting needs with mere formal authority. It's impossible.
And that intersection of competing values brings us to our final and arguably most important area, integrity. We talked about how the best EVM metrics can't fix a project if the culture is ruined. It takes one bad ethical decision to dismantle years of trust.
And the sources define adversity in this context as internally or externally driven ethical dilemmas. Let's expand on the internal pressures. Those situations where people inside your own company ask you to compromise your integrity, supposedly for the company's benefit.
Can you give us a detailed example of an internal dilemma? Maybe treat it as a kind of mini case study?
Sure. Consider the pressure to lie to secure a contract. A manager is told that if they state the project will only cost $8 million, they'll win the bid, even though the internal detailed estimate is $10 million. The internal logic is, we need the work, we'll find a way to cut costs later. If the manager agrees, they violate the principle of honesty, and they set up the project for certain failure, often requiring subsequent cost overruns or scope reductions that just damage the customer relationship anyway.
And then there's the other pervasive internal issue, withholding bad news. The schedule slipped for 10 months, hoping for a miracle example.
Right. In that situation, the PM is acting to protect themselves and their team from immediate backlash. But what's the long-term ethical consequence?
You were later labeled a liar.
Exactly. The PM substitutes their short-term hope for professional responsibility. They believe they are buying time, but what they're really doing is eliminating the organizational window for effective corrective action, which guarantees a worse outcome later. By the time the slip is revealed, it's often catastrophic, and the PM has destroyed all faith in their reporting, damaging not only their own career but the reputation of the entire project management office.
And what about external adversity when it's driven by a customer?
This is when the customer asks you to compromise integrity for their benefit. They might ask you to lie in a proposal to make their internal approval process easier, for example, assuring them that a resource-heavy feature can be delivered cheaply. Or, in a more extreme case, asking you to hide damaging information during a legal dispute. This puts the PM in the impossible position of choosing between contractual partnership and professional ethical conduct.
The sources outline the adverse impact of seemingly minor decisions, too, like the manager who refused to release an assistant for a promotion.
That PM was protecting their 3-month schedule, and their project stayed green on the dashboard. But they earned a reputation throughout the entire company for suppressing talent. They created a toxic environment where high performers realized success meant moving away from that manager, not toward them. The immediate win-lose scenario, the project wins, the assistant loses, became a huge long-term cultural loss for the company.
Another toxic outcome is the example of the PM demanding excessive overtime to meet some artificial deadline.
That high-pressure environment led directly to a fatigued worker making a $55,000 mistake and then being subsequently fired. The PM's adherence to the schedule was achieved, but at the cost of a team member's job, a massive financial mistake, and creating a culture of fear, which guarantees that future mistakes will be hidden rather than reported. It just perpetuates the cycle of failure.
This inherent conflict requires a formal framework, which is why the PMI Code of Ethics and Professional Conduct is so vital.
The code applies to everyone in the project environment, and it's divided into both mandatory standards, which are hard rules, and aspirational standards, which is how we strive to conduct ourselves.
Okay, the first of the 4 sections is responsibility.
Responsibility means taking full ownership for our decisions, whether we make them or fail to make them, and accepting the resulting consequences. This is about accountability, reporting problems truthfully, and correcting errors promptly.
The second is respect.
Respect involves regard for ourselves, the people we work with, and the resources provided, whether they're physical or human. This includes fair compensation, not demanding unreasonable hours, creating an inclusive environment, and respecting the privacy and data of others.
Third, fairness.
This mandates objective, impartial decision-making. Actions must be free from favoritism, prejudice, and most crucially, from any conflict of interest.
And finally, honesty.
Acting in a truthful manner, communicating accurately, and refraining from engaging in any deceptive practices. If you don't know the answer, say so. If the project is running over, report the true EAC.
That discussion on conflict of interest is essential for large enterprises.
It is. A conflict of interest is any situation where the individual stands to gain personally from a decision they make on behalf of the project or the company.
What are some of the less obvious forms of personal enrichment that would constitute a conflict of interest?
It goes way beyond simple bribes. It includes using insider project knowledge, say, knowing a supplier is about to be dropped, to inform your personal stock trades. It involves mischarging time, improperly allowing employees to charge their non-project time to the project budget. It involves receiving unjustified compensation or actively providing false information just to keep a project alive and thus protect your employment or your eligibility for a bonus.
And what about inappropriate connections? The source mentions seemingly minor perks like free meals or low-interest loans.
These are subtle influences. Accepting free tickets, meals, or entertainment from a key vendor who is currently bidding on a $10 million contract creates a perception of obligation, even if the PM believes they can remain impartial. The PM has to maintain objectivity. This also extends to family affiliation, using privileged or insider information gained through a personal connection to gain an advantage in a business situation.
So the standard guidance on accepting gifts, therefore, have to be extremely stringent.
Correct. The professional standard across most global corporations is generally to avoid all gifts. If gifts are permitted by company policy, there are strict financial limits, often just nominal and mandatory disclosure requirements. The goal isn't to be impolite. It's to eliminate any perceived or actual compromise of impartiality.
Ultimately, the professional responsibility of the PM is to be the frontline defense for the company's integrity.
It requires truthful representation and full disclosure of all project information, good or bad. It mandates the protection of proprietary data and trade secrets. And critically, it requires timely reporting of violations and full compliance with any auditing groups. The failure to uphold these standards can instantly replace a required culture of trust with one based on formal documentation and suspicion, ensuring that future projects are managed by mistrust rather than commitment.
This deep dive has really shown that project mastery is this constant juggling act between the mathematical rigor of earned value management and the psychological complexity of ethical leadership.
That's the perfect summary. Success is not magic. It demands the diligent tracking of hard metrics, using CPI, SV, and choosing the appropriate EAC formula that reflects your leadership assumptions, while simultaneously fostering a cultural shift from compliance to commitment and away from bureaucracy and formal authority. The ethical dilemmas are constant, and the PM's role is often the last barrier protecting the long-term health and integrity of the organization over any short-term gain.
We've covered the ABCs of EVM, the critical difference between CV for efficiency and SV for timeliness, the required use of trend analysis via CPI and SPI, and the nuanced assumptions behind those three estimate at completion formulas. We also explored the necessity of transformational leadership in today's complex project environment and the essential role of the PMI code in guiding professional conduct.
And knowledge is only valuable when it's understood and applied. The ability to use that Project Z analysis connecting a negative cost variance to a positive learning curve is just as important as the ability to foster a culture where employees feel safe reporting those variances truthfully in the first place.
Final provocative thought for the listener. We know that the schedule variance, or SV, doesn't capture the real impact of a delay because it ignores the critical path. If you had to choose only one index, the efficiency, which is CPI, or the timeliness, SPI to forecast whether a project with a lot of non-critical path work will ultimately succeed, which ratio provides the most valuable insight for managing cost risk, and why? That's the question you should be analyzing as you apply these concepts this week. Welcome back to the deep dive. Think about any massive endeavor from, aerospace manufacturing to building a new bridge. Every single one of those projects, at its core, it all comes down to a formal written agreement. And that document isn't just legal boilerplate. It is the ultimate expression of how risk gets negotiated. It defines who pays when things go wrong.
And who profits when things go right, exactly.
Yeah.
And this deep dive is really tailor-made for you if you're navigating that procurement landscape. It doesn't matter if you're the buyer trying to protect your budget or the seller trying to lock in your profit margins.
Right.
We've pulled together all the essential frameworks here, everything from procurement strategy, the intense mechanics of incentive contracts, even the psychology of negotiation, and then how you structure your organization to manage it all.
So our mission today is to give you that strategic advantage. We're going to cut through the jargon to show you how these massive organizations formally allocate risk, how they manage cash flow, and how they set themselves up for success in these huge multi-million or even multi-billion-dollar deals. Okay, so let's unpack this. When a contractor sits down to prepare a bid, they're not really starting with labor hours and material costs. They're starting with risk.
The risk comes first, always.
The cost is secondary. They're looking at uncertainty, regulatory exposure, technical challenges, cash flow, and only then do they select or, aggressively negotiate for the type of contract that shields them from all that.
And if we connect this to the bigger picture, risk is, without a doubt, the single most influential factor in any negotiation.
Right.
Just think about it from the buyer's perspective. You get a bunch of bids, and one comes in way, way lower than all the others.
That's instantly alarming. That low bid isn't a relief, it's a massive red flag.
Precisely. Because it suggests the contractor has either misunderstood the scope or just completely underestimated the complexity. So the client's response is almost a self-defense mechanism. They immediately impose these really stringent incentive and penalty clauses. We're talking heavy liquidated damages for missing milestones or specific targets they have to meet or risk losing all their profit.
So you're basically forcing the low bidder to accept the risk that their own price was too optimistic.
Exactly. So if you're that contractor, your main goal in the negotiation, it pivots. It's not just about arguing over the target cost anymore.
No.
You have to argue about the contract type itself. You have to push for a model that protects you from what our sources call onerous risks. These are the unfair, unquantifiable risks that you just can't afford to bear alone.
So shifting that risk burden through the actual structure of the agreement,
Yeah.
that's the real key. That's how you secure your profit long before you even start the work.
Yeah, that's the whole game.
All right, so let's ground ourselves in some of the fundamentals here. What exactly is procurement?
At its simplest, procurement is just the acquisition of goods or services. It sounds simple, but it's this really complex interaction between two parties, a buyer and a seller, who, fundamentally have different goals, and they're operating in a competitive market.
And getting the why of good procurement is so important because it directly drives the company's profitability, right?
Yeah.
It's so much more than just buying things.
Absolutely. The sources really stress this. Effective procurement hits the bottom line by securing major quantity discounts, which, lowers your per unit cost. It optimizes payment schedules to help with cash flows.
Which is huge.
And maybe most importantly, it's about strategically finding and locking in high-quality, reliable suppliers. That reduces your technical risk way down the road.
And because it's so tied to profit, procurement is usually centralized in a big company.
Right. Centralization just standardizes everything, gives you more purchasing power for those discounts, and cuts down on all the paperwork and bureaucracy. It's really an efficiency move.
But the sources make this crucial distinction that I think managers really need to remember. Centralization might be the corporate rule, but projects often need exceptions. The corporate procurement strategy and the project procurement strategy can be very different.
Think about that strategic difference. Corporate strategy might say, maintain a large supplier base, buy small quantities from lots of vendors to keep competition high.
Okay.
But what if you're managing some cutting-edge R&D project?
And your team suddenly discovers they need, 1 ounce of a super rare chemical that only one lab in the world makes.
Exactly. In that moment, your project strategy dictates immediate sole source procurement. You can't wait for a central vetting process or multiple bids. The project's urgency completely overrides the corporate desire for vendor diversity.
That makes sense. The constraint just dictates the strategy.
Right. And so when that project team starts its planning, they've got 4 basic strategic objectives to pick from.
Okay, what are they?
1, procure everything from a single source. 2, get everything from multiple competing sources. 3, procure just a small, specific piece of what you need and do the rest internally. Or 4, procure nothing. You decide to make it yourself. That's the classic make or buy decision.
And that whole selection process is constantly being pushed and pulled by the outside world, what we call the environment. And this breaks down into macro and micro factors.
The macro environment is all the big stuff. The enterprise environmental factors you just can't control.
Like what?
Huge systemic forces. We're talking about recessions, high inflation, the cost of borrowing money, whether it's a buyer's market or a seller's market, even the local unemployment rate.
And you can see how that connects directly to contracts. Like
Mm.
high inflation makes a fixed price contract incredibly risky for the contractor.
Of course, the cost of their materials and labor could just skyrocket, and poof, there go their profit.
But in a recession, that same contractor might aggressively chase a fixed price deal just to get cash flow in the door, even if the margins are thin.
Exactly. And these macro factors, they're not just abstract theories. They become real, explicit constraints on decisions. We've got this really surprising example from the source material.
Oh, yeah.
It's about a major foreign corporation doing a massive civil project in another country. And because the host country had a really high unemployment rate, the corporation adopted this policy that just overrode purely commercial logic.
How so?
They chose to use only domestic suppliers. And they gave preference to firms in cities with the highest unemployment.
Even if more qualified or cheaper contractors were available somewhere else?
Even then.
Wow. So they're using their procurement strategy as a tool for social and economic policy. But wait, doesn't that mean they're taking on more risk? If you're prioritizing social benefit over technical skill, you're inherently increasing the chance of performance problems.
That is the crucial tension, and yes, that's exactly the trade-off they're making. The corporation is consciously absorbing known technical or schedule risks.
In exchange for what? Political stability, local goodwill.
All of the above. And regulatory compliance. They're formalizing a higher level of acceptable project risk in their plan, all to satisfy a macro environmental factor.
That's fascinating. So that's the macro. What's the micro environment?
The micro is the internal world. It's all the processes, policies, and procedures inside the firm, the project, or the client's organization. This is where you find those 4 PMBOK processes for the buyer: plan, conduct, administer, and close procurements.
Okay, and this is where it gets really interesting, connecting strategy to the actual project timeline. The contracting process itself is often the formal way a project moves from one life cycle phase to the next, especially in big government programs like with the Department of Defense.
Exactly. Imagine you're developing a new deep-sea submersible. The first phase is all high-risk stuff: conceptual design, development, testing.
Mm-hmm.
Once that initial contract is done and you've proven the tech works, you have to start a whole new contract process just to move into the low-risk production phase. Those 4 PMBOK steps, plan, conduct, administer, close, they get repeated all over again for the new stage.
And that repetition is key because the type of contract changes as the risk changes. When a project is high risk in that early conceptual phase, the scope and cost are still really fuzzy.
And that high uncertainty means you have to use cost-type contracts. The customer is essentially insuring the contractor against cost overruns because the requirements are still changing.
But once you move into those lower risk phases, like production, the requirements are pretty much locked in.
Right. And at that point, the contract structure formally reflects that reduced uncertainty by shifting over to fixed-price contracts. The shift in the contract type is basically a signal that the project has reached technical maturity.
Okay, so that sets the stage really well. Let's dig into the 2 sides of managing that contract. We need to be clear about what contract management actually is.
It's the art and science of managing that agreement through its entire life. But as you mentioned, those 4 PMBOK processes, they really only focus on the buyer side of the table.
Right, but a contract needs at least 2 parties. So the seller, the contractor, they have to be doing a parallel set of activities.
Exactly. Both sides have to be actively managing the contract for it to work.
So let's walk through those 6 activities from the seller's perspective, because this is where all the business development strategy happens, way before procurement package even shows up.
First up is pre-sales activity. This is just continuous intelligence gathering. The seller is identifying potential customers, trying to understand their needs, forecasting future work.
And constantly checking out the competition. Who else might bid on this? What are their strengths?
Exactly. Then comes step 2, which is incredibly important for the seller: the bid-no-bid decision.
This is a huge risk assessment, right? Because bidding is expensive.
Incredibly expensive, especially for a big, complex RFP. You're committing serious internal resources, engineering hours, legal review, pricing strategy. It costs a lot of money to prepare a good bid.
So the seller has to be really methodical. They look at the buyer's requests, they weigh the competitive risk like, can we actually win this thing? And they consider the opportunity cost.
Right. What other projects could we be using these resources on? If the risk is higher than the potential reward, the smart move is to just say no bid and save your money.
Okay, so let's say they decide to go for it. What's next?
Step 3 is bid proposal preparation. This is where you actually create the offer that's designed to persuade the buyer. And for a major RFP, these proposals are massive documents. We're talking multiple, huge binders covering cost, technical approach, management team, past performance.
Then comes the moment of truth. Step 4, contract negotiation and formation.
This is where both sides get in a room and hash it all out. They're trying to reach a common understanding, agree on the terms, and most importantly, formally allocate all that risk we talked about.
And once the deal is signed, we move into step 5, contract administration.
Right, and this is the ongoing process of making sure performance actually meets what the contract requires. It's managing changes, handling invoices, tracking schedules, ensuring quality, and this part is identical for both the buyer and the seller. They're both just administering their side of the same rule book.
And finally, step 6 is contract closeout.
The final wrap-up. Settling the last accounts, making sure everything's been delivered and accepted, and resolving any last-minute issues or disputes.
The big insight here is that parallelism. While the PMBOK is all about the buyer's control, the seller is doing all the same things in reverse, using that same contract as their playbook.
It's a mirror image.
Okay, so the foundation of all of this has to be that first process. Plan procurements. This stage sets up the what, when, and how of everything you buy.
And the outputs here are not trivial. We're talking detailed plans, schedules, cost estimates that often cover the entire life cycle of the product, a formal risk register just for the vendors, and getting that official authorization to even start.
But the most critical output, especially for talking to outsiders, is defining the work itself. And here our listener really has to get the strategic difference between a statement of work, SOW, and a statement of objectives, SOO.
The SOW is the traditional way. It's a detailed narrative description of the work that needs to be done. It's very prescriptive. It tells the contractor how to do the job.
And the sources give some great history on why the SOW got so detailed. Apparently, back in the 70s and 80s, there was this problem where small companies would win these huge mega jobs.
And then immediately subcontract 99% of the work. The prime contractor didn't actually have the talent they claimed to have, which led to all sorts of performance problems and lawsuits.
So what was the fix?
The fix was to add stricter clauses to the SOW. Clauses that made the contractor identify the actual names and resumes of the specific talented people who would be working on the project.
And not just their names, but the percentage of their time they'd be dedicated to the project.
Exactly. It was designed specifically to stop companies from winning contracts with a ghost team.
Okay, so that's the prescriptive SOW. How is the statement of objectives, SOO, different?
The SOO is favored for performance-based projects, especially in the federal government, because it only describes the desired end result, the what. It leaves out the how.
And the strategic benefit there is innovation.
Right. The client's basically saying, we know you might have better technology or a smarter way to do this. So instead of dictating the method, the client just states the objective.
And then the potential contractors come back and propose their own detailed SOW, their unique how.
Exactly. So when the client is selecting a source, they're not just comparing prices. They're doing this complex trade-off analysis between different levels of proposed performance and the price for that performance. It's not about finding the cheapest follower of instructions. It's about finding the best value, the most innovative solution.
And the type of technical specification you use in these documents, that immediately decides who holds the risk if something goes wrong.
This is a fundamental legal point. If the buyer uses design specifications, meaning they detail the exact materials, dimensions, methods, and the contractor follows them perfectly, but the thing still doesn't work.
The risk is on the buyer. The buyer designed it, they own the failure.
But if the buyer uses performance specifications, where they just specify a measurable outcome like the motor must run for 5,000 hours straight. They don't care how it's designed.
Then the risk of hitting that target is 100% on the contractor.
Precisely. And a subset of that is functional specifications, which just describe the end use, like must be able to clean up oil spills. Again, the risk stays firmly with the contractor.
This all leads directly to that foundational question in any project plan. The make or buy decision. Do we build this thing ourselves or do we go out and buy it?
Right. And there are good arguments for both. The advantages for the make decision are all about control and efficiency. It might be cheaper, it's easier to integrate, you can use idle factory space.
And you keep your trade secrets secret, you also keep your workforce stable.
But the arguments for the buy decision are often really compelling. It might be cheaper if a supplier has huge economies of scale. You can tap into specialized skills you don't have.
It makes sense for small quantities. And strategically, it lets you maintain multiple qualified suppliers, which gives you leverage over price and supply.
We should also touch on the financial alternative here,
Yeah.
which is lease versus rent. This is a pure numbers calculation that project managers face all the time.
The sources have a great simple example for this.
Yeah. So say you need a piece of equipment. You can rent it for $100 a day, or you can lease it for a one-time fee of $5,000 plus $60 a day.
So the question is, where's the break-even point?
You just set the costs equal to each other. 100 times X for the rent equals 5,000 plus 60 times X for the lease.
You solve for X and you get 125 days.
And that's your decision point. If you need the equipment for 126 days or more, you have to sign the lease to save money. Any less, and you rent. It's just clear numerical clarity.
And all this planning has to end with detailed risk identification. The sheer number of risks tied to external procurement, like the ones detailed in the ABB Project Management Manual, is just staggering. It's way more than just technical risk.
Oh, that list is sobering.
Yeah.
You've got contract risks, like vague wording or exposure to penalties.
Yeah.
But you've also got the big legal risks like force majeure, acts of God, war, terrorism, and then the financial risks.
Financial risks are huge, especially with global projects. You're managing letters of credit, dealing with currency exchange risk,
Which can wipe you out.
inflation, payment bonds. Then you have political risks. Is the government stable? Are they going to change the laws on you?
Right. And then schedule risks, technical risks. The point is, this planning phase has to cover every single angle of liability before you even think about sending out an RFP.
Okay, so once the plan is locked in, we move to conduct procurements, starting with the solicitation package. This has all the bid documents, the list of qualified vendors, the evaluation criteria.
And the absolute cornerstone here, especially in government work, is maintaining a level playing field. That means the exact same, identical package has to go to every single possible supplier, no exceptions.
And that has real consequences. The sources note that vendors are smart. Sometimes a vendor will get the package, look at the qualified vendor list, and just decide not to bid.
Because they know they can't beat a competitor's price. And since bidding is a huge sunk cost, they rationally decide to just save their resources for a fight they can actually win.
Which is why bidder conferences are so important. They're held to make sure no single bidder has information that others don't.
Exactly. If one bidder asks a question, the client has to share the question and the answer with everybody, usually as a formal amendment to the solicitation.
Now, when it comes to getting responses from sellers, there are 3 common methods.
First is advertising for sealed bids. There's basically no negotiation here. The market sets the price, and the award goes to the lowest bidder who meets the technical bar. It's for when the requirements are crystal clear.
Second, and much more complex, is negotiation. This is where the price and terms are hammered out through bargaining. It requires things like an RFI, RFQ, or the big one, the request for proposal, RFP.
And responding to an RFP is the most costly thing a seller can do. It can run into hundreds of thousands, even millions of dollars. You really have to believe you can win to justify that kind of spending.
And the third method is just small purchases for everyday things like office supplies. Now, a big misconception is that the contract always goes to the lowest bidder. That's really only true for those sealed advertised bids. For complex stuff, there are 2 main strategies.
The first is the price-based award. It's simple. The contract goes to the lowest price proposal that is technically acceptable. Meet the minimum standard, cheapest one wins.
But the second one, the best value award, is way more interesting strategically. It allows for trade-offs between price, performance, and other non-price factors.
Which means the contract can be awarded to a higher price proposal if that proposal offers a much higher level of performance or better terms like a longer warranty.
And the ability to make that trade-off is all defined by the proposal evaluation criteria and the weighting system.
Right. So you have your criteria: time, cost, technical approach, past performance. And you might start with 100 points for each.
But let's say your company has been burned by late deliveries in the past. You might assign a weighting factor that makes previous performance worth 200 points.
And that's a game changer, because that low price supplier might look great on cost and time. But if their history is bad, that doubled weight on past performance can totally sink their score. They could lose the contract even with the lowest price. The selection is explicitly based on perceived future risk.
And for these big negotiated deals, the negotiation is about so much more than just the bottom line price.
Oh yeah, you can separately negotiate profit margins, the contract type, payment schedules, who owns the intellectual property.
IP is a huge one. If I'm the contractor and I get to keep the IP, I've got future revenue streams. If the client gets it, they're not locked into me for future work. That's a massive negotiation point.
It all comes down to the human factor. The sources say successful negotiation boils down to three things: compromisability, adaptability, and good faith.
And it requires just relentless planning. You need to define your minimum and maximum positions on every single point, evaluate your opponent's motivations, gather your facts, do your cost analysis.
And here's the aha moment from the sources: the impact of hygiene factors.
What are those?
The subtle environmental details that can influence the outcome. Where do you negotiate? A neutral hotel or their intimidating headquarters? What kind of table do you use? A round one for cooperation or a square one for hierarchy?
Even who faces the window.
Even who faces the window. It's about psychology and subtle control as much as it is about numbers and law.
All right, let's dive into the contracts themselves. Before we get to the types, we need a quick legal foundation with some key terms.
Absolutely. First, an agent is the person with signature authority to legally bind the company. The force majeure clause excuses you from liability for things you can't control: acts of God, war, pandemics.
Liquidated damages. This is a big one. It's a pre-agreed penalty for a specific breach, like a scheduled delay. You set the price for failure up front to avoid a lawsuit later.
Primitive contract is just the legal relationship between the buyer and seller. Termination liability is the compensation the seller gets if the project is canceled early. And the Truth in Negotiations clause requires both sides to be honest with their cost data.
Got it. And for a contract to be legal, it needs 5 things: mutual agreement, consideration like a down payment, capability, a legal purpose, and the proper legal form.
Right. And we also classify contracts by how they're delivered. A completion contract means you deliver a specific end product. It's done when it's formally accepted.
And a term contract.
That's where you deliver a specific level of effort, so many man-months of work. The contract is done when the time is up, regardless of what you actually accomplished. That's common in R&D.
Okay, now for the key terminology in these complex incentive contracts.
Target cost is your best guess of the cost. Target profit is the profit you negotiate on top of that.
The price ceiling is the absolute maximum the customer will ever pay. And the sharing arrangement is the formula that decides how you split any cost savings or overruns.
And the most critical one, the point of total assumption, PTA. This is the exact cost point where the contractor starts eating 100% of any additional costs. It's where profit disappears and corporate losses begin.
Okay, with that, let's hit the 5 major contract types on a spectrum of risk.
At one end, you have the fixed price, FP contract. The contractor takes on all the risk 100%. If they underestimate the cost, their profit is gone.
For the owner, this gives them maximum cost protection. But the downside is it's totally inflexible. Any change is a costly, time-consuming nightmare.
Next, the cost plus fixed fee, CPFF contract. Here, the customer assumes most of the risk. The contractor just agrees to give their best efforts. The fee or profit is fixed no matter what the final cost is.
The flaw here is the lack of incentive, right? Good performance and bad performance get the same reward.
Exactly. Then there's the cost plus percentage fee, CPPF. This gives the owner maximum flexibility but zero cost assurance. It's actually prohibited in government contracting.
Because it creates a perverse incentive. The contractor's fee is a percentage of the cost, so they make more money if the project costs more.
Right. The only incentive to keep costs down is the hope of future work.
4th is the Guaranteed Maximum Shared Savings, GMSS contract. This is a true shared risk model.
The contractor gets reimbursed for costs up to a guaranteed maximum ceiling. Any savings below that ceiling are shared, but any overrun beyond that ceiling is the contractor's problem alone. It aligns everyone's incentives.
And finally, we get to the really sophisticated ones, incentive contracts, the FPIF and the CPIF.
These are engineered to use financial rewards and penalties to drive contractor behavior.
Let's do a deep dive on the fixed price incentive fee, FPIF. This one needs really clear requirements up front.
Let's use the sources example. Target cost is $10,000. Target profit is $850. And the price ceiling is firmly set at $11,500. The sharing ratio is 70-30. Meaning the buyer takes 70% of any variance, the contractor takes 30%.
Okay, scenario 1, the underrun. The contractor is super efficient and gets the job done for $9,000. That's a $1,000 saving.
Right, so the contractor gets to keep 30% of that saving, which is $300. Their final profit is their original $850 plus the $300 for a total of $1150.
And the final price the customer pays is the $9,000 cost plus the $1150 profit, so $10,150. Everyone wins.
Everyone wins. Now, scenario 2. The overrun and the PTA. What if costs go up? The contractor has to pay 30% of that overrun out of their profit. But there's a limit, and that's the point of total assumption.
The PTA is the cost point where the final price hits that $11,500 ceiling. In this example, the math works out to a cost of $10,928.
And that is the moment of truth. If the cost hits that number, the customer's bill stops at $11,500. If the cost keeps climbing, say to $13,000.
The customer still only pays $11,500. The contractor has to eat that extra cost 100%. In that case, they'd lose $1,500 on the job. It's a powerful incentive to control costs.
It's terrifyingly powerful. Now let's look at the cost plus incentive fee, CPIF. This is for long R&D projects where cost is uncertain, but you still want control.
Here, the customer reimburses all the costs, but the fee is what's incentivized.
Right. Using the example, target cost $10,000, target fee $750. But you set a maximum fee of $1,350 and a minimum fee of $300. The sharing ratio is 85-15 and heavily in the buyer's favor because they're covering all the costs.
Scenario 1, the CPIF underrun. The contractor does an amazing job, comes in at $6,000. That's a $4,000 saving.
The contractor gets 15% of that, which is $600. So their new fee is the original $750 plus the $600, which is $1,350.
And since that's the maximum fee, it's capped right there. The final price is $6,000 cost plus $1,350 fee for $7,350.
Perfect. Now, scenario 2, the CPIF overrun. The cost balloons to $13,000, a $3,000 overrun.
The contractor loses 15% of that overrun, which is $450. So their fee is $750 minus $450, which is $300.
And since that's the minimum fee, it stops right there. The final price is $13,000 costs plus $300 fee. This structure creates clear boundaries of risk and reward for both sides.
And just to round this out, we should differentiate these from award fees, which are subjective. They're for things you can't really measure, like team synergy.
Right. An evaluation board just decides how much extra to give you. And then there's the award term, where instead of money, a successful contractor earns more time on the contract, avoiding the whole expensive process of having to recompete for it. A massive incentive.
Okay, so moving into execution. The key person here is the contract administrator, or CA. This sounds like a tough job.
It's incredibly intense. They have to make sure the seller complies with every single term of the contract. They have the authority to halt payments, issue warnings, even shut down the work.
And their reporting structure is interesting. They're on the project team, but they often report directly to corporate legal. They might even be a lawyer themselves.
That legal reporting line just shows how serious their role is in managing liability. Their job is exhaustive. Change management, quality inspections, audits, warranties, and critically, issuing the contractor performance report card.
That report card is so important because it feeds directly into the source selection for the next project. A bad report from the CA can sink a vendor's chances next time, no matter how low their price is.
Exactly. And the CA spends most of their time dealing with changes. There are a few types we need to know.
No.
An administrative change is simple, like changing a mailing address. It doesn't affect the substance of the deal. A change order is a formal, written order directing a change to scope, cost, or schedule.
But the most contentious one is the constructive change.
Right. This isn't a formal order. It's a change caused by the actions or inactions of someone in authority. For example, a site inspector keeps demanding a higher quality finish than what's written in the spec.
The contractor has to comply to keep the work going.
But that inspector's demand is a constructive change. It allows the contractor to file a claim for more money to cover that extra unscoped work. It's a huge legal and financial risk for the buyer.
And the CA also manages contract termination. There are two main ways a contract can end early.
First is termination for convenience. This is the customer's choice. Maybe the budget got cut or the technology is now obsolete. The customer has to pay for all the work done and materials bought, but not for any anticipated profit.
And the second is termination for default.
This is when the contractor fails to perform. They miss deadlines, they're not making progress, they violate a key clause. In this case, they can lose payment for work in progress and even be on the hook for the extra cost of hiring a replacement.
Okay, shifting gears to the internal organization. How do big companies structure themselves for all this? We're seeing a move toward strategic business units, or SBUs.
Right. These are groups responsible for the profit and loss of a specific business segment. It's a way to be more customer-focused. If you're a big auto supplier, you might have separate SBUs for Ford, for Chrysler, and for GM.
But it gets more complex with platform management.
This creates a multidimensional matrix. You have platform managers who design the core, standardized components, like an engine. Then the SBU program manager has to adapt that standard engine for a specific car model that Ford wants.
So you get this built-in conflict. The SBU manager controls the customer's budget and schedule, but the platform manager controls the core technical design. That's a classic matrix management challenge.
And no matter how complex the matrix is, that partnership between the project manager and the line manager is still key. It has to be a peer-to-peer relationship with shared authority and accountability.
Which brings us to a huge point for our listener: the project manager as communicator. The sources are really clear on this. A PM can spend 90% or more of their time just communicating.
It's everything. Giving direction, negotiating, reporting, meetings, marketing, PR. Their ability to manage communication is often the single biggest factor in a project's success or failure.
The sources outline 6 simple steps for effective communication. Think through your objective, pick the right method, appeal to the other person's interest.
Give and get feedback, and then test to see if it actually worked.
And there are specific techniques to get better. Use multiple channels, not just email. Use face-to-face for the important stuff. Use simple language. And use redundancy. Say it 2 different ways to make sure it sticks.
But even with all that, the barriers are real. The sources list a bunch of common pitfalls. One is the receiver just hearing what they want to hear and filtering out the rest.
And this one is directly related to our contract discussion. The sender and receiver having different perceptions of the requirements. The buyer wrote the SOW thinking X, but the contractor read it and thought Y.
And that single difference in perception is the source of most claims and disputes.
Then you have other barriers, like people ignoring information that conflicts with their beliefs, words meaning different things to different people, ignoring body language.
A big part of communication is just listening. Good managers listen without interrupting. They try to see the problem from the other person's perspective. And before they offer a solution, they ask the subordinate for their solution first.
It's about empowering the team.
Exactly. And a PM can adopt all sorts of communication styles, from authoritarian to facilitating, and some really bad ones like secretive or disruptive. And that style dictates the whole team's morale and efficiency.
Okay, let's bring this all together. We started by saying that every big project is really a negotiation over risk. We went through how contracts, from cost type to FPIF, are the formal documents that decide who carries that risk, with these critical ideas like the point of total assumption. And then we connected that external legal complexity to the internal structures you need to manage it, the CA, the SBU matrix, and that fundamental challenge of just communicating what needs to be done.
What's really fascinating to me is how the choice of contract type isn't just some administrative detail. It's a living financial and strategic model.
Yeah.
Whether you're the buyer or the seller, if you don't understand those leverage points, like the sharing ratio and that, yes, terrifying point of total assumption, that's the difference between profit and catastrophic loss. The financial fate of the project is sealed the moment that contract is signed.
Indeed. It forces precision everywhere in planning, financial control, and legal drafting.
So this raises a really important question for you to think about. Given that communication takes up 90% of a project manager's time, and we know that barriers like filtering and different perceptions are constantly distorting the message, how much does the success of a legally perfect airtight contract really depend on the informal, subjective communication and listening skills of the PM, rather than just the strict legal clauses themselves?
Something for you to chew on as you dive into your next project.
Welcome back to the Deep Dive. Today, we are tearing apart the very architecture of what makes a project succeed or fail.
And our mission is really to get past the surface level stuff, the charts and the deadlines.
Right. We're digging into the absolute foundations. We're going from the soft skills, which are so critical, to the hard, ironclad tools that structure the work.
And we're starting with a realization that I think is pretty stark for a lot of people. The biggest project killers, they're almost never technical failures.
No, not at all. They're failures of connection, of clarity.
Exactly. We're basically decoding the DNA of project success by looking at how information flows and maybe more importantly, where it gets distorted, where it gets filtered, or just, outright stopped.
This whole deep dive is about giving you those aha moments, the kind of insights that separate a manager who's just read the book from one who is truly effective.
And we're pulling this directly from some really heavy-duty project management sources. They cover everything from effective communication, managing organizational friction, and setting objectives that actually work. And then we'll get into mastering those two documents that everyone talks about: the statement of work, the SOW, and of course the legendary framework of the work breakdown structure, the WBS. So if you've ever seen a massive project just collapse because of one ambiguous word or one missed conversation, well, you're about to get the tools for absolute precision.
All right, let's jump right in with a statistic that should, frankly, redefine how you view project leadership.
The 90% rule.
The 90% rule.
Yeah.
Our source material insists that a project manager can spend 90%, sometimes even more, of their entire working day just communicating.
When you really let that sink in, it just fundamentally changes the job description, doesn't it?
It does. You're not a controller of tasks anymore.
No, you're a master of information, and it's not an optional part of the job. It is the job.
So because of that, that overwhelming amount of time spent on it, communication management becomes the core responsibility.
And it's directly, verifiably correlated with project performance. I mean, the link is undeniable. A PM's success is totally inseparable from their effectiveness as a communicator.
So if you fail to manage the message,
You fail to manage the project. Simple as that.
so if 9 out of every 10 hours are spent on this, where exactly is that time going? It's not just sending emails, right?
Not even close. The sources break it down into about 6 broad areas where this time gets eaten up.
Okay, let's walk through them.
First, and most obviously, they're constantly providing project direction. This is the core leadership part.
Decision-making, authorizing work, negotiating.
Right, resolving conflicts, and this is a big one, reporting progress and problems up the chain of command.
Okay, so that's number 1. What are 2 and 3? Those are the ones everyone expects. Attending meetings and just overall management. But it's 4, 5, and 6 that I think surprise people. Which are?
Project managers are constantly involved in marketing or selling the project.
Internally, you mean, to get buy-in.
Internally for buy-in and externally to keep stakeholders or the customer happy. They're also deep into public relations. They are the project's #1 ambassador.
Yeah, the last one.
A huge amount of time is spent on records management. Think about all the memos, specifications, contracts, meeting minutes.
Generating them, storing them, reviewing them, sending them out.
It's a relentless administrative burden, and it's all tied directly back to communication.
So with that sheer volume, we have to nail down what we even mean by effective communication. It's more than just talking.
Much more. It's about the successful transfer of meaning. The documentation gives a few definitions, but they all circle the same idea.
It's an exchange of information transmitting a message.
Right. But the most complete definition, the one we should really hammer onto, is that it's the process by which meanings are exchanged between individuals through a common system of symbols.
A common system of symbols, and when it fails.
It's usually because that common system broke down or the meaning got twisted on the way.
And that twisting, that distortion, is almost mathematically guaranteed to happen more often as your team gets bigger. Which brings us to a really critical idea for anyone building a team: modeling complexity. You have to use the channels formula. This is where so many managers get it wrong, isn't it? They think of communication as just a series of straight lines.
Exactly. They see it as a hub and spoke. But it's not. It's a full mesh network of two-way channels. And the complexity scales exponentially, not linearly.
So the formula for calculating these two-way channels, N, is N equals X times X minus 1, all divided by 2, where X is the number of people.
Let's make that real. A small team of 4 people, so X equals 4. That gives you 6 two-way channels.
Okay, 6. That's manageable. But you can already see how misunderstandings could start to creep in.
Right, but now let's say your team grows to just 8 people. You've only doubled the head count.
But you're not doubling the channels. Using the formula, you suddenly have 28 unique two-way channels.
28. It's not 8 people sharing updates anymore. It's 28 potential separate conversation threads that can get tangled.
And if you're running a big program, maybe a 20-person core team.
You are dealing with 190 unique communication channels.
Yeah.
190. And if you haven't formalized your process, if you're just relying on informal chats, the chaos will scale so much faster than your headcount. You just can't manage that informally.
And even if you had perfect channels, the message itself is still vulnerable It can get corrupted.
Right, because of what the documentation calls the screens or the barriers. These are like 4 psychological filters that are always distorting the message.
These screens are perception, personality, attitudes, emotions, and prejudices.
Yeah.
This is the human element, right? This is what introduces noise into the signal.
Let's break them down. The first screen is perception barriers. This happens because 2 people see the exact same message through totally different lenses.
So an executive with a finance background and a software engineer.
They both hear the instruction, optimize efficiency, and they will take 2 wildly different actions based on their education, their experience, their professional bias.
So how do you fight that?
The strategy is simple, but it's often ignored. You have to use words with precise, quantifiable meaning. Don't say make it fast.
Say it needs a 20-millisecond response time.
Exactly. Be precise.
Okay, so what's the next screen?
Next is personality and interests. This is where the receiver is just naturally selective. If the topic in a meeting or a memo is boring to them or it's unfamiliar,
They just tune out.
they tune out, they focus on what they care about, and they filter out the rest, which makes the PM's job of appealing to people's interests so incredibly important, which we'll get to.
And the third one sounds like the most destructive.
It is. It's the one formed by attitudes, emotions, and prejudices. If someone is feeling fear or anxiety or really strong emotions, like they love or hate a project,
They go into self-protection mode.
right. And that mechanism distorts the message. The sources say that strong emotions can literally rob people of their ability to comprehend information objectively. They stop evaluating the data and start evaluating the source or the threat.
And these internal battles are being influenced by everything happening around the project.
The whole organizational environment. You have internal and external factors constantly shaping things.
Internally, you're dealing with all the classic office friction. Things that either help you or stop you. The sources flag all the destructive stuff.
Wow.
Power games, where people communicate to get leverage instead of to share information, intentionally withholding information.
Oh, yeah. The limits of management by memo, which just strips out all the context, mixed messages coming from different leaders.
And of course, just basic human flaws like stereotyping or selective perception. This is the office politics that just kills trust and clarity.
And then you have all the external factors you can't control. The project exists in the real world.
The business climate, the political situation, the economy.
Exactly. Demands from regulatory agencies can completely move the goalposts on you. And of course, the ever-changing technical state of the art.
If a competitor launches some revolutionary new product, that external event immediately changes all your internal communication and your sense of urgency. And all of this friction, internal and external, it leads to the twin destroyers of clarity: noise and ambiguity. Noise is pretty straightforward. It's anything that distorts or just destroys the message.
Right, and it often comes from those personality and perception screens we just talked about. But ambiguity is arguably much more dangerous.
Why is that? Why is it more treacherous?
Because with ambiguity, people fill in the blanks themselves, and they usually do it to the detriment of the project.
They hear what they want to hear?
They hear what they want to hear or what they think the group wants to hear, or they just connect it to some past experience, even if that experience is totally irrelevant.
So the manager has to assume that if there's any gray area,
The receiver will naturally default to the interpretation that is most convenient or comfortable for them, not what's best for the project.
that is a heavy, heavy weight for a project manager to carry. I mean, if your main job is communication and 90% of your day is battling all this complexity in these emotional screens and power games, you need a real strategy to fight back.
You do. You need an actionable plan.
So let's pivot from defining the problem to finding the solution. How do you make sure that 90% of your time is spent creating clarity, not more chaos?
Well, our sources lay out a really pragmatic 6-step strategy. It's about generating messages that are not only clear, but also, and this is key, motivated.
It all starts with intentionality, right? Completely. Step 1 is think through the desired accomplishment before you say or write anything. What precisely do you want the other person to do or to change because of this communication? Step 2, determine the best way to communicate. Is this a formal email? Does it need to be face-to-face? Can it be a quick message? The medium has to fit the message. Then step 3, and this one directly counters those filters we talked about. Appeal to the interest of those affected. You have to frame the message so the person understands why they should care and how it affects them. And the last 3 steps are all about closing that feedback loop. It's about recognizing that this isn't a one-way broadcast. Exactly. Step 4 is give feedback on others' communication. Be an active, constructive listener and help clarify when others are being unclear.
Get feedback on what you communicate, and don't just ask, did that make sense?
No, that's a useless question. Ask probing questions.
Yeah.
Ask, okay, based on that, what are the first 3 things you're going to do?
Hmm.
And finally, step 6, test effectiveness by relying on others to carry out instructions. The real measure of your success isn't how clear your memo was, it's whether the work got done correctly. And to minimize those persistent barriers, the perception, noise, and emotion, the sources really stressed a few tactical techniques. And the big one is redundancy.
Redundancy is key.
It is. Don't just say it once. Say it 2 different ways. Use slightly different phrasing. It massively increases the chance of the message actually getting through those screens.
You also need to establish multiple communication channels. If you only use email, you miss all the nonverbal cues.
But if you only use meetings, you don't have a formal record. So you need both. And of course, use simple, direct language and, critically, reinforce your words with your actions.
Oh, that's a big one. If you say the budget is tight, but then you go and authorize a bunch of unnecessary spending.
Your actions have just screamed louder than your words ever could. You've lost all credibility.
And that's why, even in this digital age, face-to-face communication is still the gold standard when the message is critical or sensitive.
Absolutely. That immediate feedback loop, the ability to read body language, the power to stop and correct a misunderstanding on the spot. You just can't fully replicate that with a memo or even a video call.
Okay, so let's talk about the choke points. The places in the organization that actively fight against this ideal flow of communication. We're talking about bottlenecks and filtering.
And they almost always seem to center on the project office, don't they?
It seems that way.
The most common one is what the sources call the project office filter. This happens when the project office, usually in the name of control, says that all communication between the customer and the parent organization has to flow through them.
The intention is good, right? Control, consistency.
The intent is control, but the result is a massive slowdown in reaction time.
And from the customer's perspective, they start to worry that the information is being, massaged? Watered down?
Exactly. They start to fear that the info is being filtered to protect the project manager or the company. And once that trust starts to erode, it becomes a huge project risk.
And this friction leads directly to another problem.
The specialist direct comms dilemma. The customer will inevitably try to get around that project office filter.
They want their technical experts talking directly to your technical experts.
Of course they do. They want the raw, first-hand information, and they want it now.
But project managers, as you can imagine, hate this.
Hate it. They're terrified that the specialist, who is focused purely on the technical side, is going to say something or make a decision that goes against the overall project strategy or the schedule or, and this is the big one, the contract.
So it's a battle between technical efficiency and project control.
It is. And the source material offers a really difficult compromise. It says you can permit that direct technical communication, but only if the customer formally agrees that anything said by those specialists does not reflect the official position of the project office or the company.
Wait, so the PM is basically saying, you can talk to our engineer, but you have to sign a waiver saying their words don't officially count.
That's pretty much it.
Doesn't that just make the whole conversation feel less trustworthy, almost pointless?
It's a huge risk calculation. The compromise is trying to get the necessary technical speed while minimizing unauthorized scope creep or contractual blunders. The PM has to weigh the damage of a slow reaction time against the risk of an off-the-cuff comment costing millions in rework.
So in a high-stakes project, that formal disclaimer might be the only way to manage that liability.
It often is.
There's a third bottleneck, and this one is purely organizational. It's the status-seeking manager.
Oh, yes. This is the PM who tries to gain status by communicating only with higher-ups. They bypass all their peers entirely.
You only talk vertically.
Which creates these super rigid channels. It's an issue with the scale or chain of command, and it almost always results in 2 conflicting communication paths.
You have the formal, rigid, vertical path that the PM insists on.
And then you have the inevitable, fast, informal horizontal path that the team members create just to get their actual work done.
And the conflict between those 2 channels, with information flowing to and from the customer on both, must create incredible confusion.
It's immensely damaging. It slows down every decision and it just crushes morale.
All of this reminds us that half of communication isn't talking at all. It's listening. If a PM spends 90% of their time communicating, a huge chunk of that needs to be active listening.
The sources really emphasize the benefits here. When you listen properly, your subordinates know you're genuinely interested. That's a huge morale boost.
You also get critical, unfiltered feedback, which is exactly what you need to fight that filtering effect we just talked about.
And it fosters employee acceptance of tough decisions because they at least feel like they've been heard.
And active listening is more than just being quiet while the other person talks.
Right. It involves reading body language.
Hmm.
Sometimes the body language gives you a much more accurate read on the real intent behind the words, the intent that the words might be trying to mask.
So what does a good manager do, practically?
A few key things. Listen to the whole story without interrupting. Try to genuinely see the problem from the other person's perspective. Empathize. Don't just immediately start judging.
And this next one is critical.
It is, before you offer a solution or make a decision, ask the subordinate for their solution to the problem.
Because that fosters shared ownership. They're invested in the outcome.
Precisely.
But active listening has its own set of barriers, too. And the blame for failure can lie with both the speaker and the listener.
Let's talk about speaker-created barriers first. These are behaviors that just overwhelm the person trying to listen, forcing them to take excessive notes, for example.
They can't digest the material or read your body language if they're scribbling the whole time.
Right. Constantly interrupting, talking way too fast without pausing, or never stopping to paraphrase or ask for feedback. Those are all faults of the person sending the message.
And then you have the listener-created barriers, the psychological traps we all fall into.
Letting your mind wander. Multitasking, we all see it. People reading their email during a presentation. Even just looking off into the distance signals that you're not engaged.
And a big one is letting your emotions, impatience, anxiety, your prejudice about the topic cloud you're thinking.
Absolutely. If you're already mentally rehearsing what you're going to say next, you are, by definition, not receiving the full message that's being sent to you right now.
So the takeaway is that communication is this dynamic system. And when it breaks, the PM has to audit both the sending process and the receiving process to figure out where the distortion happened.
Two-sided equation, always.
So if 90% of a PM's job is communication, and good communication relies on face-to-face interaction and feedback, well, meetings are just inevitable, aren't they?
They are. They are the essential tool for coordination. But we've all lived through the nightmare of endless, pointless meetings.
So they need structure. They need discipline, especially for the 3 distinct types of project review meetings our sources lay out.
Okay, first up, you have the project team review meetings. These are your internal, tactical huddles. They can be weekly, bi-monthly, whatever works.
And they are the most flexible.
Right. And here's the critical rule. They should only be called if they will actually benefit the team. Never, ever hold a meeting just for the sake of formality. Okay. Second type, executive management review meetings. Senior management often mandates these, maybe monthly. But a smart PM doesn't just accept the date they're given.
What do?
They proactively request dates that line up with a major milestone or a point where they can clearly show and celebrate progress. It makes the meeting productive, and it makes the PM look good.
Smart. And the third type, which sounds like the most stressful.
The customer project review meetings. These are the highest stakes, and usually the schedule is completely inflexible. They demand a ton of prep.
You're not just showing up with a few slides.
No, we're talking detailed handouts, formal reports, all the literature prepared well in advance, because the customer needs absolute clarity and documentation for their own internal reviews.
So to turn these necessary evils into something productive, the sources give 15 really clear guides for effective meetings.
And these aren't suggestions, they're behavioral disciplines. The foundation is pure discipline. Start on time and end on time. If you wait for latecomers, you are actively rewarding bad behavior. You're telling everyone that their collective time isn't valuable.
Then comes clarity. You have to develop agenda objectives and then stick to them. Conduct one piece of business at a time.
Trying to solve 3 problems at once guarantees you solve none of them properly. And here's a huge psychological insight from the material.
What's that?
Seek opinions when silence doesn't mean agreement. In so many company cultures, silence just means conflict avoidance. It doesn't mean consensus.
So the facilitator has to actively draw out disagreements.
Yes, they had to see different views as productive, not as a disruption.
And what about that one person in every meeting? You know, the one who dominates the whole conversation.
You have to be ready to confront the verbal member gently. The sources give a perfect phrase for this.
Let's hear it.
You say, okay, we've heard from Mike on this. Thank you for that insight. Now, how about some other views?
So you acknowledge their input, but you immediately and politely pivot.
Exactly. It ensures everyone gets a chance to contribute.
This all leads back to accountability, doesn't it? You have to test for readiness before you make a decision, and then test for commitment after the decision is made.
And you have to do that before you start assigning roles or due dates. If you don't have commitment, assigning tasks is just setting people up to fail.
You also have to clearly agree on follow-up dates and explicitly state the next steps before anyone leaves the room.
And then the ultimate test of a manager's humility. After it's all over, you have to ask yourself if the meeting was even necessary.
And if the answer is no,
You've not only wasted everyone's time, you've eroded their willingness to show up prepared for the next one.
the launch point for any major project is usually the kickoff meeting. This brings all the key players together.
The PM, system PMs, the subject matter experts, functional leads, everyone. And the sources are very specific about what needs to be covered right away.
Beyond the usual scope discussion and org chart, there are some really critical administrative items. One that was surprising to me was the explicit discussion of wage and salary administration.
Yes, specifically telling employees that their functional bosses will be informed about how they perform on the project.
Why is that so important to bring up at a kickoff meeting? It feels a bit administrative.
Because in a matrix organization, people serve two masters. They report to their functional boss, but they work for the project manager. Their allegiance can be split.
So by stating upfront that their project performance affects their formal review?
You immediately align their personal accountability with the project's success. You overcome that organizational barrier from day one. They're motivated to perform because their career back in their home department depends on it.
Okay, that makes sense. Now let's look at the launch process for really big projects, where just creating the cost estimate is a massive project in itself.
Right, for long projects, the estimating cycle can take weeks or even months. It needs its own structured schedule of meetings. There are 4 of them.
It starts way before the estimate is even due.
Weeks or months before. It kicks off with the pre-kickoff meeting. This is just for the people who will be providing cost inputs. The estimate manager lays out the ground rules, the constraints, and hands out all the specs, drawings, and standardized forms.
So everyone starts from the exact same page.
The exact same data set. Then, a few days later, you hold the review of ground rules meeting. This is for clarity. People have a chance to look at the documents, and now the estimate manager can answer questions and clear up any ambiguities before anyone starts putting numbers to paper.
Then weeks later comes the big one, the most critical meeting of the cycle, the resources input and review meeting. This is where the integration happens. Each team member presents their resource inputs, their man-hours, materials, etc., in front of their peers. And that peer review forces them to justify their numbers.
And it lets the whole team spot overlaps and duplications right there on the spot. If the software team and the systems integration team both priced at the same block of work, this is where you catch it before it becomes a multi-million-dollar mistake.
And the final step before the big presentation.
The summary meeting. This is the internal dry run. The whole consolidated estimate is presented back to the core team. It's the last chance to catch any final inconsistencies before you take it to senior management or the customer. That discipline is your best defense against a bad estimate.
All right, we spent a lot of time on the critical soft skill, communication, that makes a project run. Now let's switch gears to the hard tools that define what we're even communicating about. Starting with the very first step in any successful plan, establishing project objectives. The objectives are the project's North Star, right?
They have to be. They could be strategic, like developing a new market expertise, or purely tactical, like modifying a facility or just keeping key people busy during a slow quarter.
And the challenge isn't just writing them down, it's prioritizing them.
Exactly. Objectives often conflict with each other. Management has to decide which ones are truly strategic, the must-haves, and which are just nice-to-haves. If you don't prioritize, you'll waste a ton of resources chasing impossible goals.
And this is where a lot of projects fail before they even start, with poor objective definition. The sources list the usual suspects. Objectives that not all the key players agree on, objectives that are too rigid, or the worst one of all, the ones that are insufficiently quantified.
If you can't measure it, you can't manage it. And if your objectives aren't documented well, high personnel turnover can kill you because the institutional memory of what you were trying to do just walks out the door.
For planning to work, the roles have to be crystal clear. You need consensus between 3 key layers of the organization.
First, you have the project manager's role. They set the high-level boundaries, the overall goals, the major milestones, the constraints, time, cost, performance, and all the procedures and reporting rules. They build a framework.
Then second, you have the line manager's role. This is where the detail comes from.
They define the detailed tasks needed to hit the objectives, the specific schedules, the manpower estimates, and they are responsible for flagging risks and uncertainties at that ground level.
And third, the senior management or sponsor role.
They're the strategic enabler. They're the negotiator for when the project and line managers disagree. They clarify political issues, and they provide that crucial communication link to the customer's senior management. If any of those three roles fails, the plan is built on sand. So once the goals are set, we move to the foundational document that describes the work, the statement of work, or SOW. This is the narrative description of the end results. It's what you're building. It becomes the basis for the whole contract negotiation and the pricing.
And you see two types, right? Internal and external.
Right. Internal SOWs are for internal projects. But for external SOWs, especially in competitive bidding, the contractor often has to rewrite the customer's SOW.
Why would they rewrite it?
For clarity, so that their own line managers can accurately price the work. They can't bid on an ambiguous document.
And that rewriting and negotiation process is where things can go horribly wrong. The sources warn that a misinterpretation in the SOW can lead to losses in the hundreds of millions of dollars.
It's terrifying. And the causes of these huge losses are deceptively simple things, like mixing tasks, specifications, and instructions all together in a disorganized mess.
But the really dangerous part is the imprecise language.
Words like nearly, optimum, approximately, or best efforts. If a SOW asks for an optimum solution, what does that even mean?
The contractor might define optimum as the most cost-effective solution.
While the customer defines it as the highest possible performance, regardless of cost, that one word, optimal, is a guaranteed expensive legal battle.
Other issues are pretty basic, like a lack of chronological order or just failing to get a third-party review.
You need a fresh set of eyes, someone who didn't write it, to read it and find those ambiguities.
To fight this, the guides for preparing an SOW are like an editor's rulebook. They demand precision.
For any SOW over 2 pages, you need a table of contents, and it has to conform to the contract work breakdown structure coding. That ensures traceability right from the start.
You also have to use active rather than passive language. And ideally, you want to avoid overspecification.
That's the best practice. Specify the results you want, the end item, and let the contractor propose the method for getting there.
Because, and this is a critical legal and management point,
It is. The PM has to know that any provision that takes control of the work away from the contractor might also relieve them of responsibility.
so if you tell them how to build the widget instead of just what the widget needs to do and then it fails,
You've basically co-owned that failure. You can't control the means and then hold them 100% accountable for the ends. It doesn't work that way. That's a huge shift in liability. Okay, let's talk about the hidden cost monster in every SOW, documentation and data items. These are all the deliverables and reports, everything from a status memo to the final technical manuals.
and the cost of this documentation is, and I'm quoting here, truly exorbitant.
It really is. People don't see the direct labor that goes into it. The writing, typing, technical editing, proofing, graphic arts, reproduction. It's a staggering amount of work.
The sources give us a hard metric. Typically, it takes 6 to 8 hours of work per single page of documentation.
So now, let's do the math. You take those hours and multiply by a standard burdened hourly rate. And for anyone listening, the burden rate isn't just salary. It's salary plus overhead, benefits, admin costs. It could easily be $150 an hour.
So that means the cost of one single page of documentation could be $1,000.
Easily, $1,000 per page. Many smart companies deal with this by pricing out data items separately in the contract. They'll detail the number of expected pages and multiply it by that rate.
And when the customer sees how expensive their reporting requirements are,
They are often induced to ask for fewer, more strategic reports. It can save a project millions in pure administrative overhead.
that one fact that every page of a report might cost $1,000 should change how every PM negotiates deliverables.
Finally, you have project specifications. These are the technical standards, Civil 100, Electrical 200, that kind of thing.
And even a tiny change in a spec can cause a huge cost overrun.
A massive one. So it is absolutely vital that you're using the most current revision of every spec and that they are explicitly included in the SOW. No surprises for the customer later on.
Okay, so if the SOW is the narrative of the project, then the work breakdown structure, the WBS, is the architectural blueprint.
Our sources call it the single most important element in all of project management.
That's a bold claim. Why?
Because the WBS is a product-oriented family tree. It subdivides all the hardware, services, and data you need to produce the final product. It is the common framework for everything.
For planning, for costing, for tracking.
For linking objectives to resources, and for establishing accountability all the way down to the lowest level of work, it is the project's single source of truth.
And for it to work as a control tool, every single element in that WBS has to meet 4 essential characteristics.
The 4 essentials. First, the work element has to be manageable. You have to be able to assign clear authority and responsibility for it to a person or a department.
Second, it has to be independent, meaning it has minimal interface or dependence on other elements. You want clean lines of separation.
Third, it must be integratable. All the little pieces have to sum up to a visible total package. You have to be able to roll up the costs from the bottom to the top.
And fourth, it has to be measurable in terms of progress. If you can't tell if an element is 20% done or 90% done, it shouldn't be a WBS element.
And if an element fails, even one of those 4 criteria, the entire WBS fails as a management control tool. It's that critical.
The sources detail the standard architecture as this 6-level indented structure, and it really clarifies the difference between management oversight and technical work.
The top 3 levels are the managerial levels. Level 1 is the total program, which is used for executive authorization.
Level 2 is the project, where the main budgets are set.
And level 3 is the task, which is generally where you prepare the major schedules. These top levels define the integrated efforts. They shouldn't be tied to any one specific department.
Then you move down into the technical detail. Below the task level, you have subtask, level of effort, and the most critical point for hands-on control. Level 5, the work package. And the lower levels define the specific work done by specific departments.
Right. And the rule is absolute. The sum of the effort at any one level has to exactly equal the sum of all the work in the level right below it. No gaps.
Let's zoom in on that work package at level 5. You called it the building block.
It is. Management might happen at higher levels, but this is the unit where the work actually gets done, and it's where the costs are collected.
So what makes a good work package?
It has to be clearly distinguishable from other work being done by that same group. It needs a clear start and end date, a specific budget, and, this is critical, the work has to be limited to short periods of time.
Why short period?
For management control. It minimizes your work in process, your WIP, and it gives you quick visibility into whether something is on track or failing before you sink a ton of resources into it.
Okay, now here's the big caveat. The WBS is the most important element, but managers often think that more detail is always better.
And that leads to WBS decomposition problems. Breaking the work down too far comes with very steep, often exponential costs.
The first problem is just exponential cost.
Right. Analyzing cost data down to level 5 is great for your internal control. But if the customer starts demanding non-standard cost reports for every level below level 3, the administrative cost can just explode.
This goes back to that $1,000 per page reporting cost.
Exactly, which is why many savvy companies actually bill customers separately for any cost reporting they require below level 3.
The cost of reporting starts to outweigh the benefit of the detail, which leads to the second problem, management overload. If you break the work into thousands of tiny little cost accounts, you exponentially increase the cost of managing, controlling, and reporting on all of it. You reach a point where the admin cost is higher than any benefit you get from the control.
Right. And line managers have to have the authority to push back and say, look, we can't determine costs accurately or usefully at this level of detail.
And the third problem is just complexity and scheduling.
At the lowest levels of the WBS, the interdependencies between all the little activities can become so complex that you can't even build a meaningful schedule network.
You're talking about tools like ADM or PDM, the network diagrams that show your critical path.
Exactly. If the WBS is too granular, the number of dependency arrows on your diagram becomes so immense that the whole thing is unusable. The blueprint becomes too tangled to even read.
So the key insight is to design the WBS with intentional restraint.
Because once it's set and the project is running, adding or deleting activities or changing reporting levels is incredibly expensive and disruptive. You build the WBS to be stable because that stability is what makes your cost tracking reliable.
Finally, the WBS doesn't always have to look like a simple family tree. The sources give 3 different ways to structure the blueprint.
It depends on the project type and length. First is the flow method. This breaks the work down into systems and subsystems. It's best for shorter projects, typically less than 2 years.
Second is the life cycle method.
This is similar, but it structures the work based on the project's phases: conceptual, definition, design, manufacturing. It's really tailored for longer, multi-year projects where the phases are very distinct.
And the third method is the organization method. This one seems the most unique.
It structures the WBS based on the company's own org chart division department section. You use this for projects that are really repetitive or projects that require very little integration between the different functional teams.
So if the work mirrors the company structure, this method just reduces friction.
Exactly. The blueprint has to be tailored to the environment it serves, just like communication.
So we start this deep dive by talking about foundations, moving from the soft skill of communication to the hard structure of the WBS.
And we've seen that communication failure is the single biggest project killer. It takes up 90% of a manager's time. We saw how the channels formula proves that complexity scales exponentially.
And we saw how all those psychological screens and organizational filters, like that project office bottleneck, are constantly distorting the message.
We also detailed how the statement of work demands surgical precision. Using ambiguous words like optimum can cost millions, and failing to respect that principle of accountability can shift liability in massive ways.
And we learned the staggering truth that a single page of administrative reporting could cost you $1,000. And finally, we saw that the work breakdown structure is that single source of truth for planning and control. It's defined by its 4 essentials: manageable, independent, integratable, and measurable. But we also learned the critical counter lesson, that breaking the WBS down too far leads to management overload and skyrockets your reporting costs, ultimately costing you more than the benefit of that extra detail.
We've established that good communication has to deliver both information and motivation, and it's always fighting against the natural friction of an organization.
So given how much time a PM spends communicating and all that resistance where the project office is seen as a filter, we have to consider the reality of where control really lies.
If your team members, who feel filtered and slowed down by the official hierarchy, decide to create their own informal channels to get work done, and they almost always do,
Does control ultimately rest in the hands of the communicator who sets the formal rules?
or does it rest with the listener, whose perception and needs dictate the creation of those informal and often more efficient channels?
The answer to that question often decides whether your perfectly planned WBS and your brilliantly written SOW ever actually see the light of day as a successful project. We encourage you to audit your own communication environment with that thought in mind.
Thank you for joining us for this deep dive into the foundational architecture of project success.
We'll see you next time. Welcome back to the Deep Dive, where we take complex, multi-layered source material, your reading stack, and break it down into the vital, actionable knowledge you need to be truly well-informed.
Today, we are undertaking a really focused, very technical deep dive. We're moving well past that high-level strategy phase of just kicking off a project.
Right.
We are plunging straight into the mechanics of execution, of control, and ultimately of effective closure. The source material we've got is essentially a structured masterclass in preventing chaos on complex, large-scale projects.
That's a great way to put it. If you've ever looked at some massive endeavor, a new piece of infrastructure, a multi-year software build, maybe a pharmaceutical trial, and just wondered how the managers actually keep hundreds of tasks, thousands of resources, and millions of dollars aligned. Well, this is the operational playbook.
It really is.
Our mission today is to unpack the fundamental tools of project control. We're going to start with how we rigorously define what success even looks like, using something called the WBS dictionary. Then we'll analyze how we decide if a project is even worth the investment with selection models.
And then, crucially, we'll detail how we master time using network scheduling techniques like PEERD and CPM.
It is definitely technically dense material. It covers clarity, complex financial decision-making, and some pretty hardcore time management.
It is.
Yeah.
But we've pulled out the essential concepts that, once you understand them, will fundamentally change how you view project planning and risk. We promise to distill these into insights you can apply immediately, whether you're leading a team or just sitting in the steering committee meeting.
So where do we start? What's the absolute foundation?
Let's start right at the absolute foundation of scope definition, which surprisingly isn't the work breakdown structure itself, but what comes with it.
Okay, let's unpack this. We always start with the work breakdown structure, or the WBS. At its most basic level, the WBS is a numerical framework, right? It's like a sophisticated hierarchical numbering system for organizing every single piece of project work. Every deliverable, every component gets a number.
Exactly. And that numbering system is absolutely vital because it establishes a standardized architecture for tracking everything. Think of it like the structure of a complex software system, or maybe a multi-volume library index. But as the source material is very quick to point out, numbers alone are, well, they're highly insufficient.
What do you mean?
Well, for instance, WBS element 1.2.3.4 might just be titled Database Integration.
Okay, that sounds clear enough.
Does it? I mean, that title is so open to interpretation. What kind of database? What level of integration? What are the performance metrics? So you often see wording added to the WBS elements themselves to provide some initial clarity, but even that can still leave a significant amount of ambiguity.
Wait a minute. If the WBS already has titles and numbers, why on earth do we need a separate, often very lengthy document like the WBS dictionary? I mean, isn't that just redundant paperwork that slows everything down?
That's a common misconception, but it gets right to the heart of project control. The WBS is the skeleton. The WBS dictionary is the muscle, the tissue, the vital organs. It is the definition document.
Okay.
The dictionary isn't just repeating the titles, it's defining the meaning, the intent, and most importantly, the acceptance criteria for each and every single element. The WBS dictionary is the single source of truth that transforms these vague terms into contractual requirements.
So this is where the real detail lives. Let's get specific then. What makes this dictionary so comprehensive and, frankly, so vital for any kind of managerial control? What specific contents must be included for every single element in that WBS structure?
It's a remarkable checklist of control points, really. You're looking at several interlocking categories. First, you've got the immediate description, a brief, clear narrative of what the element is. But then you immediately connect it to accountability and to finance.
So it's not just what, but who and how much.
Precisely. The dictionary must list the responsibility. This means the person or the specific cost center that is accountable for delivering that element. And this is often cross-listed to a formal responsibility assignment matrix or a RAM chart, ensuring there's absolutely zero doubt about ownership.
Responsibility is key, sure, but you mentioned the financial link. I feel like that's where the control truly begins.
Oh, absolutely. The dictionary identifies the associated cost and the specific charge number to be used for tracking any expenditures related to that WBS element. If you don't connect the work package to the financial system through the charge number, you lose cost control instantly. It's that simple.
And resources.
It also lists the required resources. And it gets specific. They're specified either by name, for unique critical individuals, or by a specific skill level. So you might see, senior certified welders versus just junior analyst.
So it's not just we need an engineer, it's we need this type of engineer with these certifications.
Exactly. And then you have to define the actual deliverables, both in terms of time and technical specs. This includes the major milestones within that element and the exact nature of the final deliverable. This leads directly to what I think is the most critical section for preventing conflict.
Yes.
The technical specifics and the quality requirements. It has to provide a detailed technical description, the mandated quality standards, like, say, an ISO certification level that's required, and it has to have cross-listings to any contractual documentation that formally defines these standards.
I can see immediately how this tackles scope creep, which is the bane of every project manager's existence.
It is the ultimate antidote. The WBS and its dictionary are the critical tools for what's called scope verification. So, validation and acceptance of all the work, all the deliverables, it's not achieved by a general handshake at the end.
No.
They're accomplished by referencing them against the descriptions, the acceptance standards, and the clear completion criteria that are laid out precisely in the dictionary.
So this means it's serving as the definitive baseline. It's constantly monitoring the difference between what stakeholders might suddenly decide they want versus what the team contractually agreed they need.
Exactly. By establishing these hard documented boundaries, the agreed-upon technical and quality parameters, this dual documentation system ensures the project team doesn't attempt to deliver outcomes or a level of quality that exceeds the requirement boundaries.
That's a subtle but important point. It's not just about preventing less work, but also preventing more work.
Yes. That's how you contain scope creep. If a stakeholder comes along and asks for an expensive gold-plated feature, the PM can point directly to the WBS dictionary and say, look, our agreed-upon quality requirement is stainless steel, and that is what we are funded and scheduled to deliver.
It also sounds like a phenomenal communication tool just for keeping everyone on the same page.
It simplifies communication profoundly. Think about project closure. Ill-defined criteria are probably the most common source of disagreement, especially at the end of a project when funds are getting tight and everyone's patience is low.
Right.
The dictionary provides crystal clear completion criteria, which ensures that everyone agrees on what done actually looks like from day one. During the execution phase, the WBS hierarchy acts as a dynamic checklist, and at the end, scope verification supports the transition to ongoing operations, and the dictionary becomes the basis for the formal contract and project closure processes. It verifies everything was delivered as defined.
So it's the bookend to the entire effort. It ensures that the final handoff is smooth because everyone was working to the same documented standard all along.
That's the idea. It's the ultimate tool for clarity.
Okay, so we've rigorously defined what we would do with the WBS in its dictionary, but now we hit that necessary gate. Should we even start this project in the first place? This transition brings us to project selection, which sounds like a prime, high-stakes responsibility for senior management and project sponsors.
It is. And the high stakes are exactly why the selection criteria are so diverse. They can range from very subjective criteria, like strategic fit or competitive advantage, to very objective quantitative metrics based on financial return.
But the bottom line is,
A bottom line, and the source material is adamant about this, there must be a valid, documented reason for choosing that project over all the others that are competing for the same limited resources.
the sources outline a really clear two-part financial and technical process that acts as the formal gate before you get approval. This seems to address both capability and commitment. What's the core insight of separating these two processes? Why not just do it all at once?
The core insight is minimizing sunk costs by failing fast on technical impossibility. You want to figure out what you can't do before you spend a lot of money analyzing if you should do it. So part one is the feasibility study. This answers the question, can we do it?
Okay.
It validates that the project meets the basic requirements for cost, for technological viability, safety, marketability, and ease of execution. You bring in your subject matter experts, your SMEs, to determine if this thing is even buildable within the known universe of technology and resources.
And only once that feasibility is established, once we know we can build it, only then do we move to the tougher question, the benefit-to-cost analysis, which determines if the company should do it.
Precisely. The benefit-to-cost analysis is a commitment. It requires significantly more scrutinized and, frankly, expensive information than that initial feasibility study. You are now investing heavily in predicting future returns, and you have to validate whether the potential profit justifies the inherent risks and the opportunity cost of not doing something else.
Let's draw a sharp distinction between these two processes because it sounds like they happen at different project lifecycle phases and require totally different types of data.
They do. The feasibility study happens in the preconceptual phase. It's primarily qualitative, and it focuses on rapid, critical go-no-go factors. Is it technically possible? What's the order of magnitude cost? What are the quality standards, the safety issues, the ease of performance? And critically, the sources note, the project manager is usually not yet selected at this very preliminary stage.
The benefit-to-cost analysis, though, that's a whole other beast.
Completely. That moves into the conceptual phase, and it is highly quantitative. The critical factors shift to rigorous financial metrics. We are talking about net present value, NPV, discounted cash flow, internal rate of return, IRR, and return on investment, ROI.
Okay, a lot of acronyms there.
Right. And furthermore, you have to assess the probability of success and the reality of every single underlying assumption. The executive decision criteria shift from, is this a good fit for us, to, will this generate the required shareholder value?
Let's pause on NPV and IRR. I mean, these are more complex than a simple ROI. For you, the listener, who is focused on the result, why are these metrics so necessary for this level of decision-making? Why not just look at the total profit?
Because they account for the time value of money, which is absolutely fundamental. $1 today is worth more than $1 next year. Simple ROI just tells you the final return percentage. It doesn't care when you get that return. Net present value, NPV, calculates the difference between the present value of all the cash inflows and the present value of all the cash outflows over the project's entire life. If the NPV is positive, the project is expected to be profitable after you discount all those future dollars back to today's value. If it's negative, the project actually destroys shareholder wealth.
And IRR, how is that different?
Internal rate of return, IRR, is the discount rate that makes the NPV of a project exactly zero. Essentially, it's telling you the expected rate of return the project will generate internally. Senior management usually sets a hurdle rate. Let's say it's 15%. If the project's calculated IRR is 18%, it's financially attractive. If it's only 12%, it fails the hurdle rate.
Even if it still makes money.
Even if it's technically profitable, it means the company can earn a better return by investing that same money elsewhere. These quantitative tools force an objective assessment of the long-term financial reality.
Okay, that makes sense. Now, to gather that initial input during the feasibility phase, management uses rating models. They're often soliciting feedback from those subject matter experts. The source material details 3 types. Let's start with the simplest, the scaling model.
The scaling model is great. It provides a quick, standardized method to score a single project against a specific set of criteria. It uses a continuous scale, typically ranging from a negative value, say maybe 2 for unacceptable or poor, to a positive value, like +2 for excellent or good, with 0 being fair or neutral.
And the criteria could be anything.
Anything relevant. They could be technical like design difficulty or patentability, or high-level strategic concerns, such as competitive reaction or even Wall Street impact. It just gives management a quick snapshot of where the project sits on a weighted scale of risk and return.
Then you have the checklist rating system.
This is more of a comparative tool. You use it to evaluate multiple competing projects at the same time against a fixed set of mandatory and desirable criteria: profitability, marketability, likelihood of success. It allows for a side-by-side comparison, often just assigning a simple yes-no, or maybe a 1-5 score. It helps highlight which projects even meet the baseline standards before you move on to more complex scoring.
And finally, the most mechanically complex, and it sounds like the most rigorous model, the scoring model, which uses weighted averages.
This is the most popular input mechanism because it forces the organization to actually prioritize what it cares about. The process is this. You have your criteria like producibility, profitability, or risk reduction, and they are assigned weights, for example, 4, 3, 2, 1, reflecting their importance to the corporate strategy. A criterion that's weighted 4 is literally twice as important as one weighted 2.
Let's walk through a quick example to make the math here really clear.
Sure. Let's say we have 3 criteria for a new product project. Patentability gets a weight of 4, because it's super important to us. Marketability gets a weight of 3. And design difficulty, how hard it is to build, gets a weight of 1.
Okay.
Now, Project Alpha is scored 8 out of 10 for patentability, a perfect 10 out of 10 for marketability, and a 5 out of 10 for design difficulty. So the calculation is 4 times 8 plus 3 times 10 plus 1 times 5. That's 32 plus 30 plus 5 for a total weighted score of 67.
And then you'd compare that to other projects.
Exactly. Project Beta might have higher raw scores in some areas, but if it scores lower on the high-weighted criteria like patentability, it could end up with a lower final weighted score. That would make Project Alpha the winner because it aligns better with the organizational priorities that are encoded in those weights. It literally quantifies strategic intent.
So once they decide they should proceed based on these scores, they have to quantify the financials precisely. Benefits seem pretty straightforward, but the sources say costs are much trickier.
They are. Benefits are usually split into 2 buckets. You have tangible benefits, which are quantified in hard dollars like increased sales or reduced operating expenditure. And then you have intangible benefits.
Which are?
Those are quantified subjectively or in other units. Things like improved employee morale, regulatory compliance, or enhanced brand visibility. Intangible benefits are often the hardest to sell to a CFO, but they can be strategically crucial.
And the cost side, why is that so difficult to quantify?
Because you have to determine the absolute minimum costs needed for the comparison. This includes the current operating costs, the baseline of what it costs to operate today. Then you have future period costs, expected planned expenditures that occur after the project is complete, like maintenance or support.
And the intangible costs.
And finally, the intangible costs. These are the hardest of all. The loss of employee goodwill during a difficult rollout or temporary market confusion. Crucially, the sources note that intangible costs are often omitted entirely if quantifying them adds little value to the final decision, just because they're so subjective and hard to defend.
So what's the ultimate takeaway on the validity of this whole selection process? Where does it fall down?
It rests entirely on the integrity of the input. Unrealistic or unrecognized assumptions, like assuming 0 regulatory friction or perfect resource availability, are frequently cited as the cause of unrealistic benefits and, ultimately, project failures down the line. All known constraints and assumptions have to be carefully documented because that final go-no-go decision rests entirely upon their validity.
And this leads us to the evolving role of the project manager. Traditionally, the PM only arrives after the go-ahead is given.
Right.
But the sources talk about a new breed of PM, one equipped with strong business acumen who is joining during this initiation phase to contribute valuable knowledge before the project selection is even finalized.
And their early involvement is critical for grounding the business case in execution reality. They provide specific expertise on opportunity options. They can quantify potential market share gain or sales volume. They define precise resource requirements and the necessary skill sets. They refine cost and savings estimates, and they often flag early inconsistencies.
So they're a reality check.
A huge one. They verify that the projected benefits realization is actually consistent with the corporate business plan. And fundamentally, they are the first to identify potential risks and maybe even exit strategies. Their presence at that initiation gate ensures management isn't just approving a dream, but a potentially executable plan.
All right, so once a project is selected, authorized, and it starts moving toward execution, strong governance becomes non-negotiable. Our sources place a great deal of responsibility on the executive or the sponsor role, specifically during the planning phase itself.
Absolutely. The first responsibility is selecting the right talent for the job. Executives have to ensure they select PMs who possess both high-level planning skills and detailed execution expertise.
That seems obvious.
You think so? But the common pitfall is assuming that a technically excellent specialist will automatically be a good planner. That often leads to scheduling disaster. The executive, who is serving as the sponsor, must then take an active, visible role during that early planning phase to set the right tone.
And this brings us to a crucial governance pitfall that the source material is very direct about: the imposition of unrealistic deadlines by executives.
It's a toxic dynamic.
Yeah.
Executives must not arbitrarily set unrealistic milestones, the infamous mandated end date, and then just force the line managers, who are the technical experts, to adhere to them. The sources are clear. If the line manager says, based on their expertise, that they cannot fulfill a timeline, the executive should comply and work with that technical reality.
What happens if they don't?
Ignoring the line manager fundamentally undermines the entire planning effort. The plan becomes a work of fiction before you've even started.
So what if a critical, unreasonable deadline is genuinely needed for some external strategic reason, like you have to beat a competitor to market? What must the executive do then?
They must realize that imposing a timeline like that requires a reestablishment of corporate priorities. That means they have to provide more resources, they have to remove conflicting priorities from the team, or frequently they have to push milestones backward for other, less critical projects.
So you can't just get something for nothing.
You cannot simply use authority to command a technical impossibility into existence. You must pay the organizational cost for that speed, whether it's through resources or deprioritization somewhere else. Reasonable deadlines are established through interface and mutual agreement, not by executive decree.
Now, for complex long-term projects, organizations need a structured management cost and control system, or MCCS, to keep everything aligned and prevent the work from being, as the source says, overphased, which causes delays and budget bloat.
The MCCS is really a necessity for efficiently managing these long-term project-driven companies. It's a systemic approach, and it's composed of 5 distinct phases. The first is the planning cycle. This is then followed by 4 stages of the operating cycle. Typically, that's the engineering phase, the manufacturing or construction phase, the test phase, and then the support or documentation and training phase at the end.
And how does our foundation, the WBS, fit into this vast MCCS structure?
The WBS is the vital artery that runs through all 5 of those phases. It serves as the initial control mechanism during planning, and its numerical structure provides the unified communications backbone throughout the entire operating cycle. Every single phase references the WBS to define what work is happening, who is responsible, and what costs are being incurred.
Now let's get to the process of actually releasing funds. We have 2 key authorization methods mentioned: work planning authorization, WPA, and work authorization, WA. The distinction is subtle, but it sounds critical.
It is. Both are about releasing money, but WPA releases funds pre-execution. WPA is primarily for functional management to prepare detailed schedules, to refine their cost estimates, and to finalize budgets. Basically, it funds the planning cycle.
And WA?
WA, on the other hand, releases the actual operational cycle funds. That's the money for physically executing the work that was defined in the plans.
And the central document that drives both of these is called the Subdivided Work Description, or the SWD.
The SWD is the formalized contractual narrative. It is a detailed description of the effort that is to be performed by a specific cost center, often at the division level minimum. The SWD is the document that's released by contract control that authorizes program management to actually proceed.
So it's the green light?
It's the official green light. It sets forth the contractual guidelines, it specifies how the work will be performed, it identifies which organizations are involved, specifies who holds specific responsibilities, and it formally authorizes the utilization of resources within a given time period. Without a signed SWD, no resources move, and no money is spent on that specific work package.
We often hear that if the hours or the dollars that are released in the final work authorization, the SWD, are significantly different from what was in the original proposal, that the project is immediately in trouble. Is that a legitimate concern, or is that just paranoia?
It's often a complete distortion of reality. The sources provide a fascinating reality check here. When a company writes a proposal, especially in a competitive bidding environment, it often estimates its costs based on an idealized world of unlimited resources, meaning, perfect staffing, perfect equipment availability, minimal internal friction. However, the hours and dollars that are listed in the actual work authorization, the WA or the SWD, are based upon the company's limited resources, what is actually available, what is budgeted, and what is scheduled for that specific time period.
So it's the difference between theory and practice.
Exactly. This difference is common, and it simply reflects the necessary reconciliation between an idealized estimate and the operational constraints of the real world. It doesn't mean the project is failing. It just means it has transitioned from being a sales document to being a grounded, realistic control document.
Okay, so once that WA is approved, scheduling the activities becomes the first major execution requirement. This is the master plan, right? And it's the single most important tool for integrating every resource across the company, for tracking performance, and for estimating costs over time.
And this demands a ton of rigor. Our source material provides 4 non-negotiable guidelines for preparing any schedule. First, you have to identify all major events and dates, including any customer-supplied milestone dates. And there's a mandatory requirement for immediate notification if they cannot be met. You cannot hide slippage.
No hiding. Second,
you must define the exact sequence of the work through a network to identify the crucial interrelationships. This is where we move beyond simple lists and into logic.
Third, every schedule has to be directly relatable to the WBS, using the same numbering system where possible. This ensures seamless cost and performance tracking.
Right. And fourth, they must identify all the time constraints and the required resources for each event, not just how long it will take.
And organizations often produce multiple schedules based on the level of detail required for different audiences.
Exactly. You'll have summary schedules that are tailored for senior management and for planners. These are high-level strategic views. Then you have detailed schedules, sometimes called shop schedules, that are designed for the doers, the line workers, for lower-level control and coordinating all that interdepartmental activity. Program management, which represents the customer and the sponsor, must approve all schedules down to the first 3 levels of the WBS to maintain that alignment.
You mentioned a hedge position earlier. What does that look like in practice, and why is it so dangerous?
A hedge position is a deliberate risk-incurring situation. It's where a contractor chooses an aggressive path that actually risks missing a customer milestone or failing to meet subsequent activity requirements.
Why would they do that?
Often because they are trying to speed up one area to compensate for delay somewhere else, or to satisfy a potentially conflicting contractual need. It's essentially a temporary calculated gamble, a warning sign that requires high management attention because it means the schedule is inherently unstable.
Now we get to the core of this segment. Network scheduling. Why do we even bother with the complexity of networks like PERT and CPM when simple Gantt charts are so common and easy to read?
Because simple charts, Gantt, milestone, or bubble charts, they all fail to show the absolutely crucial element, the interdependencies between the events and the activities. They show timelines, but they don't show logic.
Yeah.
Networks, conversely, provide a pictorial representation, a roadmap, that clearly eliminates the need for reactive crisis management because you can see the entire logic flow up front.
So what specific high-value management information do these networks provide that a Gantt chart can't?
Okay, so they reveal the logical interdependencies, they determine the overall project completion time, they show the impact of early or late starts on all the subsequent tasks, they allow for critical trade-offs between resources and time, and most importantly, they identify the critical path.
Let's define the nomenclature of these networks. What are they made of?
They're built from 2 things, events and activities. An event is a milestone, just a point in time. It indicates the start or the finish of an activity, and it's usually represented by a circle. An activity is the actual element of work to be accomplished. It's represented by an arrow showing the flow of time and logic. And over that arrow, you typically list the time or the duration needed for that activity.
And we have to distinguish between duration and effort here. This trips people up.
It does. It's a common confusion. Duration is the total calendar time required. Effort is the actual amount of man-hours or work performed within that duration.
Give me an example.
Okay. An activity might have a duration of 30 calendar days, but the actual effort applied might only be 2 weeks of actual labor, because the rest of that time is spent waiting for materials to arrive or for an internal review to happen. Networks primarily track duration for scheduling purposes, but effort is what you track for cost.
We also have concepts like burst points and sinks.
Right. A burst point is a single event, one circle. That must take place before several other events or activities can begin. So it has many arrows leading out from it. A sink is the opposite, where multiple preceding events must take place before a single subsequent event can occur. So many arrows leading into one circle.
And this structure answers some really foundational questions, doesn't it?
It does. It answers what precedes this task, what follows it, and what jobs can be run concurrently.
And the critical path is established by identifying the longest time span through that entire system of events and activities.
That is the single most important metric for time control. The critical path determines the minimum duration necessary to accomplish the entire project. And it has 2 vital implications for management. First, it has 0 slack time. Any slippage of even 1 hour here immediately threatens the overall end date.
And second,
it tells management exactly where they must focus their greatest efforts, their resources, and their oversight to keep the project on schedule. Resources applied anywhere else are inherently less critical to the timeline.
okay, let's get into the 2 major network techniques, PERT and CPM. The difference seems to be rooted in how well we can estimate time.
That's precisely right. PERT, the Program Evaluation and Review Technique, is designed for high uncertainty. It uses 3 time estimates for each activity: an optimistic time, A, a most likely time, M, and a pessimistic time, B. It then uses the beta distribution formula to derive a weighted expected time.
The formula being T, A plus 4 meter plus B, 6. Why the beta distribution, though? Why not just use the simple average of the 3?
Because the beta distribution is specifically chosen, because it is probabilistic in nature and it models uncertainty very well when estimates are often skewed, and in project management, they're usually skewed toward the pessimistic side.
Right.
Since PERT is used for R&D or cutting-edge projects where the work is often unprecedented, we need to calculate the standard deviation and variance. This allows management to calculate the statistical risk or the probability of completing the project by a specific deadline. It acknowledges that the time estimates are just educated guesses.
And because of that uncertainty, it's hard to say how far along you are.
Almost impossible. Determining percent complete in a PERT project is very difficult until a major milestone is hit, like a successful test is completed.
Now, contrast that with CPM, the critical path method.
CPM is the opposite. It uses a single time estimate, which is called a normal time, and that implies a much better accuracy in the estimate. It is deterministic in nature. This is used in mature, resource-dependent environments like construction, manufacturing, or established process industries, where time estimates are reasonably accurate because the work has been done many times before.
So if I'm building a bridge, that's CPM. If I'm trying to, I don't know, invent a new type of rocket fuel, that's PER. Is that a fair way to think about it?
That's a perfect way to think about it.
Yeah.
And because progress is more predictable in CPM, percent complete can be reasonably determined, which is crucial for things like customer billing and progress payments.
Moving to the logic of the network itself, we have to define the dependencies.
Right. You have mandatory dependencies, or hard logic. These are things that cannot change because of physical laws, like you have to install the plumbing before you pour the concrete floor. Then you have discretionary dependencies, or soft logic. These are at the project manager's discretion, like deciding to finish all the electrical schematics before starting any of the wiring. A PM might choose to change that logic later to speed up the process.
And what about external dependencies? Those sound risky.
They are. These are dependencies that are beyond the PM's control, like getting regulatory approval or relying on a specific external contractor. If that contractor sits on your critical path, the project's fate is tied to an external entity, which is a major, major risk flag.
The sources mention a concept that seems counterintuitive: the dummy activity. Why would you add an activity to a plan that consumes no resources and no time?
Dummy activities, which are represented by a dotted line, are added purely to preserve the network logic when the structure demands it. For instance, imagine activity D needs both activity A and activity B to be completed as predecessors, but activity C only needs activity B to be completed.
Okay.
If A and C don't interact at all, you sometimes need a dummy activity running from the completion of A to the start of D to correctly signal that logical dependence to the scheduling software, without accidentally implying that A must precede C. It's a structural necessity to maintain the correct logical relationships.
It's a tool for the software, really.
It is. Finally, we should just touch on GERT, the graphic evaluation and review technique, as it addresses the limitations of standard PERT in highly uncertain environments.
How so?
GERT is similar to PERT, but it's designed for maximum structural flexibility. It allows for looping, which means if an activity is a test that fails, you can explicitly model repeating that test several times until success is achieved. It also allows for branching, where based on the outcome of an activity, you can select one of several different paths to continue the project. And it can handle multiple possible project end results, which makes it ideal for extremely complex research or design processes with nonlinear paths.
Okay, so since the critical path is the longest sequence of tasks, by definition, every other path in the network must be shorter or equal in length. That differential in time is the concept of slack time, or float. This is the hidden time that management can strategically leverage.
Slack time is the strategic breathing room. It really is. Mathematically, it's defined at the event level as the time differential between the latest allowable date, which we call TL, and the earliest expected date, TE. So slack time equals TL minus TE. It measures how late an event can start or finish without pushing back the project's final completion date.
So if I have a task with 10 days of slack, what does that practically allow me to do as a manager?
It allows for resource optimization. Management can strategically use that slack time to reschedule non-critical path events to periods when maximum resource utilization can be achieved across the entire organization.
For
instance, if a highly specialized, expensive engineer is needed for 2 different non-critical tasks that have, say, 5 weeks of combined slack, you can schedule those tasks to ensure the engineer is fully utilized, eliminating their idle time, and potentially reducing the overall project costs. You're not paying them to sit around.
Let's get into the weeds of the calculation for a second, because we track 4 values when we're focusing on activities, not just the events. This is where the forward and backward passes come in.
This is fundamental to understanding network dynamics. The calculation is 2 steps. The forward pass calculates the earliest possible times. The earliest start time, ES, and the earliest finish time, EF. You start at day 0, and you move forward through the network, taking the longest path into any node as the determining ES for what comes after it.
And then the backward pass.
The backward pass does the opposite. It calculates the latest allowable times, the latest start time, LS, and the latest finish time, LF. You start at the final project end date and you work backward, determining the latest an activity can possibly start or finish without jeopardizing that end date.
And the term float is used for activities?
Right. The term float is used when this slack is calculated specifically on the activity itself, though honestly, TMs often use slack and float interchangeably. The key takeaway is, if an activity has 0 float, it's on the critical path.
Okay, now for the major warning signal, the appearance of negative slack. That sounds like a mathematical catastrophe. What exactly causes negative slack, and what does it mean operationally?
Negative slack, or negative float, is a severe indicator of project health issues. It occurs when the forward pass, which determines the earliest time the work can be done, extends beyond the customer's fixed contractual end date.
Okay.
However, since the backward pass must mathematically be measured from that fixed customer end date, the system is forced to generate a negative value for the float calculation.
So if my forward pass says the earliest my project can finish is day 300, but the customer's contract demands day 280, I have 20 days of negative slack.
Exactly. And that 20 days is an immediate high-priority warning that requires corrective action. The system is telling you, based on our current logic and our time estimates, we will fail the deadline by 20 days unless we change something immediately. It's the project's check engine light flashing bright red.
It's not a warning, it's a statement of fact. You are currently failing.
That's a great way to put it.
What are the common organizational causes for this immediate failure state?
They're almost always rooted in flawed initial assumptions or execution slips. The causes include: the original plan was wildly optimistic or just unrealistic. The customer's fixed end date was unrealistic to begin with. One or more critical path activities slipped during execution. The assigned resources lacked the correct skill levels and took longer than expected, or maybe the required resources were simply unavailable until a later date than was promised. It demands an immediate, executive-level intervention.
Since perfection is impossible, networks require iteration and replanning. The slack times form the essential basis for this reality adjustment. Let's look at the two primary resource-based techniques for this: leveling and allocation.
The first is resource leveling, which is also known as smoothing. The goal here is efficiency. It attempts to eliminate severe manpower peaks and valleys, the boom and bust cycle of demanding staff and then having them sit idle. It does this by using the available slack time to smooth out the resource requirements from one period to the next. The ideal outcome is achieving this resource stability without changing the project's end date.
But the sources warn that leveling often elongates the project and can even drive up the cost.
It does, because you might delay a task that could have started early just to wait for a shared resource to become available. But it's often a necessary trade-off for efficiency and for quality. However, sometimes leveling actually saves money.
How?
The example provided is brilliant. If two teams on different paths both need an extremely expensive resource, like a tower crane or a specialized testing facility, at the exact same time, you can use the slack time on the less critical path to delay that activity until the resource is finished with the critical one. This reduces your maximum demand to one unit, avoiding the rental, the mobilization, and the labor costs of a second unit, which can save substantial capital.
And the second technique is resource allocation or resource-limited planning.
Allocation flips the problem around. Instead of trying to maintain the end date, you accept that your resources are fixed and finite. You are finding the shortest possible critical path based entirely on the available or fixed resources you have. This forces hard decisions about resource sharing, weighing the travel costs of sending staff to another site versus the recruitment and training costs of hiring new personnel.
If neither leveling nor allocation is sufficient to resolve the negative slack and hit a fixed deadline, management has to resort to schedule compression or crashing the schedule. What are the high-risk methods for reducing the expected project time?
Crashing usually involves either spending a lot more money or accepting a massive amount of risk. The methods include adding more resources, which is called crashing resources, substituting less time-consuming components, or, most critically, engaging in the parallelization of activities.
And parallelization means accepting risk by starting events in parallel that you would normally do in sequence.
That's where the organization's real risk tolerance is exposed. A classic high-risk parallelization technique is sending out a long lead procurement letter after contract negotiations are positive, but before the contract is officially signed.
Oh, that's risky.
It saves weeks on the critical path, but if the deal falls through, the customer has to bear the termination costs from the vendors. Another high-risk scenario is when engineering has to design the prototype to fit tooling that manufacturing has already ordered just to maintain the schedule. In both of these cases, saving time comes at the explicit expense of increasing financial risk or locking in design risk.
The final methods involve focusing specifically on shortening the critical path activities themselves.
Right. You focus your effort on the longest activities on the path, the easiest activities to speed up, which are often the ones with poor initial estimates, or the activities that are the least costly to speed up. The trade-off here is always time saved versus the cost incurred to save that time.
Even with the best networks and control systems, plans fail. Our source material provides a sobering list of reasons why, and it emphasizes that the most catastrophic failures are usually behavioral, not technical.
The technical failures are easy to spot. The behavioral ones are insidious. The typical reasons plans fail include plans based on insufficient or inaccurate data, poor financial estimates, often driven by extreme optimism, not allowing enough time for proper estimating in the first place, people working toward different specifications because the WBS dictionary wasn't enforced.
So a failure of that foundational document we started with.
Exactly. Or simply lacking available personnel with the necessary skills. And the lack of a systematized planning process itself is cited as a major contributor. If the organization doesn't have a repeatable process, every project starts by reinventing the wheel.
The sources provide a brilliant and, frankly, harsh accountability check based on the type of failure. Who is at fault for what?
All right, let's run through that. If corporate goals and strategy aren't clearly understood at the lower levels, the executives are negligent. They fail to communicate the why. If financial estimates are erroneously calculated, miscalculating labor rates or material costs, the line manager is responsible. They are the technical domain expert.
And the PM.
If requirements are poorly defined, meaning the WBS dictionary is incomplete or vague, The project manager's totally at fault. They own the scope documentation. Finally, if plans fail because of extreme optimism, the classic "we can do it faster than anyone" attitude, both the project manager and the line managers share the responsibility for not honestly assessing and documenting the risk.
Sometimes, though, failure is just a simple forgotten detail, but one that creates a domino effect throughout the plan.
These simple forgotten details are shockingly common and destructive. Examples include forgetting to tell a line manager that a prototype isn't ready, which then ruins their carefully laid schedule for testing, or failing to reconfirm that a critical staff member will be available 6 months after they were initially requested, only to find they've been assigned to another project. These simple slips disrupt the network logic and cause major delays.
This leads us to the unfortunate reality of project termination. The source lists 9 specific reasons why projects have to be stopped. Beyond the good reason, the successful achievement of objectives, what are the core failure points?
They fall into a few categories: strategic, financial, and personnel. Strategically, you have poor initial planning or a sudden change in the market prognosis, a better alternative is found, or there's a major change in company interest or strategy. Financially, it's simpler: exceeding the allocated time or exceeding the budgeted costs.
And the people problems.
Personnel related. Key people leave the organization, or the problem is simply too complex for the available resources. And we have to acknowledge this: the personal whims of management are explicitly listed as a reason, a reminder that politics and personality can sometimes trump logic.
Wow, personal whims of management. That sounds terrifying. Does that really happen on major projects?
It does. A new executive comes in, wants to make their mark, and cancels their predecessor's pet project, regardless of its merits. It's a reality. And given that whole list, the sources stress that most reasons why projects fail on time and cost are behavioral rather than quantitative.
That's the critical takeaway for any manager, isn't it?
It really is. The behavioral causes cited are poor morale, poor human relations, poor labor productivity, and fundamentally a lack of commitment by those involved in the project. The sources suggest that this lack of commitment often appears to be the root cause of the first 3 issues. If people aren't bought in, productivity drops, and internal conflict just skyrockets.
If the project does need to stop, management has several termination methods at its disposal, some professional and some, well, highly destructive.
The goal should always be an orderly planned termination, where you treat the closure itself as a mini-project. But you also see these aggressive approaches, like the hatchet. This is the immediate, non-negotiable withdrawal of funds and removal of personnel, a move that just destroys morale and institutional memory.
What are the other ways?
Other methods include the immediate reassignment of people to higher priority tasks or a redirection of efforts toward different objectives. And then there's the least decisive option: burying it or letting it die on the vine. This means taking no official action, starving it of resources, and just letting it slowly wither into non-existence. This method saves face for management, but it's incredibly frustrating and demoralizing for the team that's assigned to the dying effort.
Regardless of the method, the final phase-out and transfer process is critical and frequently completely neglected. Project managers get so focused on achieving the scope, they just forget the exit plan.
Termination planning is vital. The sources define 3 core objectives of a proper closure. First, bringing the project to closure according to all the contractual requirements. Second, preparing for a smooth transition into the next operational phase, like from development to installation or maintenance. And third, conducting a thorough analysis of the overall project performance, financial, schedule, and technical success.
And that closure process must have its own structured checklist to avoid a last-minute disaster.
It needs intense rigor. Key items on that checklist include the formal transfer of responsibility to the maintenance or operations team, obtaining the official acceptance by the sponsor or the user, completing all project records and generating historic reports for future learning, conducting a comprehensive post-project analysis, your lessons learned.
And the logistics.
Yeah. Formally releasing resources and equipment, closing out all the work orders for the final financial closeout, and, most sensitively, managing the disposition and reassignment of materials and the project personnel.
And that leads us right to the behavioral component of closeout. Management's ability to handle the personnel issues during this phase often determines the overall perception of success or failure for everyone involved.
The behavioral tips are essential for preserving morale and institutional knowledge. Treat the closeout phase exactly like any other project, with clear tasks, a schedule, and a budget. Management has to secure top management support for the transition, and be acutely aware that conflict, fatigue, and shifting priorities just intensify during closure.
And the people.
And, crucially, they must deal professionally with rumors. The most effective action is keeping project personnel informed of upcoming job opportunities and dealing with potential reorganizations or layoffs in an open, honest, and professional manner. A bad closeout can poison the well for all future projects in the organization. #tag outro upro.
This has been an intensive deep dive spanning the full life cycle of project control. We started by establishing that the WBS dictionary is the ultimate source of truth, fighting scope creep by defining clear technical acceptance criteria.
We then detailed that necessary two-part selection process, rigorously distinguishing the initial technical feasibility, can we do it, from the quantitative benefit to cost analysis, should we do it, which relies on those critical metrics like NPV and IRR.
And we mastered time control, understanding how network scheduling tools like PERT with its probabilistic estimates and CPM with its deterministic approach reveal complex interdependencies that simple charts just can't show.
We also saw how essential it is to leverage slack time for resource optimization and the immediate need to address negative slack as that clear mathematical warning signal of impending schedule failure.
Ultimately, the sources consistently remind us that while the tools, the WBS, the MCCS, the networks, are technical marvels, the successes and the failures are almost always rooted in human and organizational issues.
Communication, commitment, integrity in estimating, and the willingness of executives to accept technical reality. It all comes down to the people.
Here's a final provocative thought for you to chew on. Our sources dedicated significant discussion to the high risk involved in accelerating schedules or crashing. They often cited scenarios where time is saved by increasing financial or design risk, like using parallelization by ordering tooling before the design is finalized or pushing an aggressive procurement. If you had to choose one, saving time or guaranteeing absolute adherence to the original scope, which trade-off would be non-negotiable for your next critical effort, and what does that choice tell you fundamentally about your organization's true risk tolerance?
Until next time, keep digging into the details. Welcome back to The Deep Dive, where we take the world's most complex material and distill it into immediately useful, actionable knowledge. Today, we are taking on, well, the monumental task of project mastery, a discipline that sits squarely between advanced mathematics and organizational psychology.
That's absolutely right. Our mission today is to give you a deep, thorough understanding of advanced project control. We're moving beyond the simple, list of tasks and delving into the rigorous methodologies like PERT and CPM that allow project managers to not only predict the future, but to quantify the risks inherent in that prediction.
We had a substantial stack of source material for this dive, focused on established, time-tested project control techniques used in engineering, R&D, and complex construction. For you, the learner, this is your shortcut to mastering the language of quantitative project management and, crucially, understanding why the human element, managing a fearful executive or coordinating dozens of conflicting stakeholders, is often the final, most intractable constraint.
Exactly. We've framed this discussion to move you quickly but thoroughly through the necessary rigor. We will start with the numbers, understanding how you predict time when data is scarce. Then we'll build the network framework, analyze the cost of compression, and conclude with the critical insight that organizational politics and human indecision can completely undermine even the most perfect mathematical schedule.
Okay, let's unpack this, starting exactly where the rigor begins. The moment a project manager has to predict time for a task that has, well, never been done before,
Right.
How do you anchor an estimate when you have no history to rely on?
Right.
So if we were in a repetitive production environment, historical data would be our guide. We'd know with high statistical certainty that drilling 10,000 holes takes, exactly 4.2 hours.
Mm-hmm.
But the projects we're discussing, the cutting-edge R&D, the first-of-its-kind engineering endeavors, are inherently non-repetitive. You can't just look up the duration of inventing a new widget.
And this is where we must rely on the expertise of the functional manager. The person who actually performs or supervises that type of work. We can't ask them for a single firm commitment because that commits them to an unquantified risk. It's not fair to them.
So what do we do instead?
Instead, we ask for 3 estimates, forcing them to consider the entire spectrum of possibilities, which becomes the foundation of our risk model.
Okay, so the first estimate they provide is the optimistic time, designated as the letter A. This represents the absolute minimum time required if absolutely everything goes perfectly. No material delays, perfect resource availability, maximum efficiency.
And it's crucial to understand the source material notes this is considered an extremely low probability event,
Yeah.
maybe occurring only 1% of the time.
It's the perfect scenario, the blue sky day.
Exactly. Then, on the opposite end of that spectrum, we ask for the pessimistic time, which we call B. This is the maximum time required if maximum difficulties develop. If major scope changes happen late, key resources quit, or core technical issues arise that require significant rework.
So the absolute worst case scenario.
Right. Like the optimistic time, this is also anchored at the statistical extreme, a 1% likelihood event. These two numbers, A and B, establish the boundary conditions of our universe of possibilities.
And in the middle, providing the necessary practical anchoring, is M, the most likely time. This is what the functional manager predicts would occur most often if the activity were to be repeated over and over again under normal operating conditions, accounting for typical interruptions and resource availability.
It represents their best professional judgment of the mode of the distribution. It's their gut feeling, backed by experience.
Okay, so we have A, B, and M, three numbers. How do we get to 1?
Now, to transform these three subjective numbers into a single usable expected time, we call it 2, we must introduce two essential assumptions rooted in probability theory. The first is that the time distribution for this single activity follows a beta distribution.
Wait, why the beta distribution specifically? Why not a standard normal bell curve? That seems more familiar.
That's a great question, and it speaks to the practicality of project estimation. The beta distribution is preferred here because it's naturally bounded. I mean, it cannot assign a probability to a negative duration, which is impossible in real life.
Okay, that makes sense.
More importantly, it can be skewed. Our functional manager might believe the most likely time is much closer to the pessimistic time, B, if they're worried about technical complexity, or much closer to the optimistic time, A, if they're feeling highly confident. The beta distribution lets us model that skew accurately.
Got it. So what's the second assumption?
The second assumption is what allows us to quantify the risk. We assume the standard deviation, or sigma, is 1/6 of the total time requirement range, which is B minus A.
Why 1/6? That seems very specific.
It comes from the statistical rule that the endpoints of a probability curve are typically located 3 standard deviations from the mean. Therefore, the total range, B minus A, represents 6 standard deviations. It's a well-established statistical shortcut.
Okay, so these two assumptions let us build a formula.
Exactly. They combine to give us the powerful expected time formula, T equals A plus 4 meters plus B, 6x.
And notice the critical weighting here. The most likely time is weighted 4 times heavier than the optimistic and pessimistic extremes.
Right, which is a mathematical nod to the expertise of the functional manager regarding the typical outcome. We trust their most likely prediction the most.
Let's illustrate this with the source material's numerical example. Let's say a functional manager tells us, optimistic time is 3 weeks, pessimistic time is 7 weeks, and most likely time is 5 weeks.
Okay, so plugging those in, you get 3 plus 4 times 5 plus 7, 6. That is 3 plus 20 plus 7, 6, which results in 36.
So the expected time, our $2, is exactly 5 weeks.
Yep, and that's the duration the project manager will initially place into the scheduling network.
But here's a crucial deep dive moment where this simple math reveals hidden risk. The $2 alone can be dangerously deceptive. Let's look at a contrasting set of estimates. A is 2, B is 12, and M is 4 weeks.
Okay, so if you calculate that second set, you get 2 plus 4 times 4 plus 12, 6. That's 2 plus 16 plus 12, 6, which is again 36.
The expected time, $2, is still 5 weeks. A quick glance PM sees 5 weeks and just moves on.
But the reality is radically different. In the first case, the range was just 4 weeks, right? 7 minus 3.
Right.
In the second, the range is 10 weeks, 12 minus 2.
Yeah.
The wider 10-week spread indicates a significantly higher degree of uncertainty, reflecting greater complexity or unknown technical challenges.
So the spread of the estimates, not just the expected average, is the true measurement of risk.
Yeah.
Hashtag 1.2 quantifying project risk with standard deviation.
And that leads us directly to the quantitative measure of this uncertainty, the standard deviation for the activity. This is calculated by simply taking that range and dividing it by 6. So sigma t, 6s7. This number provides a tangible mathematical measure of the inherent risk in that single task.
So for our first example, with a range of 4 weeks, the standard deviation is 4 divided by 6, or about 0.67 weeks. For the second, much riskier example, with a 10-week range, the standard deviation is 10 divided by 6, or about 1.67 weeks.
Right.
That difference of a full week in standard deviation is the hard evidence that the second activity is 2.5 times riskier than the first, even though both have the same predicted duration.
Exactly. Now, we calculate the variance, which is just sigma squared, for each activity because, and this is a key statistical principle, variances are additive.
Meaning you can't just add up the standard deviations.
No, you can't. That would overestimate the risk. So to calculate the total path standard deviation, which we call sigma path, we have to sum the variances along the critical path and then take the square root of that sum.
So the formula is sigma total plus sigma total. This is how we mathematically aggregate the individual independent risks of many sequential activities into one usable number for the entire project timeline.
And the real power of calculating sigma total comes from our ability to apply the principles of the normal distribution. We assume that the total project duration, which is the sum of many independent activities, tends toward a normal distribution, regardless of the individual activity distributions. It's a concept called the central limit theorem.
This assumption allows us to establish confidence intervals. You know from statistics that for a normal distribution, there's a 68% chance of completion within one standard deviation of the mean, 95% within two, and 99.73% within three. This is how we move from a single estimated date to a statistically grounded risk profile.
Let's use the source materials example to make this practical for you. Suppose our critical path lengths, the mean expected time, is 15 months. And after all those calculations, the total path standard deviation sigma path comes out to a manageable 1 week.
Okay, so the client asks, what is the probability we finish within 16 weeks? This is a key question in a project governance meeting.
Well, 16 weeks is exactly one standard deviation above the mean, right? 15 plus 1. Since the normal curve is symmetrical, we know we have a 50% chance of finishing at or before the mean.
Right, half the curve.
So we add half of that 68% range, which is 34%, to that 50%. We can confidently tell the client there's an 84% chance of completing the project within 16 weeks.
This changes the entire dynamic of the conversation. Instead of guaranteeing 16 weeks, which is statistically impossible, you communicate certainty. Conversely, what if the client pressures the team, asking for a completion date of 13 weeks?
Well, that's 2 standard deviations below the mean, 15 minus 2.
A big ask.
A huge ask. We take the 50% chance of finishing at the mean and subtract half of the 95% range, which is 47.5%. That leaves only a 2.5% chance of completion within 13 weeks.
So the PM now has the quantitative data to demonstrate that attempting to hit 13 weeks is a high-stakes gamble with overwhelming odds of failure. This, fundamentally, is how smart project managers move the conversation away from emotional promises and anchor it in statistical fact. The standard deviation derived from those 3 initial estimates is the measurement of risk for the entire project, and it is the single most powerful tool in your analytical toolkit.
Now that we have the rigorous input data, the activity duration, our $, and the risk measurement, our sigma, we need a structure to organize it all.
And this is where network diagrams using either PEAT or CPM come in. While their outputs often look similar today, they were born from very different historical needs.
Very different. Historically, the core distinction lies in their application environment and, critically, their approach to tracking cost and progress, specifically the ability to calculate a physical percent complete.
Okay, let's start with PEAT.
PERT, the Program Evaluation and Review Technique, was developed in the late 1950s for the U.S. Navy's Polaris missile program. This was pure R&D, pure development work.
Right, so how do you measure percent complete on writing software or developing a new rocket fuel?
You can't, really. It's almost impossible to physically measure progress.
So because physical measurement is difficult, PERT is primarily event-oriented.
That's right. It focuses on the milestones, or events, that signal the completion of a major phase of work. The source material notes that funding in a PERT environment often hinges on achieving those specific events, rather than the effort expenditure between them.
Okay, so PERT is for events. What about CPM?
CPM, the critical path method, was developed around the same time for the DuPont Corporation. This was used in process industries, construction, and plant shutdowns environments where progress can be physically and accurately measured.
So you can measure the cubic yards of concrete poured or the number of components manufactured.
Precisely. Therefore, CPM is activity-oriented, focusing on the duration and cost associated with the work itself.
Although modern software often combines the best elements of both. For you, the learner, understanding this origin is key. If you are managing pure, non-measurable knowledge work, you are thinking in PERT milestone achievement. If you are building physical infrastructure, you're leveraging CPM, the cost and duration of the activity. But regardless of which we use, both employ the same basic network structure for defining precedence. Hashtag tag tag 2.2, the 6-step PRT-CPM planning methodology. Creating a robust, realistic schedule is not a single action. It's a formal, iterative 6-step process that moves from abstract possibility to concrete commitment.
Step 1 and 2 are the foundation. The project manager meticulously identifies all the necessary activities, being careful not to create so many that tracking becomes impossible, nor so few that critical work is hidden.
And then they put them in order.
Yep. Then they establish the necessary order of precedence, crafting the initial logic charts or networks.
Step 3 is the organizational handshake. The project manager must take these initial diagrams and review them rigorously with the line managers, the people who command the resources and possess the technical know-how.
This is the vetting phase. You're ensuring that the defined activity scope and their interrelationships are technically sound and organizationally practical. You can't do this in a vacuum.
Step 4 is where the numerical inputs come in. Functional managers submit the duration estimates, like the $T we discussed, for each activity.
Right. And here's the critical initial condition. These estimates are based on the assumption of unlimited resources.
So they're asked, how long would this take if you had all the necessary people and equipment dedicated to it?
Exactly. Calendar dates are explicitly ignored at this point.
Why ignore resource limits initially? It feels a little unrealistic.
Because the estimate needs to be a pure reflection of the technical work required. If you factor in known resource constraints too early, you end up conflating duration with resource availability, and that's just muddying the waters. We need to establish the technical reality first.
Okay, that makes sense. So step 5 is the first check of reality. The project manager calculates the initial critical path duration and checks it against the required contract or calendar date.
And if the critical path is too long, immediate action is required. They must find ways to shorten the path, either by formal compression techniques like crashing, which we'll get to, or by challenging the line managers to move any fat or hidden contingencies embedded in their initial estimates.
And now the final step, step 6, which you said is the most crucial organizational turning point.
It is. This is where the project manager places calendar dates on each event and activity. This converts the abstract unlimited resource plan established in step 4 into a tangible, limited resource reality.
This is the moment of commitment.
It's everything. This step is fundamental because the time estimate derived in step 4 is useless if the functional manager cannot commit to having their resources available on the specific calendar date required by the schedule.
So if a line manager says, I see activity X needs to start on June 1st, but my specialist team is tied up on another high-priority job until June 15th.
The plan immediately breaks. Replanning is necessary at that moment. This is why many organizations require a detailed project plan long after the contract is signed. The transition from theoretical feasibility, that unlimited resources fantasy, to organizational commitment takes time and a lot of negotiation.
And this leads to the necessity of ongoing replanning. The successful project manager recognizes that constraints and objectives are constantly changing during execution.
Constantly. They must continually assess new risks, perform perturbation analysis, the what if this delay happens scenarios, and refine their estimates, focusing not just on the core objectives of time, cost, and risk, but also on resource efficiency and continuous improvement of the estimating process itself.
So when step 5 shows the critical path is too long and simply removing contingency time isn't enough, we must formally compress the schedule.
And the primary technique for this, tied strongly to the CPM methodology, is crashing. Right. Crashing means accelerating selected activities by adding resources, using overtime, or paying premiums, but doing so systematically based on cost. To make this decision, the project manager must calculate a precise crashing cost per unit time for every activity in the network.
There are rules for this, right? You can't just throw money at everything.
Exactly. We must adhere to 4 strict rules when engaging in crashing. Otherwise, we're just, throwing money at the problem without gaining time.
Rule 1. The analysis must emphasize activities, not events. You could only crash activities that have measurable cost and duration implications. A key reason this is linked to the activity-oriented CPM structure.
Rule 2. Both the time and the cost of each activity must be considered. Crashing is an economic optimization exercise. You must know the point at which the cost of acceleration outweighs the benefit of earlier completion.
Rule 3. This one seems non-negotiable. You only consider crashing activities that currently lie on the critical path.
Absolutely non-negotiable. Crashing an activity that has 10 days of slack simply increases your project cost by the crashing fee and still leaves you finishing 10 days later than the earliest possible completion.
You're just burning cash.
Just burning cash. And rule 4, start with the activities that have the lowest crashing cost per unit time. You want the maximum time reduction for the minimum increase in direct cost. You crash the most cost-effective critical activity first.
I can imagine a common mistake here. A PM finds activity C, which costs $1,000 per day to crash, and activity A, which costs $2,000 per day to crash. The PM immediately crashes C because it's cheaper.
That's a classic error if they haven't followed Rule 3. If activity C has slack, that $1,000 is wasted. If activity A is the only one on the critical path, you must crash A, swallowing the higher cost because it's the only way to reduce the project duration.
And here is the critical caveat that often derails novice project managers. When you successfully crash an activity, you shorten its duration, potentially shortening the critical path itself. This may, and often does, create a new critical path elsewhere in the network.
Exactly. If you crash activity A by 3 days, suddenly the path through BCD might become equal in duration to the path through AEF. Both are now critical.
So you have to stop and reassess everything.
You must reevaluate the entire network after every incremental crash before deciding on the next activity to accelerate. If both paths are now critical, you must crash an activity that is common to both paths, or crash one activity on each path simultaneously, ensuring you select the least overall cost combination.
The ultimate goal is visualizing the time-cost trade-off. We discussed the total cost curve, which is the sum of direct costs and indirect costs.
Right. As you crash, your direct costs soar due to overtime pay, expedited shipping, or specialist consultant fees, but your indirect costs, things like overhead, facility rental, and contractual delay penalties decline because the project finishes sooner.
So you're trying to find the sweet spot.
The optimal duration is the point where the total cost curve is at its minimum, balancing high direct costs against shrinking indirect costs. Crashing beyond that point is financially irrational. Hashtag tag 3.2. The myths and realities of schedule compression.
We've established the mathematical rules for crashing, but now we must introduce the sobering reality check provided by the source material. Managers are often aggressively positive, assuming that these compression techniques work in a vacuum, ignoring the human and organizational friction they create.
We need to dispel the myth that accompany the most common compression strategies, because failing to do so leads directly to budget overruns and quality failures.
Let's start with the most common method, using prolonged overtime. The myth is simple. 10 hours of work gets done, even if they are overtime hours. A person hour is a person hour.
The reality, backed by operational data, is that the rate of progress is significantly lower during overtime hours, especially if prolonged. Crucially, the rate of mistakes increases exponentially.
And people get tired.
They get burned out. If overtime extends beyond a few weeks, burnout sets in, undermining the efficiency and morale of the entire team, leading to a net loss in productivity and massive quality risk.
Okay, next tactic. Adding resources, the primary form of crashing. The myth is that performance rate increases instantly and proportionally. If 5 people build the wall in 5 days, 10 people build it in 2.5.
The reality is that adding resources, especially complex, skilled resources, invokes the steep learning curve. It takes time, often weeks or months, to find, hire, and train new staff.
And who trains them?
The existing productive staff, whose performance must be temporarily diverted and reduced to onboard the newcomers. You must take a guaranteed hit in the short term to get any benefit later. It's the mythical man-month.
What about reducing scope? The myth there is, the customer always asks for more than they truly need. We can just shave off non-essential tasks and meet the deadline.
The reality, particularly in well-defined projects, is that the customer needs all tasks agreed to in the statement of work. Arbitrarily reducing scope without formal approved change control results in an incomplete or unsatisfactory deliverable.
So you might hit the schedule date, but you will fail the project acceptance criteria.
Exactly. You win the battle, but lose the war.
And finally, the fast-tracking technique of performing series work in parallel. The myth is that starting activity B before activity A is 100% finished is efficient and easy.
The reality is that this dramatically elevates risk. If activity A is only 80% finished and you start activity B and then discover that the first 20% of activity A needs major rework,
Oh, that's a nightmare.
it's a disaster. That rework now involves activity B and potentially C, D, and E if they were also started in parallel. This often leads to extremely expensive, complex rework that involves multiple resources and multiple task budgets, often costing far more time and money than if you had simply waited.
We've established the mathematical baseline and structured the network. Now we confront the truth that the most perfectly calculated schedule is only as strong as the organizational commitment behind it. This is where the physics of scheduling meets the psychology of management. Hashtag tag 4.1, the invisible sponsor case study.
And the source material provides a deeply insightful example of organizational conflict and political fear becoming the single greatest project constraint. The case of Fred Cutler, the PM, and Al Zink, the new VP and sponsor at Moreland Company.
Okay, so Fred Cutler was an experienced PM, but Al Zink had zero experience as a project sponsor.
Right. And Al realized very quickly that in this organization, the sponsor was the person the president expected to assume the ultimate accountability for success or failure.
So his neck was on the line.
Completely. Al Zink's reaction was one of pure career preservation. He recognized that this high-risk project could either make his career or damage his reputation. Because of this fear of accountability, Al decided to become the invisible sponsor.
What does that mean, an invisible sponsor?
He was avoiding critical decisions and hoping to distance himself from the project's potential failure. If he never made a decision, he couldn't be blamed for a bad one.
And this indecisiveness immediately stalled Fred's ability to finalize the schedule. Fred presented Al with the core strategic decision every sponsor must make. I cannot finish the schedule until you tell me whether you want me to lay out the schedule based upon best time, least cost, or least risk.
And that choice is fundamental. If Al chooses least time, Fred has to use crashing and take high schedule risks. If Al chooses least cost, the schedule will likely be longer and resource use will be level. If Al chooses least risk, Fred might build in large contingency buffers and communicate high probability dates.
And Al's refusal to choose prevented Fred from moving past step 5 and starting the critical step 6 of calendar dating.
Time was just being wasted, simply by indecision.
So Fred recognized that appealing to logic wouldn't work. Al continued to procrastinate, asking for the schedule without providing the necessary strategic guidance. Fred realized he had to apply organizational pressure to force the decision.
Fred's escalation tactic was masterful, but, highly risky. He sent the finalized, least time schedule to Al, demanding a signature. When Al hesitated, Fred followed up with an email containing the explicit threat. If the schedule is not signed by this Friday, there will be an impact on the end date of the project.
But the real weapon was the communication channel. Fred included the president's email address in the CC location of that email.
Ooh, a bold move.
A very bold move. This immediate organizational pressure exposed Al Zink's inaction to his ultimate boss. The source material notes the result. Al signed the document immediately the next morning, forced to own the least time risk profile.
The lesson for you, the learner here, is profound. Project success depends on the sponsor owning the risk profile. The PM must assume total accountability for execution, but the sponsor assumes ultimate accountability for the strategic objective.
And Fred's action, while potentially damaging the relationship, was necessary to overcome that organizational paralysis and finally move the project from the theoretical planning phase into committed execution. Hashtag 4.2, managing expectations in the project environment. The invisible sponsor case highlights that a PM must manage expectations across the entire organization, often in conflicting directions. Misaligned expectations are precursors to political infighting.
Let's start with top management expectations of the PM. They demand total accountability for success, for failure, for resource use. They expect effective reports that summarize complex information concisely.
And they want problems solved before they get to their desk.
Exactly. Crucially, they expect the PM to possess the capacity to handle most interpersonal problems and conflicts within the team or between functional groups without needing top management intervention.
In return, the PM has clear expectations of top management. They need clearly defined decision channels so they know exactly who to go to when a decision is required, unlike the Al Zink scenario.
They need swift action on requests, assistance in conflict resolution that is beyond the PM's scope, and perhaps the most important political shield: protection from political infighting between departments.
And finally, we must address team member needs, which are vital for retention and motivation. Team members need interest in the work, a sense of belonging to the project mission.
And job security, especially in matrix organizations where assignments are temporary. And they, too, need protection from the political infighting that often permeates large, high-stakes projects. Hashtag tag tag 4.3 stakeholder identification and analysis.
While the sponsor is key, large projects interface with a dizzying multitude of stakeholders, often geographically dispersed across different cultural norms and spanning various authority levels. Rigorous stakeholder relations management is mandatory.
Identification must go beyond just organizational charts. The source material outlines several ways stakeholders can be grouped. We can identify them as formal groups, financial institutions, creditors, or regulatory agencies.
Those individuals.
Right, specific individuals, the CEO, the CIO, or key contact persons in supplier firms.
We can also categorize them by their specific contribution. Those who provide financial backing, those who supply human resources, or those who provide critical technology. And finally, by authority, their power to mandate decisions or veto outcomes.
The complexity explodes because these stakeholders rarely share the same metric for success. They inevitably have dramatically conflicting definitions of success.
Can you give us a concrete example of that conflict?
Sure. Consider a new manufacturing plant build. The finance team defines success strictly in terms of financial performance, completing the project 10% under budget, regardless of how long it takes.
Okay, pure cost focus.
The marketing team defines success as the early, feature-rich launch of the first product line enabled by the new plant, driven by maximizing immediate market share. They want it fast.
And what about engineering?
The engineering team defines success as maximizing the long-term reliability and robustness of the equipment, even if that means adding 3 months to the schedule for quality assurance. They want it perfect.
So the PM must report performance against 3 different, often mutually exclusive definitions of success.
All at the same time, and compounding this is the insidious nature of hidden agendas. Not every stakeholder wants the project to succeed. They may fear that project completion diminishes their power or makes their existing department redundant.
Telltale signs of a hidden adversary are subtle but deadly.
Oh, yeah. A silent opponent may refuse to approve necessary scope changes promptly, or they may continually assign marginally qualified resources, hoping to delay implementation.
And their ultimate goal.
Their ultimate goal is often to undermine the project just enough so that when it fails or struggles, they can publicly state, "I told you so." Vigilance against these unseen political constraints is a permanent necessity for the PM. Hashtag check 4.4, the power interest grid. Since catering equally to everyone is impossible, the PM needs a tool for prioritization. The power interest grid maps stakeholders based on their power to influence outcomes and their level of interest in the project.
This matrix yields 4 distinct quadrants, each requiring a tailored engagement strategy. Let's start with the most critical quadrant, the top right. Manage closely. High power, high interest.
These are your essential partners, including the CEO, the sponsor when properly engaged, or critical regulatory bodies. They can kill the project with a single decision. The PM must put forth the greatest effort to satisfy them, engaging them continuously and providing detailed, relevant information tailored specifically to their interests.
Next, the top left. Keep satisfied. High power, low interest. These are powerful executives who are generally passive observers. They don't care about the daily mechanics, but if they become unhappy, they can still exert immense influence.
You must put effort into satisfying their core needs, perhaps through brief, high-level summaries. Critically, you must avoid excessive detail that leads to boredom.
Why is that so important?
If a high-power, low-interest stakeholder suddenly realizes they have nothing useful to say in a 2-hour weekly meeting, they might exert their power by canceling the meeting or demanding a major change just to alleviate their boredom. You don't want to poke that bear.
Got it. Moving to the bottom right, keep informed. Low power, high interest. These stakeholders, like end users, subject matter experts, or junior functional managers, lack the formal authority to shut down the project, but they care deeply about the outcome.
These individuals function as an invaluable early warning system. They're often technically astute and the first to spot emerging problems or hidden opportunities. Keeping them informed, perhaps via detailed technical reports, makes them feel valued and provides the PM with crucial advance intelligence before minor issues become critical path delays.
And finally, the bottom left. Monitor only. Low power, low interest. They neither care much, nor can they change much.
For these groups, you provide minimal structured information, just enough to ensure they are not blindsided if a major disaster occurs. Spending excessive communication effort here is a waste of scarce PM resources. Hashtag 4.5 stakeholder engagement and communication failures. The ultimate goal of engagement is to understand needs, value opinions, and build trust. This process determines whether a stakeholder will be a proactive advocate or a passive opponent.
Successful stakeholder relations management fundamentally requires tailoring performance reports. We mentioned conflicting definitions of success. The difficulty arises because it is nearly impossible to get all key stakeholders to agree on a uniform set of reports or KPIs, key performance indicators.
Absolutely. One stakeholder demands earned value metrics, another requires cash flow projections, and a third only cares about environmental impact metrics.
So successful management therefore necessitates multiple reporting streams.
It does. The PM must tailor performance reports to each key stakeholder's specific interests. This requires significant administrative overhead, but it is necessary to maintain political support across the organization.
Despite all this rigorous planning, stakeholder management still frequently fails. The source material outlines common pitfalls, many of which relate to timing and perceived value.
The two primary timing failures are inviting stakeholders to participate too early in the process, which often encourages extensive, unmanageable scope creep.
Or inviting them too late.
Exactly. Too late means their views cannot be incorporated without immense, costly schedule delays.
Other failures center on motivation, allowing key stakeholders to believe their contributions are meaningless, leading to disinterest, or the key stakeholders becoming impatient with a perceived lack of progress.
You have to keep them engaged. The PM must constantly reinforce the value and visibility of stakeholder input to maintain their organizational commitment. In a world of hundreds of tasks, complex precedents, and resource conflicts, project management software is indispensable.
But, and this is a huge but, it is paramount to remember that software is strictly an aid. It is not a substitute for competent project leadership, and it cannot identify task-related problems that a human didn't input.
That's the key. Garbage in, garbage out.
Software's core power lies in tracking variables and monitoring outcomes. Key capabilities include instantaneous critical path analysis, multi-project tracking, and significantly impact analysis, the famous what-if scenarios, and sophisticated resource leveling across many competing projects.
For you, the learner, the features that truly deliver value include the ability to easily generate menu-driven reports like complex earned value analysis, cash flow projections, and resource utilization charts. Advanced software also supports multiple calendars, accounting for global holidays, shift work, and weekends, ensuring calendar dates, our step 6, are accurate.
The power of the what-if analysis cannot be overstated, especially when dealing with those invisible sponsor scenarios.
Oh, absolutely. Software allows the PM to establish a separate, duplicated project database, run the impact of a 3-month delay on a single activity, and immediately produce a comparative analysis showing the new critical path and cost implications versus the baseline plan.
This speeds up management review and decision-making dramatically. #tag 5.2 Precedence Networks and Relationships.
While we based our initial discussion on traditional PE or ECPM arrow diagrams, modern software often uses precedence networks, also known as activity-on-node diagrams.
AON.
Right, AON. This approach places the activity on the node, the box, rather than the arrow. In traditional peer, all constraints were assumed to be finished to start. AON allows for much richer, more complex constraints.
That simple finish-to-start constraint activity B starts after activity A finishes is often too rigid for real-world projects, particularly in manufacturing or concurrent engineering.
It really is. Precedence networks allow us to define advanced logical relationships. For example, a start-to-start or SS constraint. Activity 2 cannot start before activity 1 starts.
Like a practical example of that.
A practical example would be the final coding process, activity 2, cannot start until the surface preparation process, activity 1, has begun. They must overlap, but one drives the other.
Another key constraint is the finish-to-finish, or FF relationship. Activity 2 cannot finish until activity 1 finishes.
For example, the final installation of a complex piping system, activity 2, cannot be declared finished until the final pressure testing, activity 1, is completed. They must conclude together.
And critically, precedence networks can handle percent-complete constraints.
Yes. You can specify that activity 2 can start after activity 1 is 50% complete. This fast-tracking capability is nearly impossible to model accurately on traditional PERT charts without artificially splitting activities, which introduces unnecessary complexity.
Within these precedence relationships, we need to finalize our understanding of the tactical difference between lag and lead.
Lag is a time period between activities, often dictated by physical necessity or resource unavailability. For instance, activity B must lag 6 days after activity A, finish a start relationship with a 6-day lag, or FS6.
This is often the time required for concrete to cure or for a regulatory inspection.
Exactly. Lag increases the total project duration.
Lead, conversely, is a negative lag. This occurs when a subsequent activity, B, is scheduled to start prior to the completion of its predecessor, A. This is generally not dictated by logic, but by the tactical needs of the PM.
Recall the example we covered. Activity A finishes on March 15th, and B should logically start on the 16th. But the line manager for B tells the PM, "My high-demand resources are available on March 8th. If you don't secure them now, they'll be assigned elsewhere and unavailable until April."
Faced with the high-stakes certainty of resource loss versus the high-risk gamble of starting early, most project managers choose the latter.
They have to. They immediately place the resources on the job on March 8th, creating a 7-day lead or a negative lag. This tactical trade-off involves sacrificing perfect adherence to logical constraints for the high certainty of securing scarce, critical resources.
So it's a calculated move that trades high schedule risk for high resource assurance.
That's a perfect summary. #tag outro.
We have completed a comprehensive journey through project mastery. We began with the mathematical rigor of the 3-point estimation, recognizing that the standard deviation, sigma, is the true measurement of risk, allowing us to communicate completion probability using confidence ranges.
We then built the network framework, distinguishing the milestone focus of PEERT from the activity focus of CPM, and detailed the crucial organizational transition in the 6 steps, that moment in step 6 where the fantasy of unlimited resources collides with the reality of limited calendar dates. We saw how schedule compression relies on strict, cost-based rules, and how those rules are constantly undermined by the operational realities of burnout and rework detailed in the myths versus reality table.
Finally, we faced the messy reality of the human project. The invisible sponsor case showed us that political fear and organizational indecision can freeze a project manager, forcing them to use organizational pressure, such as CCing the president to break the deadlock. Mastery, ultimately, requires balancing the physics of time and cost calculations with the psychology of managing wildly conflicting definitions of success and anticipating hidden political agendas through systematic stakeholder analysis.
The ability to navigate this tension between quantitative certainty and human unpredictability is the hallmark of project mastery. And that brings us to our final provocative thought for you. The entire foundational planning process of PERT and CPM begins with that initial necessary fantasy of unlimited resources before forcing the confrontation with reality in step 6. We must ask ourselves, how much of our initial enthusiasm and optimism in any new endeavor, a complex project, a major career shift, a relationship, is intrinsically based on that early fantasy of unlimited resources? And how quickly and honestly do we confront the reality of constraints to ensure long-term committed success?
Something critical to ponder as you tackle your next big challenge. We hope this deep dive has given you the necessary tools to face that reality head-on. Thanks for joining us.
Welcome back to the deep dive. So if you've ever worked on a really significant, complex project, launching a new defense system, building a new platform, even just a major software rollout, you've probably seen the story play out.
Oh, absolutely.
We see the headlines every single week. Exactly. We focused on the budget and the calendar because those were the variables that felt stable. Technology forecasting was, well, it was often an afterthought. Just simple extrapolation. If it did this last year, it'll do a little more next year.
And that assumption of stability, it works, for a project that lasts 6 months.
Sure.
But our sources really hammer this point home.
Mm.
Once you push past that 1-year mark, you're not in a stable environment anymore. You're in a radically unstable one. Computer tech performance doubles about every 2 years.
And engineering tech.
Slower, but still incredibly fast, about every 3 years.
So if your project runs for 3 years, the system architecture you started with could literally be obsolete before you even deliver.
Which means you need sophisticated, integrated risk management from day one. There's no other way.
You have to. So our mission today is to move past the simple idea of just living with risk. We are deep diving into the modern tool set, the rigorous systematic methods used to analyze uncertainty, to integrate technical cost and schedule risks, and to use formal decision-making criteria in every condition, from certainty to total uncertainty.
We're really decoding the process that transforms that chaotic, reactive environment,
Right, the firefighting,
into a continuous, disciplined, proactive system.
Okay, so let's start at the beginning. Let's unpack the root causes of failure first. The inherent challenge, as you said, is that balancing act. Cost, technical performance, and schedule.
Especially on long projects.
Right, where you just can't assume stability. The source material lays out 5 critical causes of this cost growth and schedule slippage that are squarely within the control of the key stakeholders.
And that's the key point. These aren't acts of God. They aren't bad luck. They show that project failure is often baked in from the start. It's a flawed foundation or, poor organizational behavior. They are planning failures that systematically create risk that you can't avoid later.
So let's take the first one. Starting a project with an inadequate budget or schedule for what you want to achieve technically. Or, and I think this is crucial, for the integration complexity.
That is the textbook definition of under-resourcing or, over-promising.
Right.
If the technical leap you want requires, say, 5 years and $1 billion, but the stakeholders force it into a 3-year, $500 million box, you are mathematically starting in a crisis.
You're already behind.
You are. The only result is that you have to mortgage something down the line. It's either going to be the schedule or the technical performance. Something has to give.
And that inadequate starting point, it often connects directly to the second cause, which is kicking off the project before you've done your homework.
Before adequate requirements flow down, verification or resource commitment has occurred.
Yeah.
Think about the requirements flow down. If you haven't clearly defined how the top-level goals translate to verifiable metrics at the subsystem level.
If you haven't done the systems engineering.
You haven't done the work. You are starting development knowing you're going to have massive rework later. It's guaranteed. And without committed resources, any little shock, like a supply chain hiccup, can just stop the whole project cold.
You're building a skyscraper without locking down the foundation.
A perfect analogy.
The third cause, this one really speaks to organizational culture. Having a development process that just favors one variable over the others. For example, chasing technical performance above all else.
Oh, you see this all the time. If the project team knows that the only thing they'll be rewarded for is achieving that gold standard technical spec,
some say best performance,
they will sacrifice schedule and budget every single time. And look, sometimes that technical superiority is non-negotiable.
Of course.
But if that trade-off isn't made transparently, if it isn't systematically managed, it becomes this rogue driver that leads to just uncontrolled cost escalation, all in the name of technical purity.
Which leads right into the fourth point, which is about technical ambition. It's establishing a design that's right at the edge of what's feasible.
The feasible limit of achievable technical performance at that point in time.
Right.
This is the difference between iteration and invention. If you are trying to push the boundaries of physics or material science in the middle of a project, you are inherently accepting a massive spike in technical risk.
You're not managing a project anymore.
No, you're managing R&D uncertainty, which is a totally different ballgame. The probability of hitting some unforeseen scientific roadblock just skyrockets. It needs a completely different risk profile and, frankly, a much bigger reserve budget.
And the fifth cause brings us full circle right back to why we're doing this deep dive. It's making major design decisions before you actually understand the relationships between cost, tech performance, schedule, and risk.
It's flying blind at the most critical moments. You commit to some complex custom component early on without fully understanding the cost risk, the integration risk, the schedule risk.
And you've just closed the door on all your safer, cheaper options?
Exactly. You've foreclosed them before you even had the data to make an informed choice. So these 5 causes, impossible goals, fuzzy requirements, a biased process, technical overreach, and poor decision analysis, they are the direct precursors to high project uncertainty.
So the big realization, starting back in the mid-'80s, was that you couldn't just keep these risks in their own silos.
Right. You couldn't have the engineers just worry about the tech and the accountants just worry about the budget.
It's all connected.
It's all one system. The uncertainty in forecasting a new technology directly contributes to technical risk, cost risk, A&D schedule risk, all at the same time. And that recognition forced a huge philosophical shift.
Away from just reacting.
Away from reactive problem solving or crisis management, and toward a continuous, disciplined, proactive process where risk management is a conscious input to every single major decision.
It's the difference between trying to fix a faulty engine while you're flying the plane
and performing rigorous pre-flight checks and having contingency plans for every known point of failure.
Okay, so to manage all this proactively, we have to start with clear definitions. If we can't agree on what we're even talking about, we can't manage it.
Right.
The sources establish this really core conceptual definition of risk. Risk is a measure of the probability and consequence of not achieving a defined project goal.
And that definition is so precise because it has two primary components that you have to consider together.
Okay.
The probability of occurrence, let's call it P, and the impact or consequence if it happens, C. That's the amount at stake. So mathematically, risk is just a function of P and C.
So it's not enough to say something is unlikely. You have to also measure how devastating it would be if that unlikely thing actually happens.
Precisely. The classic illustration is, goal A might have a very low chance of failure, say P equals 0.05, only a 5% chance.
Okay.
And goal B might have 4 times that probability of failure, so P equals 0.20, a 20% chance.
So goal B seems riskier on the surface.
It seems riskier.
Yeah.
But goal A is mathematically riskier if the consequence of failing goal A is more than 4 times more severe than failing goal B.
I see.
Risk quantification demands, we look at both dimensions. And it's tricky because P and C, they rely heavily on judgment, on models, on estimation, not always on hard, measurable data.
There's a second way of framing it that I find really helpful for managers because it's so actionable. Risk is a function of the hazard and the safeguard.
I like this framing a lot. It's about management intervention. The hazard is the source of the danger, the root cause, and the safeguard is the action you take to overcome it.
So it shifts the focus.
It shifts the focus from just abstract likelihood to active mitigation. Risk goes up with the intensity of the hazard, but it goes down as you implement robust safeguards.
So the whole job of good risk management is to find the hazards so you can build the safeguards.
That's it, to reduce the risk to an acceptable, predetermined level.
Okay, now let's nail down these crucial distinctions that cause so much confusion in meetings. Risk, issue, and problem. The difference really comes down to just probability and time frame.
This is fundamental for prioritizing your resources.
Hmm.
So for a risk, the probability, P, has to be greater than 0 but less than 1. The consequence is greater than 0, and the time frame is future.
So it lives in the world of maybe.
It's a maybe. We don't know if it'll happen, but we have to plan for it.
Then you move up that certainty curve to an issue.
Right. An issue is defined by a probability of 1. P equals 1. We are certain it will occur. The consequence is greater than 0, but the time frame is still future.
So it's a future certainty.
Exactly. People overlook this. An issue is a certainty that just hasn't materialized yet. Think of a known contractual penalty date that you know you're going to hit, or a regulatory change that you know is coming next quarter.
So you stop calling it a risk item.
You transition it. It's not a risk anymore. It's an action item. Its occurrence is no longer up for debate.
And finally, the problem. This is when the fire alarm is ringing.
The problem also has a probability of 1, consequence greater than 0, but the time frame is now. It is currently happening. So the whole goal of proactive risk management is to handle the risks and prevent the issues from ever becoming problems.
We've focused a lot on the downside here, but there's also opportunity. And we naturally want to treat it as, the positive mirror image of risk, but the sources are very cautious about that.
And that caution is so important because opportunities are conceptually fuzzier. Their probability, their consequence, their time frame, they're often unclear. You can't just flip the sign on your risk matrix and call it a day.
That's not that simple.
Not at all. An opportunity might be a purely positive outcome, like finding a new market, or it could be a less negative outcome, like a supplier delivered late, but the impact was smaller than we feared.
Which is something better than expected.
Right, an engineering component that exceeded its performance targets.
Yeah.
The key is the utility you get from an opportunity win is very different from the pain you feel from a risk loss. So treating them as simple duels just leads to bad modeling and bad decision-making. So since we've established there's no single textbook answer for managing risk.
Right, it's all about judgment and contracts and what the stakeholders want.
We have to bring in the human element, the project manager's personal tolerance for risk. And this takes us into the formal definition of utility.
Utility. So in this context, that's basically the satisfaction or pleasure you get from a payoff. You graph it against the amount of money or performance that's at stake.
Exactly. It's a way of quantifying how much a certain outcome is worth to the decision maker, emotionally and strategically, not just in dollars and cents.
And that satisfaction is almost never a straight line, is it?
Rarely linear. And this gives us 3 classic classifications for how decision makers see gains and losses, which has a profound impact on the choices they make.
So let's start with the cautious one, the risk averter or risk avoider.
For this person, utility rises at a decreasing rate. That first dollar of gain feels amazing. The 10th dollar of gain, not so much.
Diminishing returns on satisfaction.
Exactly. Their satisfaction diminishes as more is put at stake, which makes them very cautious. A risk averter prefers a certain outcome, even if it's a slightly smaller expected payoff, and they will demand a premium.
Like insurance.
Like paying for comprehensive insurance or adding extra schedule padding, just to accept any level of uncertainty.
Okay, then we have the mathematical baseline, the risk-neutral taker.
For the risk-neutral person, utility rises at a constant straight line. Their satisfaction is perfectly proportional to the payoff. They don't care about the risk itself, only about the mathematical expected value of the outcome.
And this is the assumption we use for a lot of calculations.
It's foundational for standard EZ calculations, and it's often the assumed mindset for, large organizations that are just trying to optimize their portfolio gains.
And then there's the high-stakes personality, the risk taker or risk seeker.
The risk seeker's utility curve goes the other way. It increases at an increasing rate.
Yeah.
Their satisfaction actually rises sharply when more money or extreme performance is on the line.
They like the thrill.
They prefer the uncertain outcome, the massive jackpot, over the certain, smaller payoff. They might even be willing to pay a penalty or accept a negative expected value just for the chance to take that risk. They're chasing the moonshot, often at the cost of stability.
So I have to ask this. What if a project manager is, say, highly technical? They might be a risk seeker when they're trying to get a technical breakthrough.
Right. That's cause #4 territory.
But they might be an extreme risk averter when it comes to the budget. Does that cause, strategic chaos?
Oh, absolutely. That inconsistency is a serious threat to project success. The sources warn that if a project manager shows different risk tolerances at the same time averter on budget, seeker on tech agent, it leads to fundamentally contradictory decisions. They might refuse a tiny 5% budget risk, but willingly accept a 30% technical failure risk.
So what's the solution?
A project manager's utility curve should be relatively stable across all domains. If it's not, the organization has to step in and impose a consistent, defined risk tolerance to stop those internal contradictions from just tearing the whole strategy apart.
Okay, so that discussion on psychology is the perfect setup for how we actually make these complex choices formally. We know the PM's psychological drivers, but how do they apply that when the data is incomplete?
Right. And decision-making is generally broken down into 3 categories based on how much information you have: certainty, risk, and uncertainty.
Let's start with the easy one, certainty. Here we assume we have all the info we need. We can predict the outcome of any choice with high confidence.
We use payoff matrices for this, mapping the things we can't control, the states of nature, against the choices we can make, our strategies. And the key feature here is that one strategy will always be better than the others no matter what happens. It's the dominant strategy.
You don't even need probability.
No, because you just find the course of action that's superior in every possible future. If strategy S3 always gives you a higher return than S1 and S2, you pick S3. It's simple, definitive, and
unfortunately very rare in big, complex projects.
Very rare. Which brings us to decision-making under risk.
Okay, so under risk, we know that higher profits often come with higher potential losses. There's no single dominant strategy.
Right, which forces us to use probability. We have to assign a specific probability, a PJ dollar, to each possible state of nature in J dollar.
This is where we get into expected value, or EV.
Exactly. This is the realm of the EV calculation. The best choice is the strategy with the largest expected value, which is calculated as the sum of each payoff times its probability. It's a formal way of weighing potential outcomes by how likely they are.
And it's incredibly sensitive to those probability assignments. Let's use the investment example from the notes. We have 3 strategies, 3 possible market conditions. If we say the probabilities are 0.25, 0.25, and 0.50.
Then strategy S1 comes out on top with the highest EV, $65 million.
But if our market analyst changes those forecasts, say, the first probability becomes 0.6 and the others become 0.2.
Suddenly the whole calculation swings. Strategy S3, which might have looked too risky before, now has the highest EV at $66 million.
So the takeaway is twofold. First, EV calculations assume you're risk neutral. And second, they're totally dependent on the quality of your probability forecasts. Garbage in, garbage out.
100%. Which brings us to the hardest scenario, decision-making under uncertainty. This is when you just can't assign meaningful, specific probabilities. You don't have the data, you don't have the models, and no single strategy is obviously the best.
And this is where the project manager's own risk preference, their utility curve, takes center stage. It shows up in 4 specific decision criteria. The first one is for the ultimate optimist.
The Hurwitz criterion, or Maximax.
Go for broke.
It's the go-for-broke strategy. The manager looks at all the possible outcomes, finds the single biggest possible profit, and chooses the strategy that could lead to it, ignoring the downside.
So in our example, if S3 offers a potential payoff of $100 million, you pick S3.
You pick S3. And this strategy is really only suitable for, massive corporations with deep pockets that can actually absorb the maximum possible loss if things go south.
Okay, at the complete opposite end of the spectrum, we have the super cautious approach for the startup that can't afford a loss.
The Wald criterion, or Maxman, this is the pessimistic approach. It's all about survival.
How does it work?
The manager looks at the payoff table, finds the worst possible outcome for each strategy, and then chooses the strategy that has the best of the worst outcomes.
So you maximize your minimum payoff.
You maximize the minimum. In the example, if S2 guarantees you at least $50 million, while S3 could lose you $50 million, the maximum manager picks S2, hands down. They're choosing the option that lets them sleep at night.
Okay, the third one, the savage criterion or minimax regret, is fascinating. It's based on emotion.
It is. It's based on the pain of making the wrong choice. It assumes the manager is a sore loser.
Huh. I think we all know some of those.
Right. So the process is about minimizing that feeling of regret. To use it, you have to build a whole separate regret table.
Okay.
For every possible future, you find the absolute best outcome, and then for every other choice, you calculate how much you lost by not picking the best one. That's your regret.
So if the market booms and S3 would have made $100 million, but I picked S1 and only made $50 million, my regret for that scenario is $50.
Your regret is $50. You do that for every single cell on the table. Once you have your regret table, you look at the maximum possible regret for each strategy, and you choose the one that minimizes that maximum regret.
So you're avoiding the choice that could lead to the most crushing disappointment.
Exactly. It's a great tool for managers who are really sensitive to, being second-guessed.
And the final criterion, the Laplace criterion, basically says, let's just turn this back into a risk problem.
It does. Laplace says if you truly have no data to assign probabilities, then the only logical assumption, based on Bayesian statistics, is that every outcome is equally likely.
So if there are 3 states of nature, each one gets a probability of 13.
P1, P2, P3, 313. Then you just go ahead and do a standard expected value calculation with those assumed probabilities. The manager is basically saying, since I don't know, I'll assume a fair world and pick the average winner.
So under uncertainty, the choice you make is a direct reflection of what you're willing to lose.
Precisely. 4 different logical frameworks, 4 potentially different strategic choices, all driven by one thing: your inherent tolerance for risk.
Now, projects aren't just one-off decisions. They're sequential. That's where decision trees come in.
Yes, decision trees are absolutely essential for visualizing those sequential choices and mixing them with expected value. They give you a clear logic path for complex, phased decisions where an early choice affects the probabilities and payoffs of later choices.
The structure is pretty simple, right? A box for a decision point.
A box or a square, right, that's where you make a choice. And a circle for a chance point, where the outcome is probabilistic, up to fate.
And you build it left to right, then work backwards to solve it. Let's walk through that make versus buy rigid example, and let's make sure we get the math right this time.
Good idea. Okay, so first path, we decide to manufacture the widget. That's our decision. The first thing that happens is we have to spend $35,000 on a machine.
That's a fixed cost.
Fixed cost. Then we hit a chance node. There's a 70% chance of good demand, 30% of poor demand. If demand is good, gross profit is $80,000. If it's poor, it's $30,000.
So we need the expected value of that chance node.
Right. We take 70% of $80,000 plus 30% of $30,000. That's $56,000 plus $9,000, which equals $65,000.
And then subtract the machine cost.
Then you subtract the $35,000 machine cost. So the net expected value for the manufacturing path is $30,000.
Okay, now the other path, we decide to subcontract. Fixed cost here is just $5,000 for contract administration.
Right. Then we hit our chance node again. If demand is good, 70% chance gross profit is $50,000. If it's poor, 30% chance profit is $15,000.
So the EV calculation for this one
is 70% of $50,000, which is $35,000, plus 30% of $15,000, which is $4,500. Add them up, You get $39,500.
Then subtract the admin costs.
Subtract the $5,000 admin cost. The net EV for the subcontracting path is $34,500.
So $34,500 versus $30,000. Assuming a risk-neutral manager, subcontracting is the clear choice.
It is. Decision trees are just a powerful way to line up those probabilistic dominoes and apply the EV math reliably.
So what all of this shows is that risk management isn't some separate activity you do on the side.
No, it can't be. It's not a separate department. It's a fundamental part of sound project management. It has to be woven into everything. Systems, engineering, scope, cost, schedule. It has to be proactive.
The sources define this as a disciplined, 5-step continuous cycle. Let's just name them before we dig in.
Okay, step 1. Plan risk management. This is the foundation. You develop and document your strategy, your methods, you plan for resources. It's the roadmap for how you'll deal with risk.
Step 2, identify risks. You systematically go through every part of the program, technical, funding, schedule, and document every risk you can find.
Step 3 is perform risk analysis. This is the evaluation phase. You estimate the probability and impact using both qualitative, ranking and quantitative modeling.
Step 4, plan risk response. This is where you identify, evaluate, and pick the strategies you're going to use to bring the risk down to an acceptable level.
And finally, step 5, monitor and control risks. This is the crucial tracking phase. You systematically evaluate how well your responses are working against your metrics all the way through the project lifecycle.
Let's look a bit closer at that first step, planning. The risk management plan, the RMP, is the roadmap for the team. What has to be in it?
The RMP provides the whole structure. It has to establish the purpose, assign responsibilities, define the assessment process, like what tools you'll use, which areas to look at, define your risk rating approach.
Which scales you'll use.
Exactly. And delineate the procedures for how you respond. It's the constitution for how the team will handle uncertainty.
And there's a really important rule about documentation here that people often mess up, and it creates a huge administrative nightmare.
The RMP should never include the actual risk analysis results, the scores.
Why not?
It's vital. Because the scores, the probabilities, the impact analysis, that all changes constantly, weekly, monthly. If you put that in the official RMP document, you'd have to be formally revising your roadmap every week. It's insane.
So the RMP is how you analyze.
And the results, the actual analysis, that belongs in a separate living document, the risk register, which gets updated all the time.
Yeah.
That separation keeps the process stable while the data stays current.
Okay, moving to step 2, identification. The nature of risk, it really changes dramatically over the life of a project.
It absolutely does.
Right.
Risk identification is not a one-time thing you do in a workshop. It has to be continuous.
So early on in the concept and planning phases,
The total project risk is inherently high, and that's mostly because of a lack of information. You just don't have the data yet to precisely define the scope or the cost or the tech maturity. That lack of data equals high-risk potential.
But then, as you move into execution and closure, the risk shifts.
It does. While your technical uncertainties might be going down as you solve engineering problems, your financial risk goes through the roof.
Because you spent all the money.
You have massive sunk costs, and you've foreclosed most of your strategic options. The amount at stake is huge now. Failing late means losing years of work and billions of dollars. So you're managing information risk early, and you're managing capital risk late.
And one final point on who should be identifying these risks.
Right.
The sources are crystal clear that you can't just delegate this to a small group.
That is a fatal mistake. It is critically important that all project personnel are involved. Risk often hides in the gaps in the interfaces between the subteams.
And only the people working there can see it.
Only the engineers working in those areas can see it. If you delegate risk management to some admin group, you'll miss key technical insights, and you send the wrong message to the team. You're telling them risk is someone else's problem. It has to be everyone's responsibility.
Okay, so once we've identified the risks, we have to analyze them. We're trying to estimate the level of risk by combining probability and consequence into a rating low, medium, or high.
Right. And we do this through qualitative and quantitative analysis.
Qualitative is the common starting point.
It is. You use probability and consequence scales. You put them in a risk matrix. High risk is defined as something with a substantial impact that needs urgent management attention. Medium risk needs special action, and so on.
And while that sounds simple, this brings us to a really profound mathematical danger that the source material highlights. There's a hidden flaw in how we use these subjective scales.
Yes, we need a deep dive on this. Why can relying on these common scales lead to errors of 600% or more? This is maybe the most important practical takeaway for our listeners. Measurement scales are not created equal. There are a few types, but let's just focus on the huge difference between an ordinal scale and a ratio scale.
Okay, so let's start with the problem child. The ordinal scale. This is what most risk matrices use. Low, medium, high, or a 1 to 5 ranking.
An ordinal scale just ranks things. We know that high is worse than medium and medium is worse than low. But, and this is the critical part, it has no cardinal meaning. We do not know the mathematical distance between those ranks.
The gap between 1 and 3 might not be the same as the gap between 3 and 5.
We have no idea. The underlying risk exposure could be completely different.
And why does that lead to such catastrophic errors when managers try to add up all their risks?
Because they perform mathematically invalid operations. They add them, they average them, they multiply them to get some kind of aggregate risk score to figure out how much reserve funding they need.
So if you have 2 medium risks and you average their score of 3, you get 3.
You get a medium risk score of 3. But what if the true underlying exposure of those risks, if you measure them on a proper scale, was 1 unit of risk for the first one and 9 units for the second? The true mathematical average is 5, but your ordinal average told you it was 3.
You've completely misrepresented the portfolio risk.
It's worse than misrepresentation. If you do this across a portfolio with hundreds of risks, you can create massive systemic errors. The source material warns that the error between the actual cardinal coefficients, what the risk truly is, and what the ordinal scale suggests, can exceed 600%.
So you could be basing your entire reserve budget on a risk score that is dramatically lower than the reality,
leaving you massively exposed to failure.
So the ideal solution mathematically is the ratio scale.
Correct. A ratio scale has meaningful intervals, a true 0 point, and it allows for valid math, like addition and averaging.
But so rarely used.
They're rarely used in risk analysis because it's just really hard to assign a true ratio level score to something like schedule delay impact. And this tension between the mathematical need for ratio scales and the practical ease of invalid ordinal scales is this constant subtle threat in project management.
And that limitation is what pushes teams toward quantitative risk analysis, especially the Monte Carlo process.
It has to.
Yeah.
Quantitative analysis moves beyond those simple point values and tries to create probability distributions for potential risks. The Monte Carlo process is a simulation technique that randomly samples those distributions thousands of times.
To transform probabilistic inputs into real, quantifiable results.
Right. It gives you probabilistic cost estimates, probabilistic schedule dates, often shown as a cumulative distribution function, or CDF and the likelihood of meeting your tech goals.
The sources outline 8 critical steps for running a Monte Carlo simulation. It starts with the model.
Step 1. Develop and validate a deterministic model, your baseline schedule or cost estimate without any risk applied. Step 2. Develop the reference point estimate, the expected cost or duration, for each piece of the work breakdown structure.
And step 3 is the one the source really warns about, checking and rechecking the model logic and constraints.
This step should take the most time. The source says for complex schedules with thousands of tasks, more than half of your total simulation effort should just be validating the deterministic logic.
Why so much?
Because complex schedules have thousands of dependencies, lags, leads, resource constraints. If that deterministic logic is flawed, if you have broken dependencies or circular logic, your simulation results will be garbage. It doesn't matter how good your probability inputs are.
It's the fastest way to invalidate the whole assessment.
A single fastest way.
Okay, so steps 4 through 6 are about modeling the uncertainty itself.
Right. You identify the lowest level of the WBS, where you'll build your distributions. You identify which elements have uncertainty, and then you develop suitable probability distributions for them, treating cost, schedule, and technical risk as separate but linked distributions.
And the final 2 steps aggregate and analyze.
The aggregation, step 7, produces those CDS, that S-curve that tells you we have an 80% confidence of finishing by date X.
And step 8, sensitivity analysis, introduces this really useful metric called cruciality.
Yes, cruciality helps the manager pinpoint which specific risks are truly driving the overall uncertainty in the project.
And how is that calculated?
It's the product of 2 things, criticality and sensitivity. Criticality is the percentage of times a task ends up on the probabilistic critical path.
So how often it dictates the end date.
Exactly. And sensitivity is how much that task's own probability distribution influences the final project finish date. By combining them, cruciality points you to the tasks that are both highly likely to become critical and have a high variance. It tells you exactly where to focus your mitigation efforts.
So we've identified the risk, we've analyzed it, now we have to respond. This is about choosing the right strategy and documenting how you'll implement it.
Right. And we need proactive strategies for both the downside, the risks, and the upside of the opportunities.
For risks, we have 4 core strategies. First is avoidance.
This is the strongest move you can make. You change the design or the requirements or the scope to make the risk go away completely. If using a new material has a 40% failure risk, avoidance means you just switch to a proven older material. The risk is gone.
Second, mitigation or control.
This is what people usually think of. You take active steps to reduce either the probability of the risk happening or its impact if it does.
It's like adding redundancy.
Adding redundancy, doing extra testing, hiring a specialist. You're actively trying to shrink the P and or the C.
Third is transfer.
This is about shifting ownership of the risk to someone else. The classic examples are buying insurance, getting a warranty, or using a fixed-price contract with the supplier.
Right. With a fixed-price contract, you transfer the cost overrun risk to them.
You do. You're basically paying a premium to transfer that financial uncertainty.
And fourth, acceptance.
This is where the manager knows the risk exists, accepts the possible consequences, and just waits to see what happens. But, and this is, critical acceptance has to be paired with allocating sufficient reserve resources, budget, schedule, people.
You accept it, but you don't ignore it.
Exactly.
Now for the upside, the opportunities. We have 4 corresponding options.
First is exploit. You take direct advantage of it. Maybe you assign your most talented people to it or fast-track a process to capitalize on it.
Second, enhance.
You try to increase the probability or the positive impact of the opportunity. If a new capability might save time, you invest in extra training to make that time savings more likely to happen.
Third, share.
You team up with a partner to maximize the benefits. If a new market opens up but you don't have the distribution network, you share the opportunity with the logistics partner.
And finally, acceptance for opportunities too.
Same idea. You acknowledge the opportunity exists, and you wait to see what happens. You don't spend resources chasing it unless it materializes on its own.
Now, there's a big warning that comes with managing opportunities. Pursuing the upside often creates unexpected downside.
Yes, this is so important. While looking for opportunities is healthy, chasing that reward often means reallocating resources or changing your technical approach, which will inevitably create new, unanticipated risks.
So you have to analyze the risks of the opportunity itself.
You have to. You have to rigorously analyze the new risks you're creating to stop them from causing adverse impacts that wipe out any potential gain.
So the final step in our cycle is monitoring and control. This is about making sure our risk response actions are actually working.
Right. This is a proactive technique. It tracks the effectiveness of your actions against your metrics throughout the project. We use a management indicator system, and the tools are pretty well integrated into project management.
One of the biggest is earned value management, or EV.
Earned value uses integrated cost and schedule data to evaluate performance. By tracking planned value versus earned value, you can see very quickly if your risk responses are actually delivering the cost savings or schedule gains you predicted. If your EV metrics are getting worse, your response is failing.
We also use technical performance measurement, or TPM.
TPM estimates, through tests and analysis, the values of your key technical parameters. This is how you verify if your technical mitigation efforts like reducing heat output or increasing reliability are actually working in the physical product.
And finally, just formal program metrics and schedule performance monitoring.
These are just continuous formal assessments of your processes and schedule progress. They give you objective confirmation that your corrective actions are actually stabilizing the project, not just masking the symptoms. Monitoring and control is what closes the loop on the whole proactive risk strategy.
So we started this deep dive with that universal experience of project failure, the overruns and slips that are just all over the headlines. And we've meticulously detailed the shift from, the chaos of crisis management to a rigorous, structured process of defining, analyzing, and responding to every type of uncertainty.
We've come a long way from just calculating a single optimistic cost and schedule number. We now use formal decision criteria driven by an organization's utility, sequential risk analysis with decision trees, and simulation modeling to understand the entire probability distribution of what could happen.
And that maturity is required just to keep up with the pace of modern technology.
It is.
But even with all these advanced tools, we highlighted this really dangerous underlying flaw that's embedded in the system. A flaw many project managers don't even realize they're dealing with.
The mathematical misuse of subjective risk scores.
Exactly.
We established that true quantitative analysis using sound ratio scales is rare. And that project teams all the time rely on those ordinal scales, the simple low, medium, high rankings, to add up their risk and calculate reserves. And we know that doing math on those numbers is invalid.
Because the true gap between medium and high is totally unknown.
Unknown and likely not uniform.
So here's our final provocative thought for you to take with you. If you are calculating project reserve requirements based on risk scores that come from ordinal scales, what specific risks are you unknowingly accepting or avoiding just because the measurement scale you're using is mathematically inappropriate?
And given that we know this error can exceed 600% when you aggregate risk, how can you be sure that you aren't relying on a risk budget that is 6 times too small, sending you right back into crisis management the first time a real failure hits?
The rigor of risk management begins not just in the complex calculation, but in the simple, objective definition of the data itself.
Question the scale. Question the data source. It just might save your project.
An essential challenge to end on. Thank you for joining us for this deep dive into decoding risk and project failure. We'll see you next time.
Welcome back to The Deep Dive. This is the show where we take, these really complex blueprints, these dense research papers, and we try to turn them into something clear.
Into something actionable.
Exactly. Actionable, crystal clear knowledge, curated just for you from the source material you provide. Today, we are strapping in for a really deep look at project risk management.
A huge topic.
It is.
Yeah.
And if your organization relies on risk management as just, a compliance exercise, a checklist you do once during planning, we are about to really expose the gaps in that whole approach.
Yeah.
Our sources today, they give us a pretty detailed blueprint for moving beyond just ticking boxes. They guide us toward an integrated, continuous methodology that's really woven into the fabric of project execution.
And that shift in perspective is, it's everything. Most organizations, when they start thinking about this, they just think about threats. What could go wrong?
The list of bad things.
The list of bad things, exactly. But what's so fascinating in the material here is that it shows effective risk management is fundamentally about culture. It's about behavior, and it's about managing this intricate web of dependency.
It's an ecosystem.
It's a total ecosystem.
Yeah.
And if you fail to see that, mitigating one risk, in a vacuum, can actually catastrophically create a new, much worse secondary risk.
And that's the hidden trade-off, right? That's the complexity that just defeats so many of these high-stakes, long-duration projects. So our goal today is to turn that intimidating complexity, all those interdependencies and tough organizational choices, into knowledge you can actually use. We want you to see how to move past that superficial list and get into continuous adaptive management.
Let's do it.
Okay, let's unpack this. We should probably start right at the foundation.
Yeah, the foundation is the right place to start. And we have to begin by acknowledging that risk management is just not a one-size-fits-all solution.
You can't just download a template.
You absolutely cannot. The sources really emphasize this huge implementation challenge. You can't just adopt a standardized process and expect it to work.
So what makes it so different from project to project?
Well, effective risk management needs the right organizational and behavioral considerations, and these have to be highly tailored. You've got the size and length of the project, the existing company culture.
Which can be a huge barrier.
A massive one. Then there's the maturity of the risk practices you already have in place, and even, rigid contractual requirements from a client or a regulator.
So customization is mandatory, not optional. And that means before a single thing gets done, you have to define the structure for dealing with all this uncertainty. And this brings us to what the sources say is an absolutely critical step: defining specific roles and responsibilities inside the risk management plan, or the RMP.
Yes.
If those lines of authority are blurry, you're basically guaranteeing confusion and delays the moment a crisis actually hits.
And the RMP isn't just a list of names. It's a governance framework. It forces you to answer several really tough questions in advance.
Okay, like what?
For example, which managers have the actual decision-making authority for a risk? When a risk pops up that needs $1 million in extra resources, or it's going to cause a 3-month schedule slip, who signs off on that?
That's a huge political question.
It's immense, because assigning authority also means assigning responsibility if things go wrong.
And you also need caretakers for the process itself, right? Who owns it?
Exactly. Which group owns and maintains the risk process? And that's not just, an admin job. This is the group that ensures the methodology stays relevant, they communicate changes, and they act as the sort of institutional memory for all the lessons learned.
And that connects to training, I'd imagine.
It does. Who is responsible for risk management training and actually helping with the implementation, helping the different technical groups? If training is just a one-time thing from HR,
It's already failed.
it has already failed. The sources suggest this has to be an ongoing supportive function, making sure the RMP is actually adopted, not just, complied with on paper.
Okay, so then we get to the actual process of finding risks. The sources seem to have a universal rule here.
They do.
Who identifies candidate risks? And the answer is everyone.
Everyone. It can't be siloed. It has to be part of the daily workflow for the engineer, the finance person, the procurement specialist, everyone.
So once those risks are flagged and they're approved as being serious enough to track, how do you assign ownership?
You have to assign focal points or risk owners. You need a single point of accountability for monitoring that specific risk, for reporting on its status, and for executing the response plan that you've already approved.
So that owner isn't necessarily the big decision maker.
Not necessarily, no,
What
but
then?
they are the reliable pipeline of information flowing up to that decision maker.
And the RMP, it needs to detail that whole mechanism, right? From identification all the way to action.
Yes, how do you perform the analysis with rigor? How do you develop and approve the response plans? And crucially, how is resource allocation guaranteed?
That's where the paper plan meets the budget reality.
Exactly. If the RMP doesn't explicitly guarantee resources for accepted risk responses, the entire process is basically toothless.
And finally, there's the governance piece, auditing.
How are you collecting data for your risk monitoring metrics? And maybe most important for these big, high-stakes projects, how are independent risk reviews performed?
Why independent?
Because those external reviews are essential. They ensure risks are being properly identified and analyzed without the inherent bias that creeps in when a project team is just reviewing its own work.
Right. Without that outside check, I imagine risks tend to look a little less severe over time.
They always do.
So that whole RMP discussion really underscores that risk management is an organizational discipline, not just a technical one.
That's right.
And the sources are really firm on this. The framework needs both a top-down and a bottom-up mandate. They have to meet in the middle.
The top-down mandate, it starts with the project manager and the key senior leaders. And their involvement can't be passive. They have to actively participate. They have to visibly use risk principles in every major decision they make.
From vendor selection to staffing changes, all of it.
All of it. Because the moment a project manager starts making big trade-offs without even looking at the risk data, the rest of the team sees it.
And the consequence of that leadership apathy is immediate, isn't it?
It is. The sources warn that without that active, visible support from the top, the working level people will just dismiss the whole thing as unimportant.
Or lip service.
Or just lip service, an obstacle. Sure. If they see their leaders bypassing the system, why wouldn't they? It just creates this systemic cynicism.
And this brings us to a really key behavioral component, the whole idea of not shooting the messenger.
Right. It's universally understood that you can't punish people for reporting bad news or uncertainty.
That's just table stakes.
It is, but the sources argue that just avoiding punishment is not sufficient. You have to go further and actively foster a positive atmosphere that is conducive to identifying and communicating risks.
Okay, I see. So it's the difference between being neutral and being positively reinforcing.
Exactly.
If I report a risk and nothing happens, even if I'm not punished, I might just stop reporting them. So what does actively fostering that atmosphere look like?
It means recognition. It means validating the effort, even if the risk doesn't actually happen. It's about rewarding the critical thinking process itself. When a junior engineer flags a potential technical issue that the senior team dismisses, that senior team has to explain why it was dismissed and then thank that junior engineer for speaking up.
Otherwise, the message is don't bother.
Right. If the project manager only responds to risks after they've already become problems, the culture becomes reactive, not proactive.
And while management is building that psychological safety, the bottom-up mandate is where the rubber meets the road.
It is. The working level people have to be actively engaged. They need to assimilate these risk management principles as just part of their daily job. They're the ones on the front lines.
They see the leading indicators of failure first.
We always do. But the objective isn't to turn everyone into a designated risk manager. That would be a huge burden.
It's not a second job title.
No. The goal is behavioral. It's to make them sensitive to risk management principles so they apply them regularly, almost instinctively. When they're about to specify a new material, they ask, what's the risk with its lead time? When they adjust a test procedure, they ask, what secondary risks does this create?
So it moves from being a specialty function to just a fundamental competency.
That's the goal. A mature organization treats risk thinking just like it treats quality assurance. It's just part of how you do good work.
Okay, so moving from that organizational culture to the harsher realities of execution, we hit a fundamental constraint, finite resources. We can't assume we have unlimited funding to address every single risk. So prioritization isn't just nice to have, it's an absolute necessity of focus.
Precisely. And risks are usually categorized by the project constraints they hit: time or schedule, cost, and performance, the technical side.
And the project manager has to decide that hierarchy. Is the delivery date sacred? Is the budget completely non-negotiable? Or is the technical performance the #1 priority?
And that prioritization order, it can be set by the project manager, the sponsor, or even dictated by the customer in the contract.
The sources also point out some fascinating cultural differences here.
They do. You see these generic prioritization schemes, but then you look at industry or country-specific methods. For instance, historic Japanese methodologies often put flawless quality performance and long-term cost way ahead of short-term schedule. It shows how deeply culture affects what you see as the most serious risk.
That's a great point. And even if you have a framework, that priority can change midway through, right?
It absolutely can. A project management methodology gives you a baseline. It reveals the implied priority. But then real-world factors, like a market shift or a competitor's move, can completely change that priority. The sources are clear. Trying to standardize this, applying the same priority matrix to every project, it's just impossible. The context is always shifting.
But even with a crystal clear priority, let's say schedule is #1, you can't treat that risk in a vacuum.
No, you can't isolate it.
The moment you address a risk in one dimension, you immediately have to evaluate the others. If I rush testing to protect the schedule, I am creating a technical performance risk.
And that is the absolute core insight of this section. Risks are fundamentally interrelated. We know this from basic trade-off analysis. If you change the schedule, it almost always affects cost or performance or both.
So it's not about solving one problem.
It's about shifting the weight of the risk onto another part of the project. It's like a web of interconnected stress points. You can't touch one without making the others vibrate.
And this interconnectedness leads us right into the most dangerous territory. The trap of mitigation strategies, what the sources call secondary risks,
This is where good intentions can go horribly wrong.
where an action you take to get a specific benefit inadvertently creates new risks that are way more severe than the original problem you were trying to solve.
Let's ground this with a specific example from the source material. This is where you have to be really rigorous. So imagine your original problem is a potential schedule delay, and the proposed fix is working continuous overtime. The expected benefit is you compress the schedule and maybe save, say, $15,000 in late penalties.
Okay, on the surface, that sounds like a win.
It does. But what's the resulting secondary risk? It's your employees making significant mistakes because they're exhausted, they're stressed, they're burnt out.
So those errors then require retesting.
Extensive retesting, you have to buy new materials, and ultimately you cause a bigger schedule slippage than the one you were trying to prevent. The potential loss from this secondary unforced error, the estimate is $100,000.
Wow. So now you're facing the central decision that really defines a manager's skill, aren't you? Is it worth risking a loss of $100,000 just to save $15,000?
That's the question.
That trade-off is just so stark. And without the right tools, it just becomes a pure gamble driven by panic. What do the sources say about navigating that kind of pressure?
It demands the rigorous application of a concept called expected value.
Expected value.
Yeah, it forces you to quantify things. It requires you to determine the probability of those mistakes happening and the precise cost if they do.
Okay, so walk me through that.
Let's say we assume the probability of making a fatal $100,000 error during that high-stress overtime is, say, 30%. That seems reasonable in a complex environment.
Okay, a 30% chance.
Then the expected value of that loss is $30,000. That's 30% of $100,000.
Wait, so if the expected loss is $30,000 and the expected gain from avoiding the penalty is only $15,000, mathematically the decision to work overtime is a net negative.
A net negative of $15,000, exactly. But here's the hard part. Without that quantitative knowledge, without historical data to give you that 30% probability, the decision just relies on the project manager's subjective gut feeling, their risk tolerance.
Or worse, their desperate need to not miss a deadline today, no matter what happens next month.
That's it. And that's the fundamental difference between just guessing and actually managing uncertainty.
And if that quantification challenge wasn't hard enough, we have to talk about technical risks.
Hmm.
Project professionals, they pretty much all agree that technical risks are the most serious category.
And the least understood.
Right. Why is that?
The sources highlight that the absolute worst-case scenario isn't just one component failing. It's when multiple technical risks interact in a cascading, unpredictable, or even a completely unknown way.
Like in aerospace or a complex software project.
Exactly. You have two subsystems that, on their own, are proven to be safe, but they fail spectacularly only when you run them at the same time.
That sounds like an infinite analysis problem. I mean, if you try to model every possible dependency between every technical risk, you'd never actually start the project.
You would. You'd face this almost infinite analysis problem, and it would consume huge resources. Your standard project management methodologies, they're great for a timeline or a budget, but they're just not sophisticated enough to handle that kind of complex dependency without becoming a project in themselves. The key is acknowledging that technical risk demands a maturity approach, not just a quantitative one. We'll get to that.
Okay, so given this constant evolution of risks and their complex interactions, the whole process, it just has to be continuous. It can't be static.
Absolutely not.
And this is supported by 4 common factors that, they seem obvious, but they're so often ignored.
They are. It's the project duration, the sheer financial investment at stake, the developmental maturity of the technology you're using, and of course those dense interdependencies we just talked about. Any one of those just increases the need for constant vigilance.
We can ground this with a really great, massive case study. Boeing's aircraft projects.
Perfect example.
Developing a new commercial jet can take 10 years, and the investment is easily over $5 billion.
Yeah.
At that scale, risk assessment has to be perpetual.
And Boeing structures its approach by categorizing risks into 4 main types, and they perfectly illustrate these dynamic dependencies. First, you have financial risk.
The upfront funding.
Right, the upfront funding and forecasting the payback period over decades of future sales. Their strategy is to fund projects by life cycle phases, staging the commitment, and maintaining continuous financial risk management.
Okay, second is market risk.
This is forecasting what customers will want in terms of cost, configuration, all of that, over the plane's 30 to 40-year service life.
That's a long forecast.
Very long forecast. They counter that with really close customer contact, getting their input, and relying on a strong, standard baseline design.
Third is technical risk.
Forecasting technology and its impact on safety, cost, reliability across all those decades. And the primary strategy here is very disciplined. They rely heavily on proven designs and proven technology.
They don't bet the whole farm on a leap of faith.
No. They run parallel processes for improving products and developing new ones, which keeps them from getting trapped.
And finally, production risk. Which must be monumental.
It is. Coordinating manufacturing across tons of global subcontractors without messing up cost, schedule, quality, or safety. Their strategy relies on stable working relationships and, critically, using lessons learned from other new airplane programs. They apply learning curves rigorously.
The big lesson from Boeing seems clear then. These 4 risk categories are not silos.
Not at all. For example, if Boeing introduces some new, unproven tech to satisfy a customer, which reduces market risk.
They simultaneously increase their technical risk.
And they lengthen the production risk learning curve for their subcontractors. You can't touch one without affecting the others. And that relationship demands a live, constantly reassessed risk matrix, not just a checklist.
So the continuous process isn't just about checking in every so often. It's a necessary function of the sheer duration and interdependence of major projects.
That's it, exactly. And that seamless interaction between risk types, which the Boeing example shows so well, it leads us to this critical need to integrate 2 things that are usually separate: risk and change management.
Okay, bring those 2 together.
You have to. Risks and changes go hand in hand. Every strategy to mitigate a risk can result in a change that then generates new secondary risks. They have to be fused into one methodology.
I can see why. I mean, if your risk plan says you have to switch vendors, that is a change. And if that change isn't managed correctly, the new vendor might introduce all new quality risks or schedule risks.
Precisely. Let's look at the comparison our sources make between unmanaged and managed change. It's really insightful. When changes are unmanaged, all the organization's time and energy is focused on the back end.
Cleaning up messes.
Cleaning up messes, rework, enforcement, supervision, and worst of all, assigning blame.
And the cost implications there must be staggering.
They are. Unmanaged change is where risk management just devolves into permanent crisis management. You're pulling in senior, high-salaried managers, your key technical people, the ones whose time is most valuable, to fight fires.
It's a massive resource strain.
And it demoralizes the staff, which guarantees more problems down the line. It just becomes political maneuvering to survive.
Okay, so contrast that with managed change.
With managed change, all the energy is focused on the front end. Education, communication, planning, process improvement.
And that results in a lower cost risk plan. Why is that?
Because you're engaging lower cost resources much earlier in the life cycle. You're talking to stakeholders, internal teams, suppliers. You're pushing the heavy lifting of figuring out consequences and solutions to the beginning when it is exponentially cheaper to fix a problem.
It's preventative medicine versus emergency surgery.
That's a perfect analogy. You're proactive instead of reactive. And this integration is essential because, as we said, methodologies can't define every single dependency. It's up to the team to make those calls, which is impossible if they're always fighting fires.
Speaking of pressure, let's talk about the modern obsession with speed, the first-to-market advantage. This means concurrent engineering, overlapping activities.
A huge source of risk.
So the critical question for a project manager isn't if they should overlap tasks, but how much overlapping can we do before we get diminishing returns?
This is illustrated so well by the nonlinear relationship in the source material. Overlapping activities initially can give you a huge benefit. You get schedule compression, lower costs. You start task B before task A is totally done. That's efficiency.
But there's a tipping point.
A huge tipping point. If you push it too far, if you start task B when task A is only, say, 10% complete, that excessive overlap leads to massive cascading rework, unanticipated problems, and catastrophic cost overruns.
It's like trying to put shingles on the roof while the foundation is still curing.
Yes. You might gain a week at the start, but when that foundation shifts, you have to scrap 80% of your roofing work. Finding that optimal, narrow point that maximizes speed while minimizing rework is incredibly difficult.
So what are the common causes of that rework?
The sources highlight two big ones. First, trying to combine new technology development with product development at the same time, without proper maturity gates. And second, launching with an insufficient test and evaluation program.
Let's dig into that first point. We see it all the time.
Sure.
Sales and marketing promise a new product with some advanced but still undeveloped technology.
Right. And to hit that aggressive timeline, the development team starts detailed design without even being certain the technology will work. Meanwhile, production starts tooling up based on incomplete drawings.
And when the core technology finally stabilizes or fails,
the changes cascade instantly through the entire organization. You're retooling, redesigning. It confirms you have to keep asking three questions. Can this new tech actually be developed? Can we demonstrate it reliably in the final product? And can that final product be manufactured reliably within our constraints?
And if the answer to any of those is no, you're facing financial suicide, which is highlighted by this terrifying concept of the cost multiplier.
This is a critical insight. The financial cost of finding technology problems late is exponential. If you resolve a tech problem after product development has already started, the cost increase is typically tenfold.
10x. 10x. That's bad enough.
But if that same problem isn't discovered until the product is already in production, assembly lines are running, parts are being ordered at scale, the cost increase could be 100-fold, 100x.
100 times.
That 100-fold multiplier reflects the immense cost of stopping assembly lines, retooling, scrapping thousands of parts, renegotiating contracts. This is why disciplined risk management focused on technology maturity is about financial survival.
So what strategies do leading firms use to reduce these enormous risks?
They build strict firewalls. They impose strong standards.
They enforce maturity.
Yes. Leading firms do not include new technology in a product until it reaches a prescribed maturity level. They maintain disciplined development paths with very strong gatekeepers, senior managers, who have the authority and the mandate to say no until the milestones are met.
And they use frameworks for that, right? Like technology readiness levels.
Exactly. They use high standards for maturity judgment, like technology readiness levels, or TRLs.
Can you give us a quick conversational definition of TRLs?
Sure. It's a scale, usually 1 through 9, to assess how mature a technology is before you commit. Level 1 is just basic research. Level 9 means the technology is proven successful in an operational environment. It's flight-proven, as Boeing would say.
And disciplined firms have a minimum level they'll accept.
They do. They often won't launch a major new product using any tech rated below a TRL of 6 or 7. That means it's already been demonstrated in a relevant environment. And that dramatically reduces the chance of hitting that 100x cost multiplier.
So that focus on maturity prevents catastrophic rework. It's about insisting on a mature design before you even think about production.
It is. But all this effort, the RMP, the TRLs, the continuous management, it brings us back to a vital financial assessment, achieving investment and risk management parity.
Parity, meaning balance.
Balance, because investing too much or too little can be equally devastating.
Okay, so this is where we need to find that sweet spot. Tell us about the parity concept.
The parity concept shows the relationship between the money you invest in risk management and the project's potential for financial disaster. Overinvestment, going overboard with documentation, redundant testing, can lead to financial disaster if the risks don't actually warrant that expense.
You spent millions protecting against a minor hazard.
Right, and you diverted resources from where they were really needed. And conversely, underinvestment for a really complex, high-hazard project will lead straight to heavy losses and failure. The goal is parity, making sure the investment matches the size of the disaster you're trying to prevent.
We see this balance reflected in the schedule time.
I do. If you have too few risk-handling measures, you get an elongated schedule because you're constantly fighting fires, causing delays.
But the surprise here, and the danger of bureaucracy, is that excessive risk measures also lead to an elongated schedule. Why does too much risk management slow things down?
It creates analysis paralysis and compliance fatigue. Too many filters, too much reporting, too many meetings. Workers spend all their time on contingency planning instead of actual execution. Progress slows to a crawl. The project manager has to find that balance.
This leads us to the final and maybe most sobering realization from the sources: the imperfection of planning.
Yes.
Organizations strive for this perfect plan. They have primary plans, secondary plans for every possible hazard.
They do, and they should. But the real world is messy. Even with the best RMP, the best gatekeepers, the most sophisticated plans, some losses and damages will still occur, even for known risk issues.
So risk management mitigates damage. It doesn't eliminate the possibility of failure.
It doesn't eliminate it entirely. It's not a guarantee against all losses. It's a necessity for making informed, non-catastrophic decisions. It allows the project manager to control how they fail, to make sure the failure is small and manageable, not catastrophic and unexpected. #outro.
Wow. This deep dive has really recast risk management. It's not a compliance activity. It's a core, continuous organizational competency.
It has to be.
So let's recap the essential takeaways for you, our listener. Risk management, it isn't a singular activity. It's a continuous integrated methodology, and it's driven by organizational structure and behavioral commitment, both top-down and bottom-up.
And I think the most critical insight we uncovered today is the true complexity of risk interdependency. Effective project managers just cannot treat risks in isolation.
Yeah.
They have to use analytical tools, especially expected value, to rigorously weigh the cost of a fix against the potential severity of new secondary risks. You can't trade a small benefit, like a minor schedule gain, for a massive hidden financial loss, like that 100x cost multiplier.
We also saw that, while your methodology might dictate how many risk-handling measures you have to constantly monitor the efficiency of that process.
We do.
You have to make sure the cost of maintaining those measures, the meetings, the documents, the gates, doesn't overly burden the project and slow it down to the point of failure. The process itself should not become the risk.
We've established that the investment in risk management isn't a guarantee against all losses, but it is the prerequisite for making informed decisions, for ensuring that parity between what you spend and the disaster you avoid. And this, I think, it raises a really important question for you to consider as you wrap up this deep dive. In your own organization, when people report a potential problem, are you ensuring there's a positive, risk-aware culture where that intelligence is actually rewarded and acted upon early?
Or are you just focused on checking the compliance boxes that say you have a process, regardless of whether it actually works?
That's something to think about.
It is. Until next time, keep digging deep.
Okay, let's unpack this. We've been handed a substantial stack of material that fundamentally suggests project environments, far from being the picture of harmonious collaboration,
Right.
are instead defined by one powerful, overarching characteristic: conflict. I mean, if you are a project manager or even prepping for a role in any large endeavor, you need to accept that your primary job description is less scheduler and more conflict manager.
That's absolutely the core reality we need to address. A lot of people approach project management with this, this idealized view of coordinated effort.
Yeah, everyone rowing in the same direction.
Exactly.
Right.
But the reality is that projects inherently pit three fundamental constraints: time, cost, and scope against each other. And the friction this creates means conflict isn't an anomaly. It's the default setting.
The default, yeah.
So if you're listening today, whether you're catching up on strategic project frameworks or just, trying to systematize the chaos in your organization, this deep dive is specifically designed to give you the actionable tools to thrive in that environment.
Agreed. Our mission today is explicitly to move you beyond that reactive crisis management. We're equipping you with the formal frameworks for understanding why conflicts happen structurally, how to solve problems systematically using concrete defined tools, and when to make those tough strategic trade-offs using established methodologies that take the emotion out of the decision.
And we need to look at both ends of the spectrum here. We'll cover the tactical, interpersonal dynamic, like how you handle an argument with a teammate, right, or a functional manager.
The day-to-day stuff.
The day-to-day stuff, yeah. And then we'll move all the way up to the quantitative impact analysis required for major strategic pivots involving, hundreds of millions of dollars. We're looking for the structures and repeatable processes that make resolution possible no matter the scale of the dispute.
So let's start with that core reality. Conflict is a way of life in a project structure, and it usually stems directly from conflicting objectives and, a scarcity of resources. The sources suggest that opponents of project management, I'm talking about companies that resist adopting formal structures, they often struggle primarily because they just don't know how to handle these conflicts when they pop up. They fear the chaos.
And that fear is rooted in the constant state of firefighting. I mean, the project manager, by definition, is a conflict manager. They're perpetually dealing with mini crises. And resolving these conflicts efficiently and in a timely manner is often the critical difference between project success and total failure. So the first step to mastering this is understanding the why, identifying the causes that are structurally inevitable.
Meaning they're built into the system long before you even arrive.
Exactly. It's not about the people, it's about the process.
Okay, so the sources provide a brilliant dissection of 5 common causes of conflict, and these are often baked in right at the very start of a project. They create structural conflict no matter who is involved.
The first cause is extremely common: imposed requirements. Just think about the typical process flow. Project managers are almost always brought in after the initial business case is prepared.
After the big decisions are made.
Right. After the high-level schedule is set, the cost is estimated, and the major assumptions and constraints are all locked down by senior leadership or the client.
So you basically inherit a mandate, and I'm guessing once the PM tries to create a detailed, realistic project plan, what do they find?
They find the deliverables simply cannot be achieved within those pre-imposed requirements and constraints.
Wow.
So the conflict is already there, baked in by the initial sequencing of the planning process itself. It forces immediate trade-offs or, a confrontation with the sponsor right out of the gate.
Okay, that makes a ton of sense. So what's the second cause?
The second cause ties directly into resources, and this one is a killer in competitive environments: lack of capacity planning.
So you don't have the people you need.
Or you don't know if you will. Companies, especially those that rely on competitive bidding or have, cyclical business models, they frequently approve projects without giving real detailed thought to whether qualified personnel will actually be available when they're needed.
And this shows up in real time as staff shortages. You might have the budget, but you don't have the bodies.
Or worse.
Go on.
The subject matter expert, the SME, assigned to your high-priority project is only giving you 10 hours a week, even though your plan, which management approved, required 40.
Ouch.
The company committed the budget, but totally failed to commit the capacity.
Which leads right into the third cause, I'm guessing.
It does. Ambiguous staffing. So the high-level schedule might be based on a go-ahead date, which, it sounds vague because it is.
It is, yeah.
But beyond that uncertainty, once the project officially kicks off, the specific qualifications or even just the work habits of the assigned project team members may not actually fit the precise, nuanced needs of the project.
So you've got staff, but they aren't the right staff.
Exactly. Let's say you need someone proficient in Python, and you are assigned a brilliant developer, but their primary expertise is Java.
So they're technically qualified, but not for this specific need.
Right. And you're told these are the only resources available. That creates immediate internal pressure and conflict over quality and schedule.
Okay, so what's number 4?
The fourth cause highlights the constant internal competition: disruption to ongoing business. If your project is considered low or even medium priority, which, let's face it, is common, you must expect that your most critical resources might be temporarily pulled away to put out operational fires somewhere else in the company.
Ah, the classic bottleneck. The project has to get done without disrupting the core business operations. But the core business is constantly dipping its hand into your resource pool and pulling your staff away right when you need them most. So your schedule suffers because someone else's emergency took precedence.
And that leads us to the last one. The fifth cause is purely structural, and this is where we really need to talk about the organizational model. Organizational structure. Specifically, the tension inherent in a matrix environment.
Wait, okay, let's quickly define that for the listener, because matrix structure is a term that gets thrown around a lot, but it's rarely explained clearly, especially in terms of its impact on conflict.
That's a good point. So in a matrix organization, your staff report to two managers. A functional manager who kind of owns their career, their training, their salary.
Their home base.
Their home base, exactly. And the project manager who manages their daily tasks for the project. Now, the structure is designed to share resources efficiently, but it creates an immediate inherent tug-of-war for allegiance, time, and priority.
I can see that.
The line managers are under tremendous pressure to staff a multitude of projects at the same time. A delay on just one project can ripple through the entire organization, which means personnel who were supposed to rotate onto your new project are now being held back.
So what we've really established here is that a lot of these conflicts are just structurally inevitable. They're built into the resource management system, the organizational design, the initial project approval process. It's not just about interpersonal failure. And that's a huge insight because it means good project managers don't try to eliminate conflict. They try to anticipate and systemize the resolution of conflicts they know are coming.
Okay, so now that we understand the structural why, let's look at the sheer breadth of the conflict landscape.
Yeah.
While it's impossible to list every single dispute, the sources identify 10 common areas where clashes usually happen.
And these areas are incredibly practical. I mean, we are talking about friction over staffing resources, who gets whom,
This is a big one.
equipment and facilities, who gets the dedicated testing lab, costs, the budget battles, technical opinions, and trade-offs.
Let's build it, yeah.
Right. Then you've got priorities, which task gets attention first, scheduling, responsibilities, who is accountable for what, administrative procedures, and even capital expenditures.
And while project managers consistently report that conflicts over schedules are the most frequent because the clock is always running,
Always.
they also recognize that the potentially most damaging conflicts are those that happen over variety. Personality clashes. I mean, schedule conflicts are transactional. You can solve them with data. But personality conflicts, they're emotional and enduring. They poison the well for any future collaboration.
And the intensity of these conflicts isn't static, which is a critical point. It's constantly varying as a function of several factors.
That's right. It changes if you're getting closer to project constraints. The urgency just intensifies the heat.
Sure.
It changes if you only have 2 constraints instead of 3, say. Time and performance are fixed, but cost is variable. That forces all the pressure onto the budget. And critically, it changes depending on the specific person you're having the conflict with. The conflict intensity also follows the project lifecycle itself. It often spikes during planning and then again during final execution.
So here's an insight from the material that I think really flips the script on how we view conflict. It says sometimes conflict should be permitted to continue because it is meaningful and produces beneficial results. These aren't failures of management, they are deliberate pressures designed to achieve a better outcome.
That's the productive friction we hear about.
Yes.
Can you give us an example of that?
Certainly. Imagine you have 2 highly qualified technical specialists arguing vigorously, each trying to find additional supporting data for their hypothesis about the single best way to solve a complex engineering problem.
Okay.
They are locked in debate, but their focus remains entirely on the problem, not on, belittling each other.
Right.
That engagement drives depth, it forces better data collection, and ultimately it results in a superior, more thoroughly vetted solution. That's a beneficial result that just smoothing over the argument wouldn't achieve.
So the key difference is the focus. Problem-focused conflict is good. Person-focused conflict is destructive.
But whether the conflict is beneficial or destructive, you still need a resolution framework. Let's look at the organizational approach to resolution. The sources outline 4 common methods companies use to structure this.
Method number 1 is company-wide policies and procedures. The idea is to create a one-size-fits-all rulebook.
Which sounds good in theory.
In theory. But the sources note this is often doomed to failure. And why? Because every project is unique, every conflict has specific circumstances, and project managers, who all have varying degrees of authority, they prefer to resolve conflicts in their own way. A blanket policy is just too impractical to account for that nuance.
Okay, so then you have method 2, which sounds much more flexible, project-specific planning.
This is far more effective. It involves planning for conflicts early on, maybe using specific project tools like linear responsibility charts. This allows each PM to develop specific rules and procedures tailored to their unique project environment and team structure.
We should probably pause and clarify what a linear responsibility chart is, because that's a key tool mentioned here.
Good call. It's essentially a table or a matrix that maps project tasks against the responsible individuals or departments. And it uses symbols like R for responsibility, A for approval, C for consultation, to clarify precisely who is doing what, who must be informed, and who has the authority to sign off.
So it preempts conflicts by establishing the authority lines in writing.
Right. It immediately cuts down on those who's responsible for this conflicts.
Okay. Method 3 is the corporate escape route, hierarchical referral.
Yes. The PM and the functional manager agree that their common superior has to resolve the conflict. This is often done to protect the company's best interest.
It sounds ideal on paper, a neutral arbiter.
But it's often unrealistic. The superior can't be expected to continually resolve lower-level issues. That's just not scalable. And what's more, requiring constant escalation gives the impression that the PM and functional manager can't resolve their own problems.
So it implies managerial inability and diminishes their standing with their own staff.
Right. And finally, method 4, direct contact. This is face-to-face resolution.
Which seems like the most straightforward.
It can be, but the sources warn that the risk here is twofold. One, individuals might suppress the identification of problems just to avoid that confrontation.
I can see that.
Or worse, they create new conflicts during the heat of the initial confrontation because they weren't prepared, or they just lack the tactical tools to handle the discussion professionally.
So once a conflict does occur, the PM has to adhere to a specific protocol.
Yes. They must first study the problem and collect all the available information. Then they need to develop a situational approach or methodology. I mean, you can't use the same approach for a schedule dispute as you would for a personality clash. And critically, they must set the appropriate atmosphere or climate.
And if a formal confrontation meeting is required, the sources detail the whole sequence of events. You start by setting the climate for willingness, then you analyze the images, how the parties see themselves and how they see each other.
That's a big one.
Then you collect information to get the underlying feelings out in the open, which lets you define the problem jointly. Then you move to sharing information and problem solving, getting cross-functional involvement and securing commitments. This is followed by developing the action plan, implementing the work, and most critically, following up to get feedback on how effective the resolution was.
That whole structure is the governance. But for the PM on the ground, they need the tactical toolkit, the 5 conflict resolution modes. And the selection of the mode has to be highly situational. It depends on the conflict type, the stakes, and the relationship with the other party.
Okay, let's dedicate some real time to these 5 modes, starting with confronting or collaborating. This is the face-to-face approach focused entirely on solving the problem, aiming for a win-win or integration.
This is really the gold standard because it seeks to find the underlying truth. You use confronting when the skills of the parties are complementary, when there's a high degree of trust already established, when there's enough time to do the necessary deep dive, or when the explicit objective of the meeting is to learn something new or find a fundamentally innovative path forward. It's time-consuming, but it yields the best results.
Okay, next is compromising. This is bargaining or searching for solutions where both parties leave with some degree of satisfaction, the whole give and take. The sources note that this mode is heavily debated. Is it a win-win since a deal was struck, or is it a lose-lose since neither party got everything they wanted, which could potentially damage morale?
That's a critical challenge. I mean, if both sides walk away slightly unsatisfied, isn't that inherently damaging to morale in the long run?
So when would a PM choose to compromise?
Well, you'd choose it when you simply can't win outright, when the other party is equally as strong, when time is short and a quick, moderate solution is better than none, or perhaps most importantly, when the stakes are moderate, but maintaining the ongoing working relationship is paramount.
So you sacrifice a little bit of the goal today for collaboration tomorrow.
Exactly.
Okay, third, we have smoothing or accommodating. This is about reducing emotions by emphasizing areas of agreement and consciously de-emphasizing disagreement. It sounds like a temporary fix.
It often is.
Yeah.
It's about keeping parties at the table. You're essentially willing to temporarily sacrifice your own goals to maintain harmony or to create goodwill with the other party.
So you'd use this when?
You'd use this when the stakes are genuinely low, when your liability is limited, or when you simply need to gain time, maybe to collect more data before a more formal confrontation. It's a tactical pause, not a permanent solution.
The fourth mode is the forceful one. Forcing or competing. This is imposing a solution, a classic win-lose situation. This happens more often the higher the conflict gets escalated, right?
Yeah.
When the superior just dictates the terms.
Yes, but you use forcing strategically. You use it when you are absolutely certain you are right, when a quick decision has to be made due to high risk, when the stakes are high and failure is not an option, a do-or-die scenario, or, importantly, when the relationship with the other party is genuinely unimportant, like a one-off negotiation with an adversarial vendor. Rule 1 of forcing: never start a battle you can't win.
Right. And finally, the fifth mode. Avoiding or withdrawing. This is often seen as temporary, sometimes even as cowardly, because it just postpones the inevitable.
It can be, but it can also be tactically useful. You use it when you know you can't win, when the stakes are so low that the issue isn't worth the energy, or, interestingly, to gain time when you suspect the problem is a symptom of a larger temporary issue and might just resolve itself.
Like what?
For instance, if a conflict blows up right before a major company deadline, avoiding it until that pressure subsides might be the wisest course of action.
What's truly insightful here is how the preferred resolution mode changes dramatically based on who the other party is. This highlights the continuous adaptability required of the PM.
Exactly. When you're dealing with your project personnel, your direct subordinates forcing and confrontation often have a favorable association with maintaining low conflict intensity.
Why is that?
Because clear, firm direction, or collaborating to find a solution, is what subordinates need and expect from their leader.
But the moment you're dealing with your superiors, the dynamic flips entirely.
Completely. Compromise is strongly preferred over confrontation, which is seen as strongly unfavorable. You just don't want to challenge the common superior face-to-face unless you have absolutely no other choice.
And what about when you're dealing with functional support departments, the people whose resources you need but you don't directly manage?
For them, smoothing is strongly favorable for maintaining low conflict. You have to maintain harmony and goodwill with those outside units because you will inevitably need their specialized resources again later, and forcing a resolution will just burn those bridges for good.
That makes perfect sense. And the PM's own influence style also contributes hugely to the perceived conflict intensity. The sources analyze several influence methods, and some of the results are highly counterintuitive.
Indeed. Certain PM influence methods are strongly favorable in reducing perceived conflict. Things like offering a work challenge or a promotion, but only if the PM actually has the authority to grant it.
Of course.
Friendship is also strongly favorable. These methods motivate collaboration and reduce friction because they focus on positive outcomes and mutual respect.
But look at what creates high conflict. Penalty power, authority, just relying on your rank and even expertise. Especially when dealing with superiors and functional support, those are strongly unfavorable associations.
That's wild, isn't it? Relying on your rank or how smart you are, your authority or expertise, actually makes conflict worse when you're dealing with those critical outside units.
Yeah, but why is that?
It suggests that highly technical or senior PMs can struggle because they rely too much on their superior knowledge rather than on diplomacy and organizational strategy. Relying too heavily on rank or punishment increases the perception that the PM is using force, which just heightens the conflict.
So, the effective conflict manager is someone who understands the organization, listens actively, clarifies the nature of the conflict, and then suggests fair, situation-appropriate procedures for resolving differences, all while maintaining the necessary relationships with the disputing parties.
They have to facilitate the process without imposing unnecessary authority. That's the key.
That structural approach to conflict resolution transitions perfectly into formal problem solving, because often the resolution of an interpersonal conflict is really just the first step towards solving a bigger technical or planning problem.
Right.
Problem solving, which is, understanding the issue, gathering facts, developing alternatives, and decision-making, selecting the best alternative, they have to go hand in hand.
And step 1 is clearly defining the problem. A problem is simply a deviation between an actual situation and the desired situation. It's an obstacle, a challenge, a difficulty.
But we have to remember that problems aren't always negative.
That's a great point. They can be formulated in a positive way, like how to take advantage of an unexpected opportunity, or a negative way, how to remove something bad, like a technical flaw or a budget overrun.
The immediate challenge facing any PM, though, is the environment of information overload. We all suffer from it, and it makes it incredibly difficult to figure out what data is truly critical to understanding the problem.
We can categorize information into two types to help manage this. Primary information is what's readily available. It's accessible from your desktop, existing documentation, or internal company documents. It's the easy stuff to get.
And the other kind?
Secondary information is often more critical, and it has to be collected from someone else, frequently from subject matter experts or SMEs. We rely on those SMEs to tell us what information is directly pertinent to the issue at hand, and just getting access to their time is a conflict in itself.
And timing is everything. The time constraint has the biggest impact on decision-making. The reality is that decisions often have to be made even though the PM only has partial information and might not fully comprehend the full complexity of the problem.
Waiting for complete information is simply not a luxury the team usually has, especially with fixed deadlines.
This creates a perverse incentive known as the problem of hiding problems. I mean, companies encourage quick identification, right? They argue that the faster a problem is exposed, the more time, alternatives, and resources are available for a solution.
But people often try to solve problems secretly, especially if they were involved in creating the issue in the first place, hoping to resolve it before anyone finds out.
And the reasons for the secrecy are really instructive about the high organizational stakes.
Yeah, they're afraid the client or stakeholders might overreact, dictating a bad solution, removing financial support, or even canceling the project entirely.
And there's the issue of proprietary or classified information disclosure, the very real fear that open identification may cause people to be fired.
Or damage the company's image and reputation, potentially leading to lawsuits.
That fear is critical. It turns a solvable issue into a massive political crisis. A technical challenge becomes an organizational catastrophe because someone was afraid to report the bad news until it was way too late.
So once we finally get the data out and the problem is identified, data gathering begins. And you can't just rely on a single technique. You have to select the right tool based on the information you're seeking, the criticality, and the type of decision it has to support.
Let's review some of the core data gathering techniques from the sources, comparing their specific strengths and risks.
Okay, let's take root cause analysis. Its strength is the in-depth, iterative analysis designed to prevent recurrence. It focuses on the cause, not the immediate symptoms.
But the risk is that it's highly systematic, which makes it very time-consuming.
Right. If you need a decision in 48 hours, root cause analysis is probably not the tool you want to use.
Okay, what about facilitated group sessions?
These are excellent for complex cross-functional processes where requirements need to be documented and verified immediately by a broad group of stakeholders.
But the risk?
It requires highly skilled, trained facilitators, and the time and cost of planning and executing those sessions, just getting everyone in the room at once, can be prohibitively high.
Then you have interviews.
Excellent for one-on-one sessions. They allow people to speak freely and enable direct, detailed follow-up questions. However, the risk lies heavily in the relationship dynamics between the interviewer and the interviewee.
Meaning people might be afraid that the truth, if it's negative, will be held against them, so they hide or shade the facts.
Exactly.
Okay, what about prototypes?
Prototypes are fantastic for generating innovative ideas and clarifying user needs. They're very client-focused and they really stimulate thought processes. But the risk is scope creep. The client may want to implement the prototype too soon, or the team may not know when to stop developing the prototype before moving to the actual product. You get this prototype perfectionism.
And you need specialized skills just to build the model.
Right. Now, finally, business process diagramming. This provides excellent visual communication, verifying what is and what is not in the current state of operations.
What the downside?
It's time-consuming, and crucially, it requires the organization to be genuinely open to the changes that the diagramming may reveal. If leadership isn't ready for systemic change, the diagramming just becomes an academic exercise.
So once we have the data, we need meetings, and the material distinguishes sharply between two types: problem-solving and decision-making.
The problem-solving meeting is focused purely on analysis, obtaining a clear understanding of the problem, collecting necessary data, and developing a comprehensive list of alternatives and recommendations.
And the attendees should only be those directly related to the issue.
Yes. For example, if the problem is procurement logistics, you should exclude drafting personnel or HR staff. You need the subject matter experts and the people who own the process.
But the decision-making meeting is fundamentally different.
It has to include all the problem-solving attendees, plus others who possess the absolute authority to commit resources, functional managers, stakeholders, or superiors. Stakeholder attendance is virtually mandatory.
Because the people making the decision must have the authority to commit the necessary resources, whether that's additional funding, reallocating high pay grade employees, or adjusting the scope document.
Exactly. Now, when you're evaluating alternatives, remember that the number of practical alternatives is always limited by the iron constraints imposed on the project.
For example.
If the project is desperately late, the alternatives might be limited to overtime, crashing the schedule, outsourcing a component, or scope reduction. If the goal is cost reduction, reducing scope might be the only viable alternative that doesn't sacrifice quality.
And the evaluation process itself has to consider several core variables beyond just cost and schedule.
That's right. You look at quality, making sure speed doesn't degrade the deliverable. You look at resources. Are the needed skills even available? Or will we have to hire externally? Feasibility, is it plausible on paper but impossible to implement in reality? And risks, future risks, or opportunities that will appear after the project is completed.
And we evaluate the features of those alternatives using classification. Must have.
Non-negotiable. Discard alternatives without it.
Should have.
Important, but might be omitted if satisfying constraints requires it.
And might have. Let's talk about those might have features. These are usually add-ons to enhance performance, often described as bells and whistles, which are part of a classic project phenomenon known as gold plating.
Gold plating is a massive PM pitfall. It's often driven by internal pride or ego, where the technical team adds might-have features the client didn't explicitly ask for, simply because they think the feature is cool or technologically satisfying.
And this just burns budget, increases complexity, and dramatically increases unnecessary risks.
Right. The classification process helps the PM ruthlessly prioritize and avoid that trap.
So once features and variables are classified, we move to prediction tools. The first one is the consequence table.
This tool measures the consequences of each alternative against the competing constraints: time, cost, quality, and safety. Imagine a large spreadsheet.
Okay.
Each alternative is a row, and the columns are your constraints. You then score or rank them, maybe qualitatively, favorable, unfavorable, neutral, or quantitatively say from +3 to -3.
So an alternative might have a highly favorable consequence on quality, scoring a +3.
But an equally unfavorable consequence on time and cost, scoring -2 and -3 respectively. This table forces the PM to visualize the immediate, necessary trade-off before execution.
The second tool is the impact analysis matrix. This plots alternatives by their overall impact, high or low, and their ease of implementation, easy or hard.
The obvious goal is to find alternatives that land in the low-impact TC implementation quadrant, but reality rarely provides that luxury. The matrix helps visualize the severity of the challenge versus the effort required to fix it.
So if an alternative falls into the high-impact, hard implementation quadrant,
You know immediately that you need to elevate that discussion to the highest decision-making level, as it's going to require significant resources and attention. Our deep dive now moves from problem definition and data analysis to the conceptualization phase, generating new ideas and implementing them. And it's crucial to draw a clear distinction between creativity and innovation.
Okay, so creativity is the ability to use one's imagination to come up with new and original ideas or things. The source material notes that expertise alone doesn't guarantee creativity, and specific training in creative thinking techniques is often lacking in technical organizations.
Right. But innovation, however, is the ability to convert a creative idea into reality, a product, a service, a deliverable that fundamentally creates value for the client.
So you can be creative without being innovative?
Any problem-solving team can come up with wild, creative solutions that simply cannot be implemented within the constraints. Innovation is the disciplined process that ensures the solution delivers real value, often balancing the client's needs with your company's strategic goals.
Sometimes the best path forward involves a hybrid alternative combining two existing alternatives.
That's a great technique. You might take a high-risk, low-cost solution A and merge it with a low-risk, high-cost solution B to find an acceptable middle ground, achieving an acceptable risk-cost factor that neither standalone option provided.
We also have to address the concept of negative innovation.
This is a painful realization. It's where the solution necessitates a reduction in value compared to the original requirements of the project. You're basically innovating downward.
And that can have a destructive effect upon the team. People might see a reduction in value or scope as damage to their professional reputation or their career prospects.
Managing the team's morale during negative innovation is absolutely paramount.
And if the internal innovative talent or capacity is lacking, the PM might pursue open innovation.
This is a strategic partnership with external entities. It involves sharing the risks and the rewards of the outcome, leveraging outside expertise that the core team may not possess.
The sources categorize innovation into 4 risk types, ranging from incremental improvements to existential endeavors. This helps PMs understand the true nature of the risk they're taking on when they choose an alternative.
The lowest risk category is add-ons, enhancements, and product improvements. These can often be accomplished quickly with existing resources, and they add incremental value without requiring a major deviation from the plan.
Then you have radical breakthroughs in technology.
This carries higher risk because the timing and cost are uncertain and value is not guaranteed until the breakthrough is confirmed. It might only require the skills of 1 or 2 focused people, but the outcome is highly volatile and could destabilize the schedule significantly.
The third type is new family members, the creation of entirely new product lines or services, which usually requires a technological breakthrough and is generally more complex than a radical breakthrough on an existing product.
And finally, the highest risk category, totally complex system or platform, next-generation projects. This is the moonshot.
Right.
If the complex system cannot be developed successfully, the project will likely be considered a total loss. This requires a large number of highly talented resources, deep integration across multiple systems, and failure is a very real, very expensive possibility. The risk here is existential for the project and potentially for the business unit.
So when you're facing those insurmountable problems that threaten cancellation, the solution might be strategic downsizing. Rather than folding, you readjust the innovation attempts to salvage the project and retain some core value.
This downsizing is typically forced by external factors like market shrinkage, the deliverable is just no longer needed, or internal factors like the deliverable being fundamentally overpriced, failure to achieve a technical breakthrough in a timely manner, or just a loss of enthusiasm from the client or internal management.
So downsizing allows the project to continue, provided the client accepts a formal, negotiated reduction in final value. To generate these innovative ideas, especially in the early problem-solving stages, we rely on brainstorming. The source materials is very clear on the 4 basic rules designed to maximize quantity and minimize inhibition, which we have to adhere to strictly.
Rule number 1, focus on quantity. Maximize possible ideas, both good and bad, on the assumption that the greater the number, the greater the chance of finding the optimal solution. Volume over quality, at least initially.
Rule number 2, withhold criticism. Criticism, especially early evaluation, creates internal conflict and wastes valuable time. When participants see ideas being criticized, they immediately tend to withhold their own ideas to avoid being judged or challenged.
Evaluation comes after the generation phase.
Right. Rule number 3, welcome unusual ideas. Encourage outside-the-box thinking. That seemingly radical solution that's initially dismissed may, upon later reflection, generate entirely new perspectives or even turn out to be the best possible solution in the end.
And rule number 4, combine and improve ideas. The final solution may be a hybrid. New ideas should be encouraged from the combination or modification of ideas already presented. This is where those initial radical ideas often become pragmatic realities.
This process brings us to the crucial role of the facilitator.
The facilitator is the protector of the brainstorming process. They help people communicate, keep the group on track, and ensure process adherence, all without taking a particular position on the content. They do not evaluate ideas. Their job is to ensure total, uninhibited participation.
And there's a major organizational risk if the project manager assumes the role of the facilitator.
A huge risk. The PM may, even inadvertently, try to lead the discussion toward the answer they want, especially if they have preconceived expectations or an existing bias.
And that's especially dangerous if the PM has wage and salary responsibilities for the people in the meeting.
Extremely. Participants will self-censor. They'll be afraid that their outside-the-box idea might be interpreted as incompetence or wasting company time, especially when budget and resources are being discussed. The facilitator must be neutral to ensure the idea generation engine runs efficiently.
We arrive now at the ultimate strategic challenge for any project manager, the trade-off analysis, which is perfectly encapsulated by the great conservationist John Muir, who stated, "When we try to pick out anything by itself, we find it hitched to everything else in the universe."
That quote perfectly describes project management. You cannot change one constraint, time, cost, or performance, without impacting the others.
Right.
Successful project management is the attempt to control resources within this competing constraint triangle. Deviations from the original plan, delta T, delta C, delta P, are inevitable, and trade-off analysis is the continuous thought process for managing those deviations at the highest level.
And these trade-offs are determined entirely by which constraints are fixed and which are variable. The source material provides a brilliant, structured categorization of these constraint combinations.
Let's start with the A category, where one element is fixed. Consider example A3, where performance is fixed. This defines most fundamental research and development projects.
Okay.
The final performance or outcome, the engineering goal, is rigidly defined. Time and cost, therefore, may be allowed to slip beyond the initial budget and schedule estimates to ensure that required performance is achieved.
So SpaceX prioritizing the engineering outcome over the initial budget would be a classic A3 scenario.
A perfect example. Conversely, look at example A1, where time is fixed. This is incredibly common for product launches or capital equipment projects, where time is of the essence to realize a return on investment quickly.
Missing a specific market window, say the holiday season for a tech product, is a death blow.
Exactly. Therefore, cost and performance might be adjusted, maybe using cheaper components or stripping features to maintain that critical delivery date.
Okay, now let's consider the B category, where two elements are fixed. This is far more restrictive.
Much more. Example B2 has time and performance fixed. This is common for defense contracts or critical infrastructure, where time is critical for rollout and hard performance metrics define safety and functionality. In this high-stakes scenario, cost is the only possible slippage factor. The budget must expand to absorb any problems required to meet the schedule and the technical specification.
And the most restrictive category, C1, three elements fixed. If time, cost, and performance are all fixed and non-negotiable, there is virtually no room for trade-off.
The project outcome is binary. Total success, achieved exactly as planned, or total failure, resulting in cancellation or massive penalty fees. This requires extraordinary upfront planning and risk management.
So what forces the PM to make these sacrifices? The forces can be categorized into internal and external pressures. The sources distinguish between inward forces and outward forces.
Inward forces represent internal pressure, and they're often caused by poorly written documents, ambiguous contracts, or specifications that didn't accurately reflect the company's capabilities. When these forces dominate, the PM tends to look for performance relief.
And the logic there is?
The logic is, the specifications were poorly written or misunderstood in the first place, so the PM argues to formally reduce the deliverable or the scope. It's an internal fix aimed at managing expectations based on bad initial documentation.
Okay, then outward forces dominate when operating forces go outward to the customer, when the external market, the client, or changing regulatory conditions create the pressure.
In this case, project managers tend to seek cost relief.
And why cost relief?
Because they must preserve performance and time to meet the customer's ultimate expectation or to maintain market viability. The customer doesn't care if your internal cost estimate was wrong. They care about the product delivery and functionality. Therefore, the internal budget has to absorb the shock required to meet those external demands.
This analysis really highlights that trade-off analysis isn't a one-time event. It's ongoing throughout the entire project lifecycle, influenced by that continuous internal and external environment.
And experienced managers recognize this. They keep predetermined trade-offs in reserve, ready to implement when a specific contingency hits.
We've truly mapped the complex project environment today. We moved from the core reality that conflict is inevitable, often structurally baked in by rigid resource allocation and imposed requirements,
Right for the start.
to the tactical toolkit of the 5 resolution modes: confronting, compromising, smoothing, forcing, and avoiding.
We detailed how to systematically approach problem-solving, contrasting problem-solving and decision-making meetings, and visualizing complex decisions using prediction tools like the consequence table and the impact analysis matrix.
And finally, we saw how creativity is converted into client value through the disciplined process of innovation, culminating in the high-stakes world of strategic trade-off analysis defined by that time-cost-performance triangle. The central realization here is that whether you are dealing with a personality clash with a functional manager, or navigating a massive budget overrun forced by inward-facing documentation problems, the best response is always rooted in structure, data, and planning. It's about taking the emotion out of conflict and applying a repeatable methodology.
Exactly. And we learned that conflict is not always a project failure. Sometimes it is meaningful and produces beneficial results when technical specialists challenge each other to find better data or innovate deeper solutions.
Yeah.
This raises an important question. If conflict is structurally inevitable, and sometimes even beneficial because it forces rigorous debate and superior outcomes, are we spending too much energy trying to eliminate conflict entirely, when perhaps we should focus entirely on becoming masterful at managing and channeling this powerful energy?
A profound thought to end on. If you can channel conflict, you stop managing chaos and you start managing progress. We hope this deep dive has given you a whole new toolkit for approaching the inevitable challenges in any major endeavor you undertake. We look forward to seeing you on the next deep dive. Welcome back to the deep dive. If you've ever managed, well, any kind of complex project, you definitely know the feeling.
Oh, yeah.
That moment when the whole beautifully constructed plan it hits the wall of reality.
Right. The supplier is late, the budget suddenly gets slashed, or, a key piece of tech just will not work the way it was supposed to.
Exactly. And it all boils down to this universal, just inescapable truth of project management. You can't have it all.
That's the triple constraint right there. Time, cost, and performance. It's like this eternal triangle of tension. For years, managers have faced that brutal conflict where one of those three legs just has to give.
And usually that decision gets made reactively, right?
Yeah.
The heat of a crisis.
Which almost always guarantees the worst possible outcome for the business. It's a panic decision.
Okay, so that's what we're moving past today. We're not doing that anymore. We've analyzed this really comprehensive project management framework that kind of takes the chaos out of these crises. It doesn't just, identify the constraints. It provides a systematic, really highly structured 6-step methodology for actually managing these conflicts.
And the goal really is to transform that moment of panic into a calculated strategic decision point.
So our mission for you today is to walk you through this entire framework. We're going from the initial diagnostic questions you need to be asking about, say, data credibility, all the way through to formal replanning.
And even understanding how external forces, like the type of contract you signed, might have already dictated your trade-off priorities before you even started.
And central to this entire discussion, the core principle that has to guide every single decision you make is the systems approach.
That's the absolute foundation.
Yeah.
The classic systems model. It involves this constant cycle of feedback, translation, analysis, trade-off, and then synthesis.
So what does that really emphasize?
It emphasizes the profound interconnectedness of every single element in your project. You have to recognize that your project is not an island. It's a node within a much larger organizational system.
So even if the problem seems really localized, like, okay, one supplier is a week late.
Right.
The systems approach demands that you analyze how that one delay cascades. It hits procurement, it hits your testing resources, it affects documentation.
And potentially, it affects the entire financial quarter for the company. The smallest change in cost or scope could easily affect all the planning, the processes, all the systems across the entire organization.
So the goal here isn't to rely on rigid, hard and fast rules, like always cut cost first.
No, absolutely not. The goal is to develop a structured, repeatable, and adaptable process for decision-making and for trade-off analysis. What we're doing here is building a methodology for systemic stability.
Okay, let's dive into that methodology, starting with the intelligence gathering phase. Step 1. Recognizing and understanding the basis for project conflicts.
Right. You can't start optimizing a failure until you've properly identified where it's coming from.
This is the diagnostic stage, then.
It is. Most organizations, they have cost and control systems that flag a variance. That's just the difference between planned performance and actual performance.
But that variance is only a symptom, isn't it?
It's just a symptom. The project manager's critical first job is to scrutinize the information that signaled the problem in the first place because, well, garbage in, garbage out.
We have to move beyond just seeing a red light on a dashboard metric. We need to be like investigative journalists about the data itself. So what are those core diagnostic questions a manager has to ask to verify there's a real crisis?
We group them into two categories, quality and source. First, data quality. Is the information pertinent and is it current?
What's the difference there?
Well, a budget report showing high spending from 6 months ago might be pertinent to the project, sure, but if you're making a decision today, it is not current.
You need real-time data.
You need data on resources you consumed yesterday. Then you have to ask, are the data complete? If you only have partial material costs, but you haven't factored in the rising labor rate, your data is incomplete and you are operating completely blind.
And that second set of questions, the ones about the source,
Yeah.
that's often overlooked, but it feels critical. It stops the manager from just accepting secondhand anxiety as a fact.
Oh, absolutely crucial. You have to trace that data point back to its origin. Who determined this situation exists, and how do they know this information is correct?
Right. Did a technician on the floor just mention a delay in passing, or did the quality assurance department formally document a failure?
Exactly. Verifying the source dictates the credibility of the information. If it's a rumor, you ignore it. If it's a formal deviation report, you act on it.
And once we've verified the quality and the source, then we get to the so what.
That's the implications question. What are the actual implications for the project if this information is true? This is where you calculate the magnitude.
So, does this delay knock a non-critical activity onto the critical path? Or does the cost overrun trigger some kind of contractual penalty?
Precisely. This ensures you are reacting to the actual risk, not just the raw variance number on a spreadsheet.
Okay, so we've verified the data. Now we move to categorizing the causes of the conflict. The idea is that understanding the disease category determines the necessary cure, or in this case, the necessary trade-off.
And the sources break these causes into three pretty distinct buckets. The first bucket is human errors or failures.
These sound preventable.
They usually are. They stem from poor management or execution. Examples would be accepting impossible schedule commitments right at the very beginning of the project.
Or poor control of design changes during execution, poor cost accounting that hides the true burn rate.
Or even specific mechanical failures and test failures that just point to poor quality control. These are fundamentally process breakdowns.
Okay, so the second bucket deals with the uncertainty that's just inherent in the business environment. These are the uncertain problems.
Right. These are known risks, but with unknown timing or impact. This includes structural issues, like having way too many concurrent projects across the organization, which that inevitably leads to resource contention.
So something like a labor contract expiring, you know it's coming, but you don't know if there'll be a strike.
Exactly. Or changes in project leadership that destabilize momentum, or even the real possibility of project cancellation hanging over the team. These are all factors you can estimate the risk for, but you can't just schedule their occurrence on a calendar.
And finally, the really disruptive bucket, totally unexpected problems. These are the true black swans that force an immediate, radical reevaluation of the triple constraint because you just couldn't have reasonably anticipated them.
This is where things get genuinely stressful. It includes things like overcommitted company resources that were approved without the project manager even knowing.
Conflicting project priorities that come down from top management out of nowhere.
Or external shocks, like cash flow issues suddenly hitting the company. Or unforeseen delays in material shipment because of global events.
I want to focus on this one specific kind of fascinating example mentioned in the sources. Fast track, people being promoted off the project. Wait, how? How does someone's career success cause my project to fail?
It is so counterintuitive, but it's highly destructive. So when you identify your high-performing, high-potential individuals, your fast-track talent, they often have this deep, specialized knowledge in a specific work package.
Okay.
If top management promotes them off your project halfway through to fill a corporate need somewhere else, you immediately lose that institutional knowledge, that specialized skill set, and often a critical internal champion for your project.
And the person who replaces them, even if they're competent, needs time to ramp up.
Which leads directly to time and cost overruns. It creates this vacuum of expertise that forces an immediate trade-off, usually involving a reduction in time or performance, just to mitigate the loss of that key person.
So understanding which of those three categories your problem falls into error, uncertainty, or unexpected event is absolutely critical. You treat a process failure, a human error, totally differently than you treat a sudden cash flow crisis, an unexpected problem. That structural diagnosis leads us directly into the planning refresh. Step 2 is reviewing objectives. So if step 1 was diagnosing the immediate illness, step 2 is like rereading the patient's initial medical chart.
That's a great way to put it. The project manager needs a complete review of the objectives as seen by all participants.
Not just their own view.
No, because misalignment of objectives is a silent killer. The project manager has to ensure that top management, the sponsors, functional managers, and the individual team members all have the exact same definition of success.
Because if the tech team thinks the goal is maximum performance, but management's goal is first to market,
the resulting tension is absolutely inevitable. Someone is going to be unhappy.
and the original objectives, they determine this crucial rigidity factor for the trade-off?
Exactly. The initial goals determine how much elasticity, how much stretch there is between time, cost, and performance. If the original objective, maybe it was even stated in the contract, was launch on the exact day the competitor launches, regardless of marginal cost increases,
Then your schedule constraint is incredibly rigid.
it's rock solid. You immediately know that any variance will likely be absorbed by increasing costs or cutting performance. Knowing that rigidity factor really limits the trade-off options you have available later on.
So what key foundational documents does the project manager need to pull out and verify at this stage?
Well, they need the initial project objectives, obviously, but also how that project was integrated into the sponsor's overall strategic plan. You have to ask, is this project even still strategically relevant?
That's a big question.
A huge one. They also need the detailed statement of work, ESOW, the precise schedule, cost, and performance specs, and a hard look at the resource projections. What was supposed to be consumed versus what was actually consumed.
Because if the project's strategic value has dropped, the decision might not be a trade-off at all.
It might be termination.
All right, let's move into step 3, analyzing project status. This is where we go beyond that variance report and we conduct a forensic examination of the project environment.
Right, focusing on project results, problems, and roadblocks. And the sources are very clear on this. This must avoid becoming a witch hunt.
It's investigative, not punitive.
Because blame just delays action. This analysis requires looking at factors well beyond the immediate project metrics, what we call the environmental factors.
What falls under that complex umbrella?
We're talking about the surrounding business context.
Yeah.
What is the current financial risk to the company as a whole? Is the company in a cash crunch? What is the status of other concurrent projects?
Right, because if 3 other projects are failing, your project might be deemed less expendable.
Or, conversely, it might have its resources rated to save the others. You also have to consider the potential for follow-up contracts. Is this project a loss leader designed to secure massive future business?
Ah, okay. If so, then performance and customer satisfaction become basically non-negotiable regardless of cost overruns.
Exactly.
This environmental analysis, then, it necessitates an extensive stakeholder assessment. It means getting out of the office and actually talking to people.
It absolutely does. The manager must consult the project management office, the PMO, to get a management assessment on the relative priorities of time, cost, and performance, and the impact on the firm's overall profitability and strategic plan. You need their macro view.
And there's this crucial strategic friction with the internal functional managers, isn't there?
This is a major source of roadblocks. If the engineering or procurement department is also running critical operational tasks, you have to gauge where your project sits in their priority list.
Because if they routinely assign their A team to internal operational duties and you get the B team or part-time staff,
That is a fundamental resource commitment issue. The project manager needs to assess this and potentially counter that resource distribution later in step 5, but without escalating the conflict prematurely.
tactically, maybe the most important part of step 3 is the work package deep dive.
This is granular data review. You have to get clear, detailed appraisals from the people responsible for 3 specific metrics for each project work package: the time to complete, the cost to complete, and the actual work to complete.
You're validating the remaining work.
You are. And furthermore, you must look at past performance data. If the estimates provided by a specific functional team were consistently, say, 30% low in the past, you cannot trust their current projection. Your diagnosis is flawed if you do.
So we've found the variance, we've drilled down into the environmental and work package levels. Now we have to identify the why, the suspect areas, to avoid just curing the symptoms.
The sources highlight 5 common suspects here. First, inadequate planning. This just means the initial schedule lacked sufficient detail, or the controls you needed to track against the approved plan just weren't established. You weren't measuring the right things.
Second is the classic project management catastrophe, scope changes.
Or scope creep. Allowing it without formally incorporating it into the project plan or adjusting resources is a documented promise to fail. Cost and schedule overruns are the normal result.
Not the exception.
No. The source emphasizes that even minor changes, if they're not formally baselined, erode the integrity of the entire plan.
The next category is fascinating because it involves performance issues that can be either poor or too good.
Correct. Poor performance by an individual is obvious, but excess performance is the sneaky danger. This is the gold-plating problem. An overzealous team member might unintentionally distort the plan balance.
How so?
They might over-engineer a database to handle 10 million transactions when the specification only required 10,000.
Sure, they met the performance spec, but they blew the cost and schedule by months and introduced a ton of unnecessary technical debt.
This is why strict adherence to the SOW is so critical.
Absolutely.
And the final two suspects deal with the outside world and structural issues. Right, we have environmental restraints, which are delays caused by external parties, third-party approvals, regulatory bodies, or just non-performance by outside resources. And the fifth suspect area is often the cause of the others. Inaccurate or non-existent control systems, which just makes tracking and predicting anything incredibly difficult.
Before we wrap this analysis, let's explore the perception trap. The source notes that some projects appear to be out of tolerance when in fact they're operating exactly as planned.
This is so vital for managing your stakeholders. It often happens in large construction or infrastructure projects that are intentionally front-loaded with costs.
What does that mean, front-loaded?
It means major expenditures like deposits for specialized long lead time machinery or massive early investments in specialized staff training and site preparation are all clustered at the very beginning of the project.
So if you look at the cumulative spending curve versus the earned value curve in those early phases, the cost line is going to be way above the value line.
Right. It's going to look like a major discrepancy or a huge cost overrun.
And the danger is that a project manager who only looks at the raw numbers, that negative variance, might panic.
They might panic and initiate a costly, completely unnecessary trade-off, like slashing resources or reducing scope, when the project is actually on budget for its planned cash flow.
So the manager has to understand the planned cash flow to avoid starting a crisis response to a planned activity.
Exactly. This deep dive into the initial financial model is absolutely required to separate a legitimate variance from intentional front-loading.
We've moved from intelligence gathering in steps 1 through 3 to the strategic action phase. Step 4 is where it gets really interesting, generating and analyzing alternative courses of action. We're moving from diagnosis to generating viable solutions by brainstorming compromises across time, cost, and performance.
Right. And the goal here is to refine that brainstorming into maybe the 3 or 4 most strategically sound scenarios for project completion. And to do this, the project manager needs rock-solid, specific answers to critical questions in each of those constraint areas.
And focusing on the long-term strategic damage, not just the quick fix.
Yes, that's key, not just the short-term fix.
Okay, let's start with the questions about time. If we accept a schedule delay, what do we have to quantify?
We have to ask, is a delay even acceptable to the customer? What is the cost associated with a new schedule? Not just labor, but management overhead, facility costs, and potential liquidated damages.
And crucially, how will the delay hurt the company's ability to get future contracts?
Absolutely. If this delay impacts the customer's key strategic launch, the political cost could be astronomical, and it could outweigh any savings you get from the delay.
Now for cost. When an overrun is staring us down, what are the key financial and strategic questions?
The first question is always, what is the root cause of the overrun? Then, if we decide we have to absorb the extra cost, do we use internal reserves or do we go looking for new funding?
Can we maybe renegotiate the time or performance standards to stay within the original cost?
That's a great question to ask. And will increased funding provide net value gains? I mean, will the extra money actually speed things up or improve quality, or are we just throwing good money after bad in a failing process?
And finally, performance. This is often the easiest thing to cut, but the long-term risk here is arguably the highest.
It is. The questions here are inherently legal and technical. Can the original specifications even be met? If not, at what new cost can we guarantee a reduced but still acceptable level of compliance?
Are the specifications negotiable at all? Maybe because the original requirements were gold-plated or just excessive?
You have to ask that, but most importantly, will a change in performance, a reduction in structural integrity, a cut in safety testing, or reduced component longevity, will that incur product or employee liability? Because that liability risk absolutely outweighs any short-term schedule fix.
Okay, once we have these answers, the systematic approach demands we move from these abstract concepts to a concrete visual analysis. The framework uses graphical methods to analyze alternatives, which usually requires one parameter to be held fixed. Let's walk through these 4 analytical situations.
This graphical analysis is really where the art of trade-off becomes a science.
Okay, situation 1. Performance is held constant. The product must meet the specs. So in this case, cost is expressed as a function of time. We compare the target cost and time against the actual completion curve.
So we need to visualize 2 distinct scenarios here. Curve A illustrates the idea that time is money. If the project runs longer, the cost increases linearly. That's usually due to accumulating management support time, lease costs, standing charges.
But curve B is more complex. It shows plateaus in the cost curve. Tell us about the plateaus. Why would costs occur in steps like that?
Okay, so the plateaus indicate periods where increased time does not immediately lead to increased cost. Imagine a construction project where you're pouring concrete. You pay the labor and material costs initially, but then you have to wait for it to cure. Whether you wait 7 days or 14 days, your specific material cost doesn't change during that waiting period.
But once it's cured, you move to the next step. You need new resources, and the cost jumps up instantly.
Exactly. And the critical insight here is that the optimal trade-off decision points, where you pay the least for schedule optimization, are at the end of those plateaus, not in the middle.
If we need to shorten time while keeping performance fixed, the framework outlines 4 methods to analyze and shift those time cost curves.
Right. First, you can add resources. This often results in that curve A costs spike very quickly. This is the classic throwing bodies at the problem, which often creates control problems or poor coordination.
The Matin effect.
Exactly.
Yeah.
Second, you can redefine the scope of work. This means smart deletions removing non-core functionality, unnecessary documentation, or excess design features that don't affect the core performance requirements.
Third is shifting resources.
This is just effective replanning. You identify non-critical activities that have some float, and you shift their resources to the critical path activities that are currently behind schedule. It's a zero-sum balancing act to keep the project flowing.
And finally, number 4 is changing the logic diagram.
And if you're truly desperate for schedule reduction, you might convert serial work efforts to parallel work efforts. You're essentially doing tasks simultaneously that were planned to be done one after the other.
And that's risky.
The source warns this is highly risky because it exponentially increases interdependency and requires absolutely flawless coordination.
Okay, moving to situation 2. Cost is fixed.
Yeah.
The budget is absolutely immutable, so performance has to vary as a function of time.
This is where performance starts to become elastic, right? If your performance is nearly perfect, say 98%, but achieving that last 2% would require 3 extra months.
The company may strategically opt to just deliver the 98% quality on time, rather than risking the additional time for marginal gains.
Right, assuming that 98% still meets the minimum contractual requirements.
However, the framework warns really strongly against the risk of performance sacrifice.
Because performance is the easiest thing to cut. You skip a test, you use cheaper materials, you simplify a component. But degraded performance often leads to massive, hidden long-term costs.
So?
If the product requires increased maintenance, if it fails prematurely, or requires expensive rework in the field, the total project costs, when you view them over the product life cycle, actually go up. You save $1 today, you spend $10 on warranty claims tomorrow.
And speaking of real costs, the source lists several common overlooked items that drive up costs when contracts are fixed cost. These are often administrative or contractual things.
Yeah, these are bureaucratic traps. They include demands for excessive detailed reporting or unnecessary documentation, which just eats up valuable high-skill labor hours.
It also includes developing detailed specs for equipment that you could just buy commercially off the shelf for much less.
Or even using the wrong type of contract entirely. If you use a fixed-price contract for an exploratory research project, the organization will inevitably absorb massive, unexpected cost overruns because the risk was unquantifiable from the start.
Okay, now for situation 3. Time is fixed. The deadline is immutable, often dictated by external forces, and cost varies with performance.
This scenario is common when a component is part of a larger, critical assembly. The source uses this vivid example of a single aircraft pump delaying the engine manufacturer, the airframe manufacturer, and the ultimate customer.
This is the definition of the political cost. When a small failure creates these massive, cascading downstream financial and reputational damages,
the resulting financial losses can be astronomical. And the emotional damage, those irate vice presidents in the customer shop, that can kill future contracts out of all proportion to the real technical failure.
The longest memory in business belongs to the customer who incurred huge, unanticipated consequential damages because you were late.
Exactly. And when time is fixed, the power of early warning is immense. Early notification to the customer of a time overrun, even partial notification, can greatly mitigate the damage and increase their willingness to negotiate versus just a surprise failure at the end.
But there's that fascinating strategic insight here about flexibility that the project manager has to seek out.
Yes, we have to remember the customer is running a system too. Sometimes, even though the contract says time is fixed, there may be latitude without actually inconveniencing the customer.
Why is that?
Because the customer's entire program, of which your project is just one small part, might be running behind schedule anyway. They aren't ready for your specific deliverable yet.
So that creates an unseen scheduling buffer.
It does. And if you, as a project manager, have deep ethical coordination with the customer, you can anticipate and exploit this buffer. You can strategically negotiate a schedule extension that benefits both of you.
Turning a potential failure into a strategic negotiation advantage.
Exactly. You turn the customer's problem into your solution.
And finally, situation 4. No constraints fixed. Everything is negotiable.
This is the most complex scenario because you are analyzing a three-dimensional problem. You move from simple curves to using parametric curves or a family of curves that analyze cost, time, and performance all at the same time.
And you might identify several different cost paths that achieve the same technical result at different times.
Right. The final path you select depends heavily on the contractor's tolerance for risk and their long-term strategic goals.
Before we move on, let's just reflect on how priorities shift over the project lifecycle, as the framework illustrates.
They're very dynamic. At project initiation, especially in early R&D phases, cost may be less important. While performance and schedule are absolutely critical, you have to secure the technology and that initial market window.
But as the project nears termination,
Especially if it's a product designed to generate profit, the relative importance of the cost constraint increases drastically as the organization tries to recover its massive investment and realize the profit margin.
the performance and schedule impact usually decrease in relative importance at that final stage.
Right, as long as the minimum standards are met.
We've diagnosed the problem, we've generated and analyzed the solution curves. Now we're at step 5, selecting an alternative. And this choice can't just be the cheapest or the fastest option.
No, it must minimize the overall impact to the company. That means we have to look beyond short-term financial results and consider long-term strategic and market considerations.
That holistic view is non-negotiable then.
It is. And the selection process requires formality. Project managers have to prepare formal update reports detailing alternative work scopes, schedules, and costs. You lay out the scenarios for minimum cost overrun or minimum schedule overrun.
And those reports should include the analysis of the graphical models we just talked about.
Yes, they should.
And the decision needs structured support. What decision tools does the framework recommend here?
The manager should construct a decision tree. This tree includes the costs, work objectives, schedules, and, critically, an estimate of the probability of success for each condition leading to that final decision point.
And then you present that limited set of alternatives and their probabilities to top management for the final selection.
Exactly.
Management needs a systematic way to evaluate these impacts across the whole organization. What criteria should be on their evaluation checklist?
So management has to ask, will other concurrent projects be negatively affected? Will this selection require expensive rework in previous tasks? What's the long-term effect on the project life cycle? Will maintenance or repair become more difficult?
And what about the effect on key employees and, most importantly, the customer?
Yes. If a decision, like reducing performance, jeopardizes a key strategic client relationship, it has to be discarded immediately, regardless of the short-term cost savings.
The sources outline 2 common methods for comparing these alternatives: weighting and using a common denominator. Let's start with weighting.
Weighting involves assigning numerical weights to various organizational objectives, like, say, increasing future business gets a 40% weight. Maximizing immediate profit gets 20%, or meeting current specs gets 40%.
And then you assess how well each proposed alternative satisfies those weighted objectives.
Right.
But the framework offers a really strong caution here, suggesting this method can often add mass confusion to the already confused process. If that's true, why is it even taught in management science?
It's taught because mathematically it offers a structure for considering multiple qualitative factors at the same time. But it causes confusion because the weights are inherently subjective.
Who decides that future business is worth 40%?
Exactly. And what happens if that weight changes next week because of a market shift? It allows managers to justify a preconceived answer by just manipulating the weights, making the decision look rigorous when it is purely subjective.
So for this reason, many experienced project managers prefer the second method.
Which is the lowest common denominator method.
Right.
This approach attempts to equate all alternatives to dollars. You convert capital equipment, time, resource consumption, all into a monetary value. It ensures you're comparing apples to apples on a financial basis.
And it makes the final decision look clear and quantifiable.
It does.
However, this method brings up the most serious ethical and moral dilemmas of project management.
Absolutely. The difficulty arises when you have to assign dollar values to non-monetary moral imperatives. How do you quantify employee safety standards? How do you assign a monetary value to minimizing environmental pollution?
Or, in the most extreme cases, assigning a dollar value to the possible loss of life due to a performance cut.
Right. These essential moral and liability factors, they resist simple dollar conversion. When cost is the lowest common denominator, the manager has to understand that sometimes the financially optimal choice is the morally unacceptable one. And that's a decision that must be escalated to top leadership.
Once the alternative is selected, we move to actionable corrective action options. What are the general remedies available to the project manager?
The list is pretty comprehensive. Overtime, double shifts, expediting material procurement, adding manpower, changing vendors, changing specifications if that's acceptable.
Shifting project resources, using outside contractors, providing bonus payments to motivate speed,
Or even aggressively single-sourcing materials to reduce supply chain complexity, even though that increases your dependency risk.
But let's get specific. What are the specific, actionable alternatives for manipulating the schedule?
Okay, if the project used PRT-CPM scheduling, you can prioritize all the tasks to see the effect of eliminating low-priority efforts on the critical path. You should immediately implement resource leveling.
Which is...
That's identifying non-critical resources that have some slack time and shifting them to activities that are now on the critical path because of the variance. You also have to reassess time estimates by carrying the work breakdown structure, the WBS, down to one more level of detail. Challenge every single remaining estimate.
And for performance manipulation.
The goal here is smart cost reduction that minimizes liability. You can ease excessive or tight specifications that are not critical to the project's success. For example, removing unnecessary standard military specs if the project is for commercial use.
You could alter testing requirements, maybe using accelerated life testing to simulate longevity faster and minimize costs.
And crucially, you should set an absolute minimum acceptable performance requirement, a floor below which you will not pursue the project because the liability or reputational risk is just too high.
Now we get to the most brutal section of the framework, when a pragmatic, detailed analysis shows that no action can save the triple constraint. This is the stop-loss viable alternative stage.
This happens when the cost of completion exceeds the value of the completed product, or when compliance is just technically impossible within the bounds of the current contract. Only two general options remain. First, a formal renegotiation of project performance criteria with the sponsor, based on a view of what is now acceptable. This involves professional and serious legal liability concerns for everyone involved, because you are altering the fundamentals of the contract.
And if renegotiation fails or isn't viable, the only remaining option is stop-loss completion planning, where the organization is basically just seeking to defend itself and minimize overall damage.
And this leads to four highly risky choices. These choices are about minimizing one specific type of failure at the cost of maximizing others.
So the first high-risk choice is completing on schedule to the minimum quality level required.
Right. This maximizes your financial loss through cost overruns, but it delivers the product on time, securing the schedule and minimizing those consequential damages from the customer.
The second is controlling cost and performance, but permitting the schedule to slide.
This saves the budget and the integrity of the product, but it risks massive unhappiness with the sponsor, potential loss of future work, and exposure to consequential damages if the client suffers financial losses from your delay.
And the third high-risk choice is the most dangerous path, maintaining schedule and cost by allowing quality to slip severely. Why does the source material suggest this has the highest probability of total failure?
Because if the final results are below the absolute minimum standards, If the structure fails, if the component burns out immediately, all the quality work and investment you've done previously is instantly lost. This high-risk approach essentially guarantees the failure of the end product, and with it, the failure of the project manager's reputation and the company's image.
And the fourth option is horrifying, seeking impossible results. The source material calls this hoping that the inevitable won't happen.
This is pure, reckless denial. Management continues to fund and drive a project that is mathematically doomed. It offers the opportunity to fail simultaneously in all areas: cost, schedule, and performance.
And in this highly reckless scenario where integrity, safety, or contractual obligations are knowingly compromised,
The source material explicitly warns that criminal liability could become an issue for the management involved, especially in fields related to public safety or structural integrity. The final, slightly safer stop-loss option is just immediate project cancellation, which limits financial exposure but usually terminates the project manager's career.
moving quickly to step 6, replanning the project. Once that painful alternative has been selected, the project manager has to get top management approval and secure total commitment to the new course of action.
This is so critical. Top management has to approve because their decision is based on factors beyond the project manager's control. Things like the firm's long-term policies on quality, integrity, and image.
The ability to develop long-term client relationships, current cash flow requirements, projected ROI.
And their assessment of competitive or technical risks. All things the project manager doesn't see.
And the final commitment must be total.
Yes, the entire management, team top management, functional managers, and the project managers must be publicly and privately committed to achieving the revised plan. That means signing off on new schedules, revised work breakdown structures, and establishing new performance benchmarks.
Because if management approves the plan but then fails to commit the necessary resources or executive support,
The trade-off was meaningless, and the failure will simply be delayed.
we've covered the entire internal methodology. But the source material makes it really clear that the specific decision, what is sacrificed first, second, or third, is heavily dictated by external influences.
Right, namely the contract type and the industry you operate within.
The contract type is, in essence, a pre-programmed trade-off algorithm.
It is. It defines the sequence in which the constraints must be sacrificed because it allocates risk between the parties.
Okay, let's look at the standard FFP, firm fixed price contract.
In an FFP, time, cost, and performance are all specified, and the contractor assumes all the financial risk. So to protect their reputation and avoid legal damages, the contractor generally tries to deliver the specified performance on schedule.
So the sequence sacrificed is cost. First, you just absorb the loss.
Then time, second, you slide only if you absolutely have to, and performance, third, you sacrifice it only as a last resort because failure to perform means you fail to fulfill the contract.
This flips completely when we look at incentive-based contracts like FPIF, fixed price incentive fee, or CPIF, cost plus incentive fee.
Oh, the game changes entirely. In these contracts, cost control is explicitly measured to determine the incentive fee. That's the contractor's potential bonus profit.
So if cost is the metric for your bonus,
It becomes the asked constraint you are willing to sacrifice. You will prioritize schedule and performance over absorbing the cost overrun.
so the sequence becomes time first. You sacrifice the schedule earliest to save money.
Then performance second, and finally cost third. It is protected at all costs to maximize that potential incentive fee.
And the CPAF, cost plus award fee contract, is unique again.
It is. Here, costs are reimbursed, but the award fee is based on performance criteria, which often relate to quality or mission success. Because costs are reimbursed, the contractor has minimal risk there.
Making cost the first constraint considered for a trade-off.
Exactly. And performance, because it drives the award fee in future business, is the last constraint to be sacrificed. So the sequence is cost first, time second, performance third. Understanding your contract type is half the battle in predetermining your strategic trade-offs.
Let's look at industry trade-off preferences. These priorities vary dramatically across sectors because of different funding models and core missions.
Right, take nonprofit organizations. They rely on restricted funding from donations or grants. Funding is the strictest constraint because cost overruns are generally prohibited and time constraints for grants are often fixed.
Performance is the first resource compromised.
It is. And this is often compounded by relying on inexperienced staff or volunteers, which can lead to poorer customer service delivery despite meeting cost and time targets.
What about the banking industry? This is counterintuitive, as we learned earlier. They sacrifice cost first.
Yes, in banking, Cost is typically the first resource sacrificed, even in non-regulated projects. And the strategic reason is fascinating. Banks often lack accurate, quantitative internal cost estimation of their actual service delivery.
They don't know what things really cost.
They often rely heavily on aggregated data, like functional cost analysis from the Federal Reserve, which might be inaccurate for their specific service. Lacking reliable cost data, they'll prioritize time to meet regulatory compliance and performance to secure market share.
And if competitors launch a new superior service, time becomes less critical than performance.
But cost is still sacrificed first to ensure they can deliver the necessary technical capability.
And finally, the culture of non-project-driven organizations, which you typically find in large manufacturing or utility companies.
In these companies, new projects take a clear backseat to day-to-day functional operations. The money is allocated to departments, like engineering or manufacturing, not to the project itself.
And the functional managers emphasize operations and maintaining production levels over project deadlines.
Exactly. Therefore, time is the first resource sacrificed. Projects slide constantly because they are a low priority. Budgetary constraints outweigh performance criteria, so cost is actually the last to be sacrificed to protect the department's budget over everything else.
That's a total inversion from a project-driven organization like aerospace, where time and performance during the early conceptual phases are everything.
It's completely different. And even within those project-driven organizations, the trade-off priorities change by life cycle phase. In the conceptual and definition phases, performance and time standards are primary for securing the contract, so cost is often the first to be compromised. You'll spend extra on R&D.
But once the product moves into the operational or construction phase,
Cost control increases drastically in importance as the organization desperately tries to recover its initial investment and realize the profit margin.
this has been an incredibly rigorous analysis of the systematic process required to manage project conflicts. Our final synthesis, I think, is clear. The project manager's role is far beyond just tracking three constraints.
Absolutely. It's about applying superior managerial skill and really emotional intelligence to bring stability in profoundly adverse conditions.
The triple constraint: time, cost, performance. That's just the starting point.
It is. True trade-offs in modern project management involve competing constraints like quality, image, long-term risk exposure, reputation, goodwill, and legal liability. It requires a combination of process adherence and keen interpersonal relationships to manage the team and reassure the sponsor while you're executing these complex decisions.
We've spent time today discussing the graphic analysis, the plateaus, the curves, but we have to always remember that buried deep within that technical data is the human element. And that crucial strategic insight we discussed. Sometimes the customer schedule is actually your biggest ally.
Yes. The source material mentioned that often, even though the schedule is supposedly fixed in your contract, there may be latitude without inconvenience to the customer because their own massive program is running behind.
Which leads to our final provocative thought for you to chew on.
How can project managers ethically leverage deep, consistent coordination and transparency with the customer to anticipate and exploit this unseen scheduling buffer, turning a potential failure into a strategic negotiation advantage?
That requires building trust before the crisis ever hits.
So you can ask the right questions about their internal readiness when your own project is struggling.
That requires going beyond the contract and building a genuine partnership.
Excellent point. Thank you for diving deep with us today.
My pleasure.
We'll catch you on the next deep dive.
Welcome to the deep dive. If you're here, you're looking past the headlines and straight to the strategic core of what truly drives performance. Today, we are undertaking a deep dive into the absolute revolution happening in project performance measurement. And it really is a revolution.
It is.
Not long ago, say 20 or 30 years, the mere fact that a company used a formalized project management methodology was enough. It was the competitive advantage.
It really was. You were ahead of the curve just by having a Gantt chart.
But today, PM is universal. Everyone has the tools. So what separates the truly high-performing, successful organizations from the ones that are just, going through the motions?
Well, that's the thing. It's the sophistication. It's the forward-looking way they measure their efforts.
And it seems like it's a huge shift from what we used to do.
Oh, absolutely.
Yeah.
That's the strategic heart of the change we're tracking. Historically, the entire discussion of project success revolved around two very simple metrics: time and cost.
Right. Always time and cost.
They were the default standard because, frankly, they were the easiest to quantify, the easiest to report on an audit.
So convenience over value.
Exactly. The industry knew this was incomplete. I mean, it missed the whole point of why the project was launched in the first place. But we were constrained by technology and, by the existing methodology.
But we've moved past that.
We've moved far beyond those simplistic constraints. We are transitioning from simply being good at project management to achieving genuine excellence. And this excellence is driven entirely by how robust, how actionable, and how strategically aligned our measurement metrics have become.
And that is exactly our mission for this deep dive. We need to unpack how exponential advances in technology, specifically modern project management information systems, or PMIS,
Right.
integrated seamlessly with enterprise resource planning, ERP, are fundamentally transforming how we collect data and, more importantly, how we use it. We are trading in the seat-of-the-pants guesses that used to define executive decision-making for true evidence-based facts. We're going to focus specifically on metrics related to value, risk, reputation, and, of course, customer satisfaction. Let's jump in.
So let's start with that foundation. We have to acknowledge the historical inadequacy of those traditional metrics. If time and cost were the default only because they were easy, what did that omission actually cost companies?
It cost them alignment. A project could finish exactly on time and, exactly on budget. But if the market had shifted in the meantime, or the final product was just irrelevant,
The project was still a failure.
a complete failure from a business perspective. The measurement system just failed to capture that value dimension. It was a blind spot.
So what are the new non-negotiable measurement areas today? What do stakeholders demand now?
Today, a successful system has to incorporate a much, much broader range of metrics. We're talking about tracking the expected benefits from the initial business case.
So what we thought we were going to get. Right. And then tracking the actual value created and realized over time.
Right.
And beyond that, safety records, project risk exposure, detailed customer satisfaction ratings, and, yes, even those notoriously difficult intangible factors like brand image and corporate reputation.
And I imagine the stakeholders are much more savvy about this now.
Oh, absolutely. Stakeholders today, from the CEO down to the client, they're far more educated about project management. They've seen projects succeed on paper but fail in the market, so they demand this holistic view of success.
This sounds like an enormous amount of data to collect, synthesize, and then report on. It really underscores why the technology, the project management information system, the PMIS, is so crucial. Can you flesh out what a PMIS is beyond just, the software platform?
That's a great question, because it's so much more than that. The PMIS is, you could call it the technological nervous system of the project.
I like that.
It is the central repository of all essential and supporting information that covers the entire project lifecycle. And I mean everything.
From the very beginning to the very end.
Exactly. From the initial charter approval and the detailed planning phases, all the way through execution, monitoring, control, and then the final closure. It's far more than a simple scheduling application.
So earned value is in there, but it's not the whole story.
Right. While the Earned Value Measurement System, or EVMS, which is obviously critical for tracking time and cost performance, is a key component. A modern PMIS is designed to capture and process that much broader set of value and risk-related metrics we just talked about.
So it's not just about managing the project schedule. It's about managing the project as a kind of business entity in its own right.
That's the perfect way to put it.
What are the strategic benefits, then, that organizations get when they design and implement a PMIS correctly?
The benefits are profound and structural. I mean, first, a well-designed PMIS ensures that various stakeholders get the information they need when they need it. Timely information is everything.
Right, not a report that's 2 weeks old.
Exactly. Second, and this is crucial, it must provide the correct amount of information. This is counterintuitive, but too much data can actually be paralyzing. It leads to information overload, where the critical details are hidden in all the noise.
And too little, of course, means you're flying blind.
Right, you can't make proactive decisions. It's the Goldilocks zone of information.
The Goldilocks zone, I like that.
Exactly. Furthermore, it dramatically lowers the administrative cost of information collection. It also provides key data on how the project interacts with the company's ongoing business initiatives, which prevents conflicts for resources. And it's absolutely vital in preventing project failure due to, derailed communications.
And I assume it has to be easy for the team to use.
It must be. That's the final point. It has to facilitate easy input for team members. If status reporting is too difficult or takes too long, people just won't do it, or they'll do it poorly, and then your data is garbage.
Now, here is where the concept truly modernizes. The PMIS is rarely a standalone tool anymore. It's integrating heavily with the Enterprise Resource Planning System, the ERP. Why is this integration not just helpful, but truly essential for modern strategy?
It's essential because of a fundamental realization that has swept through corporate strategy over the last decade. And that is that organizations are increasingly managing business by projects.
Meaning everything is a project.
Pretty much. The realization is that virtually everything an organization does, a marketing campaign, a product launch, even a simple organizational restructure, can be viewed through a project lens.
So if that's the reality.
Well, if that's the strategic reality, then the C-suite needs total visibility into both ongoing operational business processes and project processes. And those two worlds have to be perfectly coordinated.
And the ERP is the system that runs the day-to-day business.
Exactly. The ERP system is the enormous enterprise-wide hub designed to coordinate all resources, information, and tasks across the entire organization. Finance, HR, the supply chain, and increasingly, project management. The PMIS often becomes a sophisticated module integrated directly into the ERP system.
So it's not a separate island of data anymore.
Right. This integration allows information to flow seamlessly. It breaks down those traditional departmental silos that cause so many problems.
And if you had to pinpoint the most critical functional driver for making that PMIS ERP integration happen, I suspect it's all about capacity planning.
It is the absolute key driver, hands down. Capacity planning is the strategic necessity because functional managers, the people who actually own the employees, they have to allocate their people between two competing demands.
The day job and the project work.
The company's ongoing day-to-day business operations and the myriad of current and proposed project assignments. The ERP system is indispensable for making this complex allocation work effectively.
Can you walk us through that practical example in a bit more depth? How does that ERP-MyS connection prevent a project portfolio from being stacked with initiatives the company physically cannot staff?
Okay, sure. Think about the functional manager of, say, the engineering department. Let's say that department has 15 highly skilled engineers. The ERP system tracks what those engineers are doing in real time.
Not just on projects, but on everything.
On everything. It might report that 10 of those 15 employees are already committed to critical, ongoing, non-project business activities. Maintenance, technical support, regulatory compliance work, the stuff that keeps the lights on.
Right.
The ERP then relays that precise information to the integrated PMIS that only the remaining 5 employees are genuinely available for new project assignments.
But it's more than just a headcount, isn't it?
Oh, much deeper. That ERP data can be sophisticated enough to include the employee's specific pay grade, their specialized certifications, or their unique skill level. This is crucial data for project portfolio selection.
So you know not just who is free, but what they can actually do.
Exactly. If the project requires a senior engineer specializing in deep learning, and all 5 available employees are junior electrical engineers, the portfolio manager knows immediately that this project cannot be launched. Or at least, it must be heavily outsourced, even though the headcount was technically available.
That's a huge shift from the old way of just asking a manager, hey, can I have 2 of your people?
It is. This level of integrated capacity planning ensures that when a project is approved, the resources physically exist and they possess the right qualifications to execute it, all without crippling the day-to-day business. It turns resource allocation from a frantic political negotiation into an evidence-based decision.
That structural foundation is huge, and it allows us to move from the technological platform to the philosophy of measurement itself. Project metrics are the language stakeholders use to communicate project health. So before we even get into KPIs, let's revisit the core, almost philosophical principles of measurement. What's the simplest way to define a metric?
The simplest definition is really elegant in its simplicity. A metric is just something that is measured. That's it.
And from that simple idea, everything else flows.
Everything. The principles that flow from this are the core truths of management. If it cannot be measured, it cannot be managed. It's an old saying, but it's true. If you don't know where you are, you can't possibly know how to course correct.
And the other big one, what gets measured gets done.
That's the one that drives organizational behavior. If you measure bug counts, developers will focus on reducing bug counts. If you measure customer satisfaction, they'll focus on that. Measurement equals control. And a lack of measurement creates these huge managerial blind spots.
It's the difference between guessing and knowing.
Absolutely. Without good metrics, all decisions become those seat-of-the-pants guesses. They lack the evidence and the facts necessary for rational management. Good metrics are the only thing that facilitates truly proactive project management.
Right, so you're not just fighting fires.
Exactly. Instead of constantly reacting to crises that erupted last week, you are managing trends today so that the future disaster never even materializes. And it doesn't matter if the metrics are recorded as raw numbers, percentages, dollars, counts, or even qualitative ratings like good, bad, neutral. Their purpose is the same, providing that necessary feedback loop.
I find the insights from measurement experts like Douglas Hubbard fascinating because they challenge our instinct to just collect more data.
Hubbard's perspective is incredibly useful for calming managers who feel, completely overwhelmed by the idea of measurement.
Right, how can I possibly measure brand reputation?
Exactly. He points out two things. First, you have far more data than you think you do, even on those seemingly intangible things. And second, you often need far less data than you think you do to make an informed, confident decision.
That's so important. It dismantles the fear that it's an impossible task.
It does. It dismantles that paralyzing fear while simultaneously addressing the very real problem of data overload that we talked about with the PMIS. We're looking for the minimum amount of data required for maximum confidence.
So beyond simply providing control, what are the transformative organization-wide benefits that a company gets when it really commits to using metrics robustly?
They really become the foundation of organizational learning and continuous improvement. I mean, metrics tell us with the objective clarity, if we are hitting our targets, are we getting better? Or, and this is the most critical sign, are we getting worse?
They're an early warning system.
A powerful one. They allow for the early identification of issues. You catch a mistake when it's small and cheap to fix before it cascades into half a dozen other interdependent work packages.
It builds on itself over time.
It does. On a macro level, robust metric tracking dramatically improves the accuracy of future estimating. It raises the overall future performance of the entire project management office, the PMO.
And it lets us redefine what success even means.
Critically, yes. Metrics are what allow us to more accurately assess success and failure in terms that go beyond the ancient triple constraints of time, cost, and scope. They are the objective way to assess the project's current health and track our ability to meet the defined critical success factors.
Now, unlike stable long-term business metrics like annual revenue growth, project-based metrics are highly dynamic. They can and often must change during the project lifecycle. What drives that volatility?
It's because projects are temporary endeavors by definition, so their metrics are necessarily shorter term and highly susceptible to both external and internal shifts. The baseline agreement on which metrics to track has to be a joint venture.
It can't be dictated by the PM alone.
No. It must be established early in the planning phase between the project manager, the client, and all the key stakeholders. Everyone has to agree on what good looks like.
So what are some of the drivers for changing those metrics midstream?
Oh, they're numerous. There might be a change in how the company defines internal value halfway through a project. Maybe a new CEO comes in and pushes a huge sustainability agenda.
So the definition of value itself changes.
Right. Or there could be an update in the customer or contractor's joint definition of success in the statement of work. Or maybe a major technological breakthrough means a shift in the risk profile is warranted. Even updating the tracking software itself can mandate a change in metrics.
But the biggest one must be a change to the why.
That's the most significant driver, a fundamental change in the project's original business case assumptions. If the foundational reason for the project shifts, the metrics measuring its success must shift with it.
This brings us to the famous Goldilocks problem, finding the right number of metrics. This feels like where the entire metrics initiative often collapses. Stakeholders always want more data.
It's the constant battle against information paralysis. If you have too many metrics, you are automatically stealing valuable time from other essential project work just in the collection, maintenance, and reporting.
It's a huge administrative burden.
Huge. And more importantly, you create a fire hose of information for stakeholders, which prevents them from determining what is truly critical. The excessive volume limits the value of the report itself. It's the ultimate example of information overload hiding the vital signs.
And on the other side, if the PM overcompensates and selects too few,
then informed decision-making becomes dangerously difficult because you simply aren't provided with enough critical information to act proactively. You are, as we said, flying blind.
So how do you find that just right amount?
Organizations need crystal clear ground rules for metric selection. First, make sure every metric is actually worth the time and cost of collecting it. Second, ensure they're actively used in decision-making, not just collected and filed away.
They have to have a purpose.
They have to have a purpose.
Yeah.
Third, confirm they are genuinely informative, not just vanity metrics that make people feel good. And fourth, you have to dedicate resources to train the entire team on the value and the specific purpose of those metrics.
Even with those ground rules, we know metrics management often fails. What are the common failure modes that are rooted in organizational behavior or governance?
Many failures trace back to poor foundational governance, especially at the stakeholder or executive level. If the sponsors aren't aligned or they don't value the output, the system just collapses.
And slow decision-making can kill it, too.
Absolutely. Slow decision-making processes can render timely metrics completely useless. If the data points to a problem today, but the decision to act takes 2 weeks, the project has already suffered irreparable damage.
What about planning?
Another frequent cause is organizational delusion. Overly optimistic project plans or trying to accomplish far too much in far too little time. No measurement system can save a project that was designed to fail from the start.
The metrics will just show you're failing over and over.
Right, which leads to metric fatigue and people just start ignoring them. And finally, a poor understanding of how the metrics will actually be used. If they're collected as a compliance activity but never analyzed or acted upon or tied to rewards, it's a sure path to failure.
And the more complex the project,
the greater the organizational need and the subsequent difficulty for robust, meticulously governed metrics. Complexity demands discipline.
Okay, let's solidify the crucial distinction we've been hinting at. Metrics versus key performance indicators. If a metric is a generic measurement, like, say, the number of defects found per week, what elevates certain metrics to the level of key performance indicators?
The difference is all about strategy and actionability. A KPI is a specific, highly strategic metric. They serve as the organization's critical early warning signs.
They're the ones you can't afford to ignore.
That's it. They provide focused information specifically designed for informed decision-making about the future direction of the project. We can think of them as the project management equivalent of strategic intelligence, or SI, in the business world.
They answer a specific question, though.
They answer the question. Out of all the things we could measure, what are the 6 to 10 things that will truly make or break this project?
We really need to dissect the acronym KPI to truly grasp its weight. Let's start with key.
Key means the metric is a major contributor to the success or failure of the project. It has such an impact that its trend can literally make or break the outcome and the value realization. You would not use the word key for something trivial.
Okay, so it has to be vital. What about performance?
Performance means the metric must be measurable, quantifiable, and adjustable. But here is the critical part, the differentiator. It must be controllable.
Okay.
The user, typically the project manager or the functional manager monitoring that KPI, must be able to influence that metric directly to improve performance. They have to be able to pull a lever that changes the number.
Wait, let me challenge that for a second. If a KPI is key, a vital factor for success, but the PM lacks the authority to change the underlying issue, is that KPI truly useless to them?
That's a great challenge. And the answer is yes, it is useless as a performance management tool for that PM. It remains a critical metric for the project sponsor, who can make the necessary high-level trade-offs, but it fails the P-test for the operational team.
Can you give an example of that?
Sure. If you track user adoption rate as a KPI for a software project, which is absolutely key to delivering value, but the PM can't control the marketing budget or the necessary training resources needed to drive adoption.
They can't do anything about it.
They're simply reporting failure without the ability to fix it. This is a very common flaw in KPI selection. You're measuring a problem you have no power to solve.
That makes the connection between the KPI and organizational authority crystal clear. And finally, indicator.
Indicator simply means it provides a reasonable representation of the present status and, critically, how the current status will affect future performance. It's predictive.
We need to be careful not to confuse KPIs with other common project terms. They aren't targets, nor are they CSFs, though they're all related.
That's right. KPIs are not performance targets. They are the measurements that indicate if you are tracking toward or moving away from those targets.
And they aren't critical success factors.
They were not critical success factors, or CSFs. The CSFs are the prerequisites for success, the things that must be in place to achieve the objective. The KPI, however, may provide the leading indication that a CSF is about to be met, or more importantly, is about to fail.
So a leading indicator is a type of KPI.
Exactly. Leading indicators are themselves a type of KPI. They explicitly measure how current work will affect future outcomes. Standard earned value metrics, like schedule variance, SV, and cost performance index, CPI, are often elevated to KPI status precisely because they are predictive. They give you a forward-looking view of your time or cost at completion.
Beyond the standard EVMS metrics, what are some practical non-financial KPIs that a PM might use to track project health and strategic alignment?
We see a big shift toward indicators tied directly to risk, resource health, and stakeholder alignment. A few examples. The percent of work packages that adhere to both their scheduled duration and their budget.
That's a good one.
Or tracking the actual number of assigned resources versus the planned resources, which ties directly back into that ERP capacity planning we talked about.
And what about the customer?
Definitely. Customer satisfaction ratings taken at key milestones, not just at the end. The project complexity factor, which might be a weighted score based on team size, technology novelty, and dependency count.
What about assumptions? That seems critical.
One of the most crucial predictive KPIs is tracking the number or percent of critical assumptions that have changed since the project charter was approved. If the foundations of your project are shifting, that must be a KPI for the sponsor to watch.
The Permenter 10-80-10 rule seems like the perfect antidote to the track-everything mentality of most stakeholders. How does this framework help PMs narrow their focus down to that critical 10%?
David Parmenter's categories are designed to force a kind of strategic triage. The vast majority of stakeholders and team members instinctively want to track those generic performance indicators, the PIs. That's the 80% segment.
Right, the busy work metrics.
Kind of. Parmenter forces a distinction. You have results indicators, or RIs, that's 10%. These are lagging metrics. What have we accomplished? The outputs.
So the project is complete.
Right. Then you have the performance indicators, the PIs. That's the big 80%. These are the generic metrics that track daily work. They tell you if you are busy, but not necessarily if you are busy doing the right thing.
And then the crucial part.
And then the key performance indicators, the KPIs, the other 10%. This is the strategic focus. These are the critical few that, if you act on them quickly, can drastically increase the accomplishment of the core project objectives.
The challenge is getting the organization to focus on that 10%.
It is. The project manager's job is to persuade the organization that focusing on the 10% KPIs, the predictive, difficult ones, provides 80% of the strategic insight. Most organizations find that 6 to 10 KPIs is the sweet spot. More than 10 usually causes the strategic focus to just blur.
Let's talk about the characteristics of an effective KPI. We mentioned the SMART acronym for objectives, but you suggested its applicability to KPIs is questionable. Why is that?
The SMART, rule-specific, measurable, attainable, relevant, time-based, is fantastic for setting objectives. But when you apply it rigidly to performance indicators, it misses the single most important attribute. Attainability, for instance, is less relevant for a KPI than it is for an objective.
And that most important attribute is, again, actionability.
Absolutely. The KPI must be actionable. If the trend is unfavorable, if the KPI starts flashing red, the person responsible for monitoring it must know exactly what action is necessary to correct it.
And have the power to do it.
And they must have the authority and the resources to control the outcome. If the corrective action requires approval from 3 layers of management, or if the action falls outside the employee's functional authority, the KPI will fail to drive performance improvement. It just becomes a measurement of failure.
So what's a better checklist for a project KPI?
For project-oriented KPIs, we tend to stress characteristics like predictive, measurable, actionable, relevant, automated to minimize costly manual effort and human error, and critically, few in number.
Let's drill down into those failure points again. We've established that controllability is key. What are the common organizational reasons why even well-selected KPIs fail to improve performance?
We often see 3 major organizational flaws. First, as we said, the actions needed to regulate an unfavorable indication are beyond the authority or control of the employees doing the monitoring. It's a managerial mismatch.
The PM sees the problem but can't command the fix.
Right. The project manager sees the dip, but the fix requires a line manager to pull resources, and the PM has no peer-to-peer relationship or authority to command that action.
What's the second flaw?
Second, the KPIs might simply not be related to the employee's daily work or sphere of influence. If a programmer's KPI is overall corporate goodwill, they won't internalize it or act on it because it feels too abstract and distant.
And the third?
Third, if the rate of change of the KPI is too slow, say, it only moves quarterly, it is useless for managing daily or weekly work. It might be good for a strategic scorecard, but it won't help the team manage their day-to-day. And of course, identifying too many KPIs, exceeding that 10-point limit, ensures confusion and guarantees the strategic focus is lost entirely.
If the metric shift is about technology enabling data collection, then the value revolution is about what we deem to be successful in the first place. We've moved past profitability and quality as the sole definitions of success. What exactly drove this shift, and why is value now the reigning champion?
This shift is driven entirely by the customer. Traditionally, the PM defined success via profitability internal financial metrics. The customer defined it by quality.
But quality was hard to measure until the end.
Right, it was often only measured at closure. Today, clients and sponsors are fundamentally interested in the value they will receive upon completion and, more importantly, beyond.
So quality isn't the main thing anymore.
The strategic outlook has changed. Quality is now considered an attribute of value. It's a prerequisite for being in the game. It's necessary for survival, but it is no longer the true differentiator.
It's table stakes.
It's table stakes. Every competitor must produce high quality just to exist. What truly differentiates one project or firm from another are the other attributes that define value. Things like price point, speed of timing, the enhancement of image or reputation, customer service, and increasingly sustainability.
And the customer is making a trade-off.
Always. The customer's decision is based on their perceived value balanced against the price they pay.
So value is not a simple calculation. It's a complex, multifaceted equation involving tangible costs and intangible benefits.
Precisely. To manage projects successfully in this new paradigm, management has to internalize 5 core concepts. First, projects derive value from the benefits the organization accrues by achieving its stated goals, not just by creating deliverables.
It's about the outcome, not the output.
That's it. Second, projects must be viewed unequivocally as investments made by management, competing for scarce capital. Third, investors tolerate risk, which means, fourth, project value is fundamentally related to both the investment made and the specific risks you undertake to achieve it.
And the fifth concept.
And fifth, and most practically, value is always a delicate balance among 3 key project elements: performance, resource usage, and risk.
This strategic emphasis on value delivered compared to value expected is leading to a fascinating organizational convergence. The source material highlights the merging roles of the project manager and the business analyst. Why is that alignment now inevitable?
It's inevitable because the old definition of success meeting time and cost constraints now has very little bearing on actual business success. If you deliver a flawless product on budget, but it doesn't achieve the business outcome, the project failed. Period.
So success is no longer about hitting the plan.
Success is measured by the business value expected compared to the business value delivered over the long term. This means both the PM and the BA have to be laser-focused on maximizing that business value for the given time and cost constraints.
This means value-based metrics, or VBMs, are now mandatory.
They're a mandatory subset of KPIs for determining success. This is why we see high-performing organizations integrating the PM and BA roles, ensuring that the tracking and reporting of VBMs continues long after the construction team packs up.
You touched on the idea that VBMs must be tracked and reported to the client even beyond the formal project closure date. How does that typically manifest in contracts or reporting?
It creates a necessity for long-term accountability.
Right.
We see companies agree in the contract to monthly or quarterly reports that track the realization of the benefits.
Can you give an example?
Sure. If a project was designed to automate a process and reduce cycle time by 30%, the contractor might report monthly on the current cycle time reduction and the projected date when the client will achieve the expected return on investment.
So the reporting continues well after the project team is gone.
Right. That projected date often occurs significantly past the project closure date, extending the PM's scope of influence and accountability well into the client's operational phase. It ensures the focus remains solely on the realization of benefits, not just the delivery of a physical asset.
This is great when the value is tangible. A 30% reduction in cycle time is easy to measure, but the difficulty explodes when we attempt to measure intangible value. Reputation, goodwill, brand loyalty. Let's break down the measurement complexity here.
The complexity forces us to separate values into 2 groups. The easy, or soft tangible values, are expressed in classic quantitative terms. ROI, net present value, NPV, cash flow, market share, these are objective financial figures.
And then there's the other side.
Then there's the hard or intangible values, which are incredibly difficult. Stockholder satisfaction, customer satisfaction, employee retention, brand loyalty, goodwill, reputation. These are inherently subjective.
And the measurement problems are huge.
They're manifold. Even the tangible values rely on often undisclosed or overly optimistic assumptions, which can skew the decision to launch or continue a project. But the intangibles are the real challenge.
How so?
They're subjective, they often lack standardized, meaningful models for measurement, and they're frequently described as more of an art than a science. How do you put a dollar value on enhanced corporate reputation? You are often forced to use surrogate metrics, proxy measures, that hint at the intangible value but don't measure it directly.
This complexity leads to the three extreme schools of thought on value measurement, where organizations often fall into an all-or-nothing trap.
That's the danger of complexity. People retreat to ideological camps. School one insists that only ROI matters. It's 100% quantitative, and if you can't see it on the balance sheet, it's irrelevant.
The pure numbers camp.
Right. School two swings the other way, arguing that ROI is so easily manipulated by assumptions that only the intangibles matter. That's 100% qualitative.
And the third school.
School three is the reductionist view. If you can't measure it, forget it entirely. It doesn't matter.
But the effective approach is the deliberate compromise. How do we blend quantitative and qualitative assessments successfully across a project's lifecycle?
The best approach requires constant vigilance and flexibility. It is a compromise that demands we use quantitative assessment where possible, NPV, ROI, but supplement it heavily with qualitative methods for the intangibles, like stakeholder satisfaction surveys or internal audits of perceived goodwill.
So the type of measurement changes over time.
Exactly, it has to. Early in the project, when risk is high and the design is conceptual, a qualitative assessment of perceived value might be the most predictive. Later, during execution, quantitative checks on resource burn rate and earned value are necessary. Then, after completion, that long-term qualitative value realization tracking takes over. You have to be willing to switch measurement styles.
Since traditional EVMS focuses solely on time and cost metrics at completion, it seems clear a dedicated value management methodology, or VMM, is necessary to stress the value side of the equation.
Absolutely. The VMM forces the organization to manage the project as a true investment. It stresses value variables and introduces the concept of value or benefits at completion.
And this isn't just a one-time calculation.
No, it requires a periodic, rigorous reevaluation of the value expected versus the value currently projected throughout the entire project lifecycle.
Why, then, does this crucial periodic reevaluation of value so often fail in organizations?
There are several deep-seated organizational reasons. First, just a lack of a formal reexamination process. Management simply assumes the original business case still holds true.
Complacency.
Right. Second, management complacency or outright optimism. If other projects are highly profitable, they misinterpret that overall corporate success as validation that this specific project is also on track to deliver value, even if the internal metrics suggest otherwise.
And that can be a dangerous assumption.
Extremely dangerous. And third, misinterpreting high profits elsewhere as a license to ignore potential value degradation on the struggling project. The VMM, through its periodic reviews, helps the project manager and sponsor assess if value trade-offs are necessary.
It forces them to confront reality.
It forces them to confront reality and make difficult choices. For example, have new technological breakthroughs appeared that could drastically increase value if we spent slightly more? Or has a scarcity of skilled labor forced us to accept a lower level of quality, requiring a formal reduction in the value at completion projection?
Okay, so once we have all this complex data from operational metrics to strategic, value-based KPIs, we can't just bury it in a 50-page report. Executives and customers demand a visual, immediate display of critical information. This brings us to dashboards and scorecards.
Exactly. Visual communication is key.
And the simplest, most effective starting point is the classic operational dashboard, often using traffic light reporting. It's universally understood.
It's the baseline standard for rapid status communication. Red means a serious problem exists related to time, cost, quality, or scope, requiring immediate sponsorship intervention.
Yellow means be careful.
Yellow or amber signals caution. It indicates a potential future problem that the sponsor should be informed about, but no immediate action is required just yet. And green, of course, means progress is exactly as planned. No sponsor involvement is necessary.
And you can customize this system.
Of course. I recall an IT development group that used a 6-color system, including blue for pending external dependencies and purple for scope change currently undergoing approval. The point is visual acuity, conveying the maximum critical information with minimal time expenditure.
Despite their common usage, dashboard and scorecard are frequently used interchangeably. But according to experts like Wayne Eckerson, they serve fundamentally different audiences and purposes. How can we clearly differentiate them?
They differ primarily in their focus, their audience, and their temporal scale.
So let's start with dashboards.
Dashboards are the operational tools. Their purpose is to measure immediate, moment-to-moment performance against specific operational targets using right-time data.
Like the dashboard in your car.
Exactly like that. It tells you your current speed, fuel level, oil pressure. The users are supervisors, team leads, and operational specialists. The data focuses on events and is updated intraday, often with latency measured in minutes or hours. They are used by frontline workers to monitor core operational processes.
So the dashboard is reactive and operational. What about the scorecard?
The scorecard is the strategic tool. Its purpose is to chart progress toward achieving high-level strategic goals and long-term organizational objectives.
And the audience is different.
The users are executives and high-level managers. The data is based on summaries and periodic snapshots, updated monthly or quarterly more, like an annual financial report or a strategic map.
And they have more context.
Yes. Scorecards often utilize visual displays, but they are critically accompanied by textual commentary that interprets the performance, describes strategic actions taken in the last period, and forecasts future results. They track whether the organization is moving in the right strategic direction.
Eckerson goes further, breaking down the performance dashboards themselves into 3 types based on the level of strategic focus.
Yes. The 3 types represent increasing levels of organizational scope. The operational dashboard is all about monitoring. It provides highly detailed information, updated intraday, used by frontline staff to track core operations and manage immediate exceptions.
Then you have the tactical level.
The tactical dashboard is focused on analysis. It tracks departmental processes and projects, often comparing performance against established budgets or forecasts. Updates are usually daily or weekly, and its audience is middle management who need to analyze deviations and trends.
And finally, the strategic dashboard.
Finally, the strategic dashboard is focused on management. This monitors the execution of strategic, organization-wide objectives, often implemented through a balanced scorecard approach. These are typically updated weekly or monthly and are used by senior executives to align the entire organization.
This structure naturally brings us back to the idea of business intelligence, BI, versus strategic intelligence, SI. We can map these concepts perfectly onto our discussion of metrics and KPIs.
Absolutely. In the project environment, business intelligence, BI, represents the basic metrics. It is the surveillance and monitoring function. BI tells you what happened, what is happening now, and where your current numbers stand.
It's descriptive.
It's descriptive. It tracks operational data. Strategic intelligence, SI, on the other hand, represents the KPIs. This is the proactive, future-oriented function.
It's predictive.
It's predictive and prescriptive. SI moves beyond mere surveillance or strategic watch by actively producing recommendations and providing instructions for strategic decision-making. Where BI informs you about the present and immediate past, SI uses that information to inform you about what changes may be necessary in the future.
So that's where the PM becomes a true business partner.
That's it. This is where the project manager elevates their role from a tracker of metrics to a business-oriented manager driving strategic outcomes.
Metrics and KPIs are only effective if the excellent performance they measure can be sustained over time. And sustaining that performance requires rock-solid partnerships, both internal and external. Internally, the most critical relationship in any matrix organization is always between the project manager and the line manager.
This relationship is the very foundation of successful project management, and it has evolved significantly. Historically, PMs were chosen primarily for their technical command.
The best engineer became the project manager.
Exactly. They knew more about the engineering than anyone else. This often led to adversarial or at least poor working relationships with line managers who felt their resources were being dictated to them.
And as projects got more complex, that model broke down.
It had to. It became impossible for one PM to master all the technologies involved. The successful model that has emerged is the peer-to-peer partnership. Today, successful PMs and line managers view each other as equals. They share authority, responsibility, and accountability to ensure project success.
So it's about collaboration, not command.
It's a move away from command and control structures towards shared leadership. And the modern project management methodology has to actively emphasize and reward this cooperative relationship.
And the external partnerships, particularly with suppliers, have become equally critical due to outsourcing trends.
Outsourcing is endemic now. It's necessary for speed and competitive pricing. External partnerships with suppliers, if you manage them correctly, can provide significant long-term benefits to both the customer and the contractor.
So their performance is now part of your performance.
Absolutely. Their performance is now integral to the organization's success, which means supplier performance metrics, delivery timeliness, quality checks, cost adherence must be included directly in the overall project success metrics. They are, in essence, an extension of your team.
And their performance needs KPI scrutiny, just like your internal resources.
Exactly.
The other key to sustained excellence is the constant pursuit of continuous improvement, and the source material offers a strong warning against the danger of complacency.
Complacency is arguably the single greatest threat to a sustained competitive advantage. When a firm achieves a degree of excellence, say, through superior project execution that reduces time to market, and begins exploiting that advantage.
The competition doesn't just sit still.
They never do. They inevitably counterattack by copying or leapfrogging your methods. If the firm fails to recognize the absolute necessity of continuous improvement, it will quickly lose its advantage. Sustained performance requires perpetually iterating and improving methodologies and metrics, even when performance looks excellent on paper.
A vital part of this improvement cycle happens at the very end of the project. Contractual closure, followed by administrative closure. What's the difference, and why is administrative closure so crucial for performance improvement?
Contractual closure is the legal and technical verification that all deliverables have been accepted by the buyer. It signals the end of the contracted work. Administrative closure is where the learning happens. It is the strategic function.
This is the lessons learned part.
It is, but it's more formal than that. Administrative closure involves several crucial steps essential for performance improvement. Documenting a formal debrief of the seller's overall performance, documenting the seller's performance for future source selections.
So you know who to work with next time.
Exactly. It involves identifying explicit room for improvement on future contracts and, critically, performing a robust lessons learned review to identify and archive best practices. These archived best practices are what feed into the continuous improvement mechanism for the next generation of projects.
And there's a small but financially critical procedural detail regarding the order of these closures.
Yes, and it's one people get wrong all the time. Financial closure, closing out all open charge numbers and accounts, must always follow contractual closure.
Why is that so important?
If financial closure occurs first, and the buyer later finds a defect or requires a repair that falls under warranty or existing contract terms, the project manager faces the huge administrative headache of reopening charge numbers and potentially back-charging costs. It's a bureaucratic nightmare. Contractual and administrative sign-off must precede the financial closeout.
Finally, let's go back to the very front end of the process, the interaction between proposal development and the contract terms. Metrics and performance management are fundamentally baked in right from the moment of negotiation.
This is where everything starts to go right or wrong. It is absolutely critical that contract terms and conditions be thoroughly reviewed and formally approved before the proposal is ever submitted to the client.
And this isn't a solo effort.
No, it's a multi-departmental effort. It involves a contract representative working with the proposal manager, legal, insurance, tax, engineering, and estimating departments. They have to collectively define everything up front.
And the most important part of that,
the single most critical step at this early stage, is accurately and realistically defining the scope of work covered by the contract. An inadequate, overly optimistic, or unrealistic description of the work to be undertaken marks the beginning of an unhappy, unmanageable contract experience.
It doesn't matter how good your metrics are if the scope is wrong.
Exactly. The metrics can only track the performance of the scope you defined. If the scope was wrong from the start, the project is doomed before it even begins. So, to summarize this deep dive, I think it's clear we have definitively transitioned project performance measurement from a simplistic accounting function, just tracking time and cost, into a proactive strategic tool.
It's a whole new mindset.
It is. We manage complex technological ecosystems, integrating PMIS with ERP, which are now focused entirely on delivering maximum business value and strategic benefits. Success today isn't about mere timely delivery. It's about ensuring the project realizes the right value, measured rigorously and proactively through a small, focused set of actionable key performance indicators.
The essential takeaway here, then, is that measurement is no longer a burdensome administrative task. It's not something you do just to satisfy a compliance audit or an accounting department.
Not at all.
It is the vital engine for proactive management, the fuel for organizational learning and continuous improvement, and, most powerfully, the mechanism for achieving total strategic alignment across the entire enterprise. From the real-time data on the operational dashboards used by the team, all the way up to the summarized performance on the strategic scorecards viewed by the C-suite. Measurement is strategy.
Well said.
This leaves us with a final provocative thought for you to mull over. Given that intangible values, things like reputation, brand loyalty, and customer goodwill, are now considered critical differentiators for project success, and yet their measurement is still widely described as more art than a science. If the most strategically vital metrics are inherently subjective, how much confidence should management truly place in purely quantitative metrics alone when making critical future investment decisions?
That's the real question, isn't it?
Is the currently accepted compromise between quantitative and qualitative assessment of value the only way forward? Or will future project management require an entirely new framework that embraces rather than merely tolerates inherently subjective measures of success?